Welcome everyone to this course in Python programming. My name is Saurabh and in this tutorial we are going to focus on each and every important concept of Python. So without wasting any time, let us move forward and have a look at the agenda for today. So this is what we'll be discussing today. We'll begin by understanding what is Python, how it works, how we can install Python. Then we'll understand what are the sequences and file operations in Python. Next up, we are going to focus on functions and OOPS concepts. After that, we'll be working with modules and how we can handle exceptions in Python. Then you will be introduced to a couple of very important libraries called NumPy and Pandas. After that, you'll understand how you can perform data visualization using Matplotlib. Then you will understand how you can perform data manipulation using all the three libraries that I've just mentioned. After that, we are going to develop really cool applications. One is web maps using Folium, another is motion detector using OpenCV. So I hope you guys found the agenda very interesting. And Mr. Varun will be the instructor for this particular session. He has rich experience in working with Python. Over to you, Varun.
Hi everyone, I will be your instructor for this course. My name is Varun. Introduction to Python. So the question is, which programming language should you start with? And I mean, of course, you have already started with one as part of this course, but in Day's opinion, and in my opinion, it has to be Python. Simply because it is very, very simple and easy to learn. In a few moments, when we start looking at Python code, you will notice how it looks like English. It doesn't even look like code. So when people hear the word code, they start thinking of ones and zeros, or they start thinking about, oh, it's going to be like a puzzle that you have to solve. Nothing of that sort, really. It's just a set of detailed instructions. Like if you can write instructions about how to send a email, or so about how to send a post mail, if you can write very, very detailed instructions about how to send a post mail, you can probably code. It's like that. Next is that it is free and open source. So in the sense that you don't have to pay anybody money for using Python. Now, one question might be that, hey, I mean, what's new about that? I don't need to pay anybody to speak English, and English is a language. But the thing is that English, Spanish, French, these languages, there is no creator of these languages, right? They are commonly developed. So nobody really owns English as a language. Nobody has a right to English. Whereas if you look at programming languages, they're created by a small set of people, 10, 15, 50, 100 people, right? 100 people is not a big group of people. It's relatively small as compared to people who developed English, right? People who developed English words would be the authors, the writers, and the regular folks as well. So that number would be millions of people who have developed the language. So open source is a concept in software programming. I strongly suggest that you go on YouTube and search for open source. You will come across some very neat documentaries. I suggest you have a look at them. But comparing this with sort of what is paid for, so MATLAB has a version which is paid for, which has some extra functionality which you need to pay for. But Python is free completely. A lot of Python libraries are available for free, right? There is a language called Wolfram, WOLF, like a wolf, RAM, which is very expensive. You need to buy a license. You can't just use it. It's not allowed. It's like Windows. You need to pay a license fee to use it. Now, it's a high level language. So believe it or not, but the first three lines over here are actually valid Python code, right? Forget the fourth one. Some of you might be able to understand that itself, but the first three lines are valid Python code. That's why Python. You don't have to deal with the right side. Don't think about this. You're never, almost never going to look at this and be supposed to figure out, oh, what does this mean? You're only supposed to look at stuff like this and say, okay, what does this mean? Then it's portable. Portable being that you can use it on multiple kinds of devices, whether that's a Windows device or a Linux device. Python is very compatible that way. It will run on different devices. It supports different programming paradigms. So paradigm is just a fancy word for styles. If you're a beginner in programming, don't bother with it unless and until you have, had 600 to 1000 hours of programming under you. Don't bother with it at all. Okay? This is not relevant for you. However, if you have some experience with programming and you know what a programming paradigm is, just know that Python supports multiple. And for those of you who don't know about it, don't worry about it. You will get there eventually. I'm not saying it's not important. It is important. It's just that right now it's like running. Like right now, if writing a line of code is the starting point, it's like stumbling or crawling. Thinking about paradigms and styles of programming is kind of like running. So I would not recommend thinking about it too much. Next is Python is extensible in the sense that you can invoke C and C++ libraries from Python. So you can sort of call code of other languages using Python. So that way it is very extensible, increases the usability of it, makes it work with other systems. So Python is also used widely by a lot of companies. Let us look at a few of the giants. So this would include YouTube, Google, Dropbox, Raspberry Pi, BitTorrent, NASA, Netflix, NSA, and I mean it's like amazing, right? I mean, you look at how varied and wide different these companies are. There's from internet companies to, national space agencies to national security agencies. Really, the breadth and the depth of it, and it's being used by all of them in some way or the other. So it's not that you shouldn't say that, hey, Google is built on Python. No, Google uses 10 languages. It's a huge company, right? Same for Dropbox. Oh, by the way, the creator of Python works for Dropbox. He actually does work for Dropbox. And he has it in his contract that he will devote a certain percentage of his time, like it's about 30 or 40% of his time, for developing Python. So that is something he got as a part of his job contract. Of course, he's a very celebrated person that way. Not regular people like me, or I guess you as well, can't really negotiate something like that. But yeah, he did, because he's the creator of Python, right? But yeah, the point is that the best of the places, from the Silicon Valleys to the government agencies, they are using Python. Now, the best part, yes, this is my favorite part, because Python really works for most of the things out there. Like, you want to develop a website, you can use Python. You want to do data analysis, you want to do data science, you can use Python. You want to do automation testing, you can use Python Selenium. You want to do collect data from the internet, which is web scraping, that is extract data from the websites, you can use Python. Now, one cautious thing, you don't need to do all of the things to say that you are a Pythonist or a Python developer. Like, for example, I've never done this one, type testing. I've not never really done scraping as well. I know how it is done, but the point to note is that there are very slight differences between these. It isn't that you have to learn an entirely new thing when you are doing this versus this. You have to learn the concepts related to it, but that's more like business logic rather than programming logic is completely changed. Right, the golden question on a lot of people's mind. Are there Python jobs in the industry? So this is a job train from Indeed.com. Don't focus on the small percentages. Yes, I know they're small, but they are of the total number of jobs. Okay, they're not just, it says 0.85%, but it's of probably 10 million or 15 million job postings. So you can notice how the trend is good for Python. It's going a little sideways, but then it keeps surging, that it keeps doing that. But if you compare it to PHP or C++, definitely a huge difference. And then, of course, the popularity. So this is even more relevant. How much is the community developing? So this indicates, the Google Trends would indicate both searches using the word Python, either by experience or by new people or by industry. So even if I have to hire Python developers, I might go to Google and say hire Python developers, and then it would show up here. So this is an overall accumulation. This is a summation of how popular Python is compared to other languages. Like these indexes, 9966, so on and so forth. These are indicative of that. So let's look at how to install Python, right? So we have sort of understood till this point what is Python, why it is used, what is programming, why it is used. Let's look at how to get started. Now, to get started, the first thing is to, of course, buy the car, buy the or get the Python. You go to python.org, you go to the downloads tab, and you download the latest version of Python. 3.6, 3.x is the latest version. 2.x is also out there. It's being used by a lot of projects. Even my projects these days use 2.x because they're like 12 to 15 months old now, the current projects that I'm working on. So, I mean, it isn't that you do 2.x. So, it isn't that for a beginner in Python specifically, you would find a massive amount of difference between a 2.x and a 3.x. I mean, it's like, having a car and then its sports version of that car, or the plus version or the luxury version of a car. The differences are minor for a regular user, but if you are a power user, then of course you might find significant differences. But don't be confused by it. It's not that companies turn away developers who know Python 2.7 and don't know the latest version. The job market doesn't work like that. They will go for Python. They will ask you if you know Python, and then the version difference doesn't really make too much of a difference. You run on the open the installer and click on run. Click on install now. This is very important. In case you have already installed Python and you forgot or you unchecked this for some reason, please go back, uninstall Python and reinstall it, and make sure that you have selected this box. Nothing will work if you don't do this. Okay? So please, 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 please follow the step. And that's it, you're done. As easy as that. You have Python on your system now. There's a Python GUI available for you. Now, next is Python IDE. So, one question is, what is an IDE? So, IDE is an integrated development environment. It is used as a code editor, including a series of peripheral components and attachments. So, fancy words aside, if you can ask me, hey, can I write code or can I write Python in a notepad or a Word doc? My answer to that question would be yes, you can. Now, if you ask me, should I write code in Notepad? My answer to that would be no. Please don't. Never. Right? So you get the difference. You can do it, but you should definitely not do it. So it's not that your code wouldn't run or something of that sort. It's just that IDEs are tools which are meant for doing this. Okay? They are specialized development environments for you to code in. It helps you in certain ways that makes sense, right? Because programming can be very difficult without them. So definitely, please choose an ID, stick to it. One thing that you notice, there are line numbers. These are very, very useful, by the way. As you will experience, if you're talking to another developer, the best way to talk to them is line number 3. There's an error on this particular line. Can you start reading from this line to this line? That's how I deal with n number of situations, okay, where I would talk about a certain line number. Okay, let's open something called as a terminal. So on Mac and Linux, this will be called the terminal. On Windows, this is called as CMD. Okay, you need to search for CMD. Once you've installed Python, what you can simply do is type Python on the command line and press enter. And it opens the Python interpreter. I can write Python code right here and it will work. So this is valid Python code. Okay, and it comes with the help function. So if I type help followed by braces, it will launch help for me. And if I type in keywords, right? So there are certain things called as keywords in programming. Let me just zoom into it. Yeah, this is how I can exit from Python. Look at the definition. So let's get started. As I showed to you, this is how you can open the Python interpreter. You just need to go on the particular page and type Python and it will open it up. Let's come to PyCharm for a minute. In PyCharm, the way it works is that, of course, I already have this, but in case you would not have this, so let's just remove it altogether. What you need to do is you need to create a new project and then you need to give it a name. The name could be test, right? And you do a create. So I'm going to open it in the current window, right? Once it's in the current window, what I can do is that I can go to new and then I can select Python file and I can give it a name. And automatically it creates a test.py. It adds the py extension by itself and it stores it. Even if you go into your system and you will see that it has been created. And you can just start writing your Python code over here. Now, programming has something called as comments. So a lot of times what happens is that you will write a piece of code, but you will forget what it does. And it's not something that only you go through. It's a standard thing. Even if I write code, I can bet my life on it that 3 days later I would have forgotten about 80% of it. Like I would know what it does, but if it's more than 100 lines, I would have to read through it. Okay. Now, what developers do in this for this situation is that they add comments. Comments are nothing but simple English explanations for what you have done so that you don't need to remind yourself again and again of what this particular thing does. It just helps you keep a track of, it's like notes, it's like small notes, and the programming language will basically ignore them. Now, there are two ways to write comments. So, this is a new Python file for the class. Okay, now that's it. This is not valid Python code. This is not code, this is English. Okay, this is one way to write it. Other way to write it is using 3 single quotes and you write it like this. This is a new Python file for the class. Okay, these are the two ways you can do it. And the purpose is basically to just remind yourself or to other developers. So this is one thing that a lot of people, when they're starting off, your code will be viewed by other developers at some point. You will start sharing your code either within a company or otherwise. So when they look at your code, they should be able to understand from your comments what it does. Not just the whole file, not like a description that this file saves something to the database, but like what each and every step is along the way. So like for every 10-20 lines of code, probably one comment should be there. That's like a best practice. So next is indentation. Now you need to think about this in the way that Python follows indentation like comment system on social network websites. So if you have ever seen Reddit, let me just open it up actually. Okay. So if you look at Reddit, if we go to the comment section, okay, so you will see that there is a nesting, right? You can know that, okay, aha bali is being responded to by a retarded clown face, or this guy is being replied to by this, but this guy is being replied to by this, and this guy is being replied to by this guy, so on and so forth, right? It's a nesting. You can see that there is a division. You can see that this comment is a reply to this comment, and this is something that we see everywhere. We see this on Facebook, we see this on Instagram, everywhere. Now, this is how Python sort of declares blocks of code. Okay. So, in case you're not familiar with what blocks or closures are, it's okay. We're going to come across it when we go further in Python. But just remember that indentation is a very important concept in Python. And this is how closures or blocks of code are defined. So how does Python code execution happen? So you write code and it is saved with a py extension, like I just showed it to you, right? The code is converted into bytecode for machine to understand. That's done by the Python compiler or the interpreter. You don't need to worry about this step. It happens automatically as you run the file and it gets executed. So you just need to care about step 1, 2 and 3 are taken care of by automatically. It's not something that you have to do much about. So let's create a first hello world program in Python. Okay. So how do we write hello world? How do we greet the world? Well, this is how we do it. As simple as this. Print, opening braces, then a string. Okay. This is a string. You can't write this. This will not work. Okay. If you see, this is already showing an error. And of course, this is where Python is smart. PyCharm is smart. If you notice, it has underlined this file. It has underlined the folder containing it. It is just telling you without before you even run it that this is not going to work. So anytime you're printing string, a string being anything which is like a message, right? It needs to be within strings, okay? And you use the print statement, use the the brace opening and the brace closing like this. If you miss the brace, it won't work. You have to include it, right? And then let's run it. So the way to run it is you right click and then you click on run hello, where it is referring to the name of the file. And this is where it will run. This terminal is already present. Hello world gets printed 2 times, right? Hello welcome to Edureka gets printed. And then something odd happens. Happy learning, welcome to Edureka. This gets printed on 2 different lines. Why is that? We just wrote a single line. So this is where this comes in. Backward slash n. This is what is called as a break line character. It will break the line. So this is like if you're typing in a Word doc and you press enter, right? It goes to the next line. It's a new line character. If I type it 2 times, so we should expect 2 spaces, right? Yeah. So if you notice, it has gone 2 spaces deep. If we do it another time, or let's suppose we do it 4 times, and we save and we run, it goes even further. And the reason why it is not appearing in the same line is because there is a space character here. So if I just do it like this, then it will start coming in the same line. Now see, it adjusted. So this is how you do it. So it could be single quotes or double quotes, doesn't matter, but I would suggest following one of them. Okay. And this is the output you will get after running the file. Next is variables. So variables are pretty much like mathematics variables over here. You take a particular name that you want to give it. So you want to set A as 10, you want to set B as Edureka, right? This is an integer in Python, this is a string. Notice that now we're using single string as compared to double quote. Okay. You can do print AB, A comma B, and notice the comma. So even here, right, for example, I could have done this and this would have worked. So print, you can separate multiple strings or things that you want to print by a comma. So you see, both of them get printed. Now let's come here and let's print this. So 10 and Edureka both get printed. Of course, they're coming with these braces. So in case you want to just print them individually, that's a separate thing, right? I mean that you will have to do separately. But in case you just want to see the values on your terminal, this is the way to do it. Now another example over here is this one. So what this will do is that it will move in order. It will assign x to 10, y to 20 and z to 30. Let's try it out. Okay. Now, of course, this is a very convenient way of doing it. Now, the alternate way of doing it, of course, you can always do it like this as well. But it's just that, it increases the vertical length of your file I don't find it to be neat, and you will see experienced developers doing this quite a bit. It's just more convenient. It just comes in a single line. That's it. It's just a matter of convenience. Otherwise, this is also correct and this is also correct. Correctness is there. It's just that line number 9 is better than doing it in 3 lines. This is more concise. Okay. Now, a word about identifiers. Now, where this is an identifier. So, when you hear the word identifier, A and B are identifiers. They're identifying a particular variable name for you. Now, there are certain rules around it. It is used to identify a variable, function, class, module, or any other object, right? It starts with the letter A to Z, or A to Z, capital or small, or an underscore, and followed by digits 0 to 9. So you can't start a variable with a digit like this. It shows an error. But what you can do is you can do this, or you can do this. This works, but doing this won't work. So this underscore b underscore b, right? And all of this, they are valid identifiers. But you can't start it with anything else apart from letter A to Z, capital or small, underscore. You can't start with the digits. And Python doesn't allow special symbols like at the rate, dollar, percentage, star, braces, exclamation mark with an identifier. Now, there are certain naming conventions in Python. There is something called as a class in Python. It's a concept. Maybe some of you are familiar from other programming languages. It starts with an uppercase letter, and all other identifiers will start with a lowercase. So only the class name start with an uppercase. Now, there are certain other rules as well. They are related to classes. So I think it would be better if we cover them then. Okay, so all of these things like that, the identifier is private, strongly private, two trailing underscores. Now, all of these are some concepts that we will learn later. Let's leave them for that. But for now, you just need to know that, okay, this is how you name a variable in Python or in an identifier. Now, how are variables stored? So they are reserved memory locations. What happens is that in the computer's memory, which is the RAM, right? It creates a space and stores that variable in the memory, and it reserves some bytes for it. That's it. That's all is happening. It's just remembering them, storing them. So it's not that while I'm writing, it is doing that. It is when I'm running the file. Okay. So it is not going to do that right now as soon as you create it. So don't think that if you create too many variables, your typing speed will slow down or your laptop will start hanging up. No, I mean, it might do that, but when you're running the file, and it might be for different reasons than just, simply having too many variables. So, but just notice that this is just an instruction. Okay, this is just nothing but like instructions. When you run it, that's when it really does something on the computer. Right now you're just typing it like a notepad document, and you know I'm pressing control S. But when I run it, and by run I mean I do go ahead and do this, that's when it goes to memory and it does all of these things. Yeah, so we have already covered this, right, where we run it and then the values get printed. Now let's look at some standard data types available in Python. And even before that, let's try to understand what is meant by a data type. Now, a data type is basically a way to say that something is an integer, something is a string, something like what kind of a data it is, whether it is a numeral or it is a string or it is a boolean or something else or something else. So Python has two kinds of data types, or any programming language for that. One is immutable and the other one is mutable. So the word mutable or immutable comes from, you need to think of mutation, the one that you might have studied in biology. Mutation fundamentally means change. So mutable data type would say that it can be changed, okay? That the data can be changed. Immutable is that it cannot be changed. So something like a list, dictionary, or sets, these are some things that we're going to study. They can be changed, but immutable data types, such as numbers, strings, or tuples, they cannot be changed. Now, one source of confusion that you might have is you might be thinking, so if I do a is equal to 121 like this, and then I do a is equal to 121, or let's suppose, right, I do this and then I do a is equal to 3, then this should not happen, right? Because a is an integer and you're changing it. I'm first setting it to a random value 121 and then I'm setting it to 3. But that is not what it means. What it means is that, see, this is just an identifier. This is not the data. The data is on the right side of this. So when it says that it is immutable, what it means to say is that whatever you do, you cannot turn 1 to 1 into 3, which if you think about it makes sense, right? So this is the level of depth, by the way, that happens in programming. Something as obvious that 1 is not equal to 2 or 121 is not equal to 3, it cannot be 3. It is just that this is a different thing in the world and this is a different thing in the world. There is no way that you can convert this into this. Like you cannot convert gold into silver. So gold is immutable. Okay? Gold is immutable, where you cannot turn it into silver. You cannot turn it into any other element. But then there are certain things in the world which are mutable, that you can take them and turn them from one thing to another thing. So, for example, you can take a seed and turn it into a tree. That's mutation. But if you're trying to mutate gold into a tree or gold into silver, it will not happen. It will remain gold. Even if you mix impurities in it, right? It will be impure gold, but it will still be gold. So you need to think of it like that. It's a very basic concept, but it's something which is there across programming, that the entity cannot change. Now let's talk about the immutable data types: numbers, strings, and tuples. Now Python supports three different kind of numeric values: integers, which are signed, so you can add a plus or a minus in front of that. There are floats, which are real numbers, decimals, and then there are complex numbers. And when it comes to representing numbers, you can represent them in three different ways: binary, octal, or hexadecimal. Okay. However, please note that you typically would not be using these representations. Typically, you would be using numbers like you use them normally, right? So to define an integer, you set a is equal to 10. To define a float, you set b is equal to 10.65. And for complex numbers, so in case you remember this or you're familiar with this is 10 plus 6j, right? This is the imaginary value, and it will output it like this. Let's quickly have a look, right? So we have the same file here. Let's run it, and it outputs like 10 plus 6j. If I do 10 is equal to 5 plus 4j and I print d minus c, let's see what do I get. So if you see, it has done a subtraction. 5 minus 10 is minus 5, 4 minus 6 is minus 2, and I get a result. So next is strings. The continuous set of characters represented within any quotation is called a string. So whether it is single or it is double quotes. Now Python does not support a character type. Now this is basically coming from other languages which have something called as char as a character. Python doesn't have that. Python just has continuous strings. In case you're not familiar with character, it is okay with character data type. It is not referring to character in the generic way of alphabets. It is referring to it in the programming context, where there is something called as a character. It's char data type, which is present in Java, C++, so on and so forth. Python doesn't have it. Python just has strings. It cannot differentiate between single and double quotes, or does not differentiate between single and double quotes. And as we have already tried it, this works for us, right? We have already done the print statements using strings. Next is tuple. So a tuple is a fixed list, okay, and it comes within parentheses. So for example, even this right now, the way it is printing, it's a tuple. If you look at this is a tuple. And yeah, so I can do this. Now notice this, okay, so I can print this and this will run. Okay, now I can also do the following with a tuple. I can print an individual element. I can print the 0th element. So these are 0 indexed, meaning, or let me rather change it. So let's suppose these are 4, right? So instead of saying that this is the first and the second and the third, it works with a 0 index. It says this is the 0th, this is the first, and this is the second. Now I can do this as well. So this is me reading an individual element of the tuple 4, 5, 6. However, notice if I try to do this, PyCharm has already highlighted this. It has a problem with it. If you hover over it, it is saying that tuples don't support item assignment, which is basically meaning that, hey, you can't do this. You cannot change it. I cannot change it. So let me run it. It is throwing an error. It is throwing an error. Tuple object does not support item assignment. So I'm trying to change this data type. It's like I'm trying to change gold into silver. I'm saying, sorry, can't do that. That's not possible. You cannot modify this. Now let's look at the mutable data types. The first one is a list. So we just saw a tuple. It seemed like a list of items, right? So, but it was called a tuple. But Python also has something called a list. Now, list can contain various elements, n number of elements. If you want to create an empty list, this is how you create one. Square bracket. open and close. This is an empty list with zero things in it. And this is a list with 1, 2, 3, and 4 things in it. Now, if you notice, all of these are different types of data. This is a decimal, this is an integer, and this is a string. You can print a list, and pretty much like a tuple, you can access any element within it. So let's run this, right? What you can also do is that you can update it. So we can set a1 is equal to changed first second element, right? So because for this is zero again, this is zero indexed again, by the way. Like tuple was zero indexed, this is also zero indexed. Zero indexed being that this is referred to as zero. It doesn't count it as one. So that is generally how things work in programming. Almost all programming languages have it this way. So if you see, I changed the second element. So the same thing was throwing an error in a tuple, but in a list, it is doing it in this certain way. It is allowing me to modify. Now the list can contain other lists as well. So you can also do this, and you can also do you know 4 and then third element, and it can also contain tuples. So it can also contain a tuple inside it. Now this is a particularly complicated example of, not complicated, but something that you would normally encounter, but I'm just trying to showcase it to make a point that a list can be of anything. So think about the English word list, right? It can be of anything. So what I've done here is that I've said the 0th element, which is this, which is a list, give me the second one. So it gives me 4. If I say 1 and then I run it, it will give me 2. I can run it on the first one as well, and yeah, it will give me 4. If I need to access the tuple, think about which element it is. 0, 1, 2, 3, right? If I want to print 5, then I'll do this. P3, 2. Yeah, so I'm just counting. I'm counting 0, 1, 2, 3. Okay, I got the tuple till this point. After that, I want to access 5, which is 0, 1, 2. So I go to 2. Now, slight differences. Lists are between square brackets, tuples are between parentheses. Lists are mutable, tuples are immutable. Tuples are faster than lists. I think that's owing to the immutable nature of it. But that's not the real reason why you would use a tuple. You would use a tuple if you want to have a fixed value. So if, let's suppose, you are making a simple calculator, which can do scientific calculations. Let's suppose by using the value of pi and scientific constants. So it can calculate the area of a circle or a sphere or a cone or whatever. And it needs to use 3.14, the value of pi and other constants. And you need to maintain that, and you need to ensure that it is not modified accidentally by you while you're programming. That is when you would use a tuple. Or you would use a tuple if you had to maintain a list of countries, because you don't want the list of countries to get changed. You don't want accidentally, while you're coding, you end up changing an element within that list, because it will cause a lot of problems. So basically, to understand why, you need to also think about and understand why immutable data types are needed. Because if you look at lists and tuples, the only difference really here is, so by the way, I can do this with a tuple as well. I can do the very same thing. I can simply do this, see, and I can run it, and it will work as it is. It just did. It just printed the element, right? Now, the only difference is that lists are slower, but more importantly, lists are mutable. So mostly you would find yourself dealing with 90-95% of the cases, you will find yourself dealing with lists rather than tuples. Tuples are needed for very specific scenarios. So don't get confused by why do I have two, can I use either one of them? Focus on lists for now. Tuples will naturally come to you when you are presented with a scenario. Okay, so tuples are more in the niche where they are for a very particular case. Next are dictionaries. So dictionary, as the name suggests, it is like you would go through a dictionary, right? What is the meaning of the word naive? What is the meaning of the word precarious? What is the meaning of the word apple? So on and so forth. And against every word, you would have a meaning. So the word is like a key, and the explanation is like a value. So this is a key, age is a key, this is the value, this is a key, this is a value. If you look at it, this is very readable. They're separated by colons, okay? And the need to use this is that it makes your data very readable. Key value pairs is something which comes naturally. So if you look at a web form, any sign up form that you have ever filled, right? It asks for an email and a password. Now imagine that being stored here. So in the sense, let's open this up, right? So this is being handled like this. Now, suppose you can also argue that, hey, I can also store it like this. Why shouldn't I store it like this? I mean, I can just store it like this, and instead of, doing, oh, by the way, so what you would have done over here is you would have used square brackets and then you would have typed the key. So let's run this once, right? Same output. So you can argue, hey, why wouldn't I use a list or a tuple? Why would I use this? So one primary reason why you would not do this is because this is way more readable. So imagine 100 lines of code. Imagine this was declared on line 1 and you're using this on line 100. You don't know what is 0. You have to constantly refer to what is being stored at 0. But if you look at it, you immediately like, oh, okay, you're trying to print the age. So for developer readability, dictionaries are way better. Okay. And you will find that you will use these a lot as well. And once again, so the keys have to be string. Okay, the keys have to be strings, but the values can be anything. The values can be anything, in the sense that it could be an array as well, or it could be, you know a dictionary as well. So dictionary within a dictionary, and array within a dictionary, all of them can be mixed and matched, right? Last one is sets. It's an unordered collection of items. Every element is unique, and you use curly braces separated by a comma. Okay, and if you notice, right, if you try it out, once you finally, so you might assign it, but it will automatically just print or consider the unique ones. That's it. It wouldn't bother with the non-unique ones. Okay, next is Python operators. So operators being any sort of operation on your data types. So 2 plus 3 is equal to 5, where 2 and 3 are operands, and plus is called as an operator. Arithmetic, assignment, comparison, logical, bitwise, identity, and membership. These are the different kinds of operators. Let's go through them one by one. First one is arithmetic, quite simple, that we have done in maths. A plus b, a minus b, a star b, a division b. This gives you the remainder. So this is called as a modulus operator. Let me quickly show it to you. This gives 0. 4 modulus 5 gives us 4. And then of course there's 4 plus 5, and there is 4 minus 5, right? Exponent is 2 raised to the power 3, or 2 raised to the power 2. Sorry, I misprinted that. Yeah, 2 raised to the power 2, 4. And then there is floor division, which is, so this is float division. Okay, this will return the float. Now assigns value from right to left. So first this will be calculated and then this will be assigned. So if this seems confusing to you, it starts from the right. It doesn't start from the left. So it isn't that it will get confused between what to do. It will do a plus b and then reassign it to a. It will do a minus b and then reassign it to a, and a star b, and a division by b. And what is written over here is a shorthand notation. So in Python, you could, let's suppose I had a is 2 and b is equal to 3. Now I could do a is equal to a plus b, okay, and then a is 5. Or I can also do a plus is equal to b, and then a is 8. So this is because I added again. I can do it like this again, sorry. A comma b is equal to 2 comma 3, and then I can do a plus is equal to b. These are just shorthand notations which get the same effect, which says that, hey, take the left one and apply this operation, and using this second operand, and just assign it back the values. Next are comparison operators. So these give you a result as true or false. Okay, these give you Boolean values. So if you do a is equal to b, it says false. If you say 1 equal to 1, it says true. So if I do a is not equal to b, it will give me a true value. If I do a is greater than b, give me a true value. If I do a less than b, it will give me a false value, because a is 2 and b is 3. Sorry, a is 5 and b is, this is, yeah, in case you're getting confused. So a less than b, 5 is less than 3 is false. 5 is greater than 3 is true. This is naturally true. And I can also do a greater than equal to b and a less than equal to b. And these are keywords. These are not strings, by the way. So these are not strings. These are Python keywords. So to show it to you here, I can also assign them like this. If you notice, the color is different. It's not like just another value. It's being treated as a special value in Python. Yeah, so then there are logical operators as well, A and B, A or B, A not and not A. They are pretty much, so A and B will give me 3. It'll give me the lower value. A or B will give me the greater value, and not A will give me false. So because A is a truth, not 1 will give me false, not 0 will give me true. So anything greater than 0 and not false will give me true, and not true will give me false. So anything which is, not 0 and not false is going to give me a false when I apply the not operator. And going back to what was this doing, why it was giving the lower value and why it was giving the higher value. So it is the way Python deals with this particular thing, where or on two particular things it will compare them, and it will convert them into binary, and then it will automatically perform the operation. That is the output that you will get. So this is more related to binary logic rather than Python logic. So this is the result that you would get even in mathematics. You had a math question like 3 and 5, right? And 3 or 5. This is not about Python really. This is more about mathematics, about why the output of 3 and 5 should be 5 and why the output of 3 or 5 should be 3. By what logic? So I'll just sort of leave that for you to kind of rediscover. But that's really secondary school mathematics. It has got nothing to do particularly with Python. This is just the way you do it in Python. You simply use it like English. So if you notice this, so this might not seem like English to you right now. This might not seem like code to you right now, but all of this is valid code. I can do this as well, right? And I can run this. See, I'm getting a result, false. So this is all valid Python code. And A or false returns this value. So or basically always returns the higher value and always returns the lower value. So if I have 1 and 1, or if I have 5 and 5, and will return the lowest value, which is 5 in this case. But if I have 5 and 4, it will return the lowest value. Or on the other hand, always returns the highest value. Next are bitwise operators. These are done on bits, essentially a binary and, binary or, binary XOR, binary not, binary left shift, binary right shift. Good to know about them, but as I said earlier, you would rarely be dealing with binary operators in Python with binary numbers. Very, very rare case. So otherwise, when you're dealing with that, it's going to be pretty much like mathematics. This has got very little to do with Python. It's got more to do with maths. Then Python also has identity. Again, very, very readable. So 5 is 4. Of course, you will get a false. And you can do 5 is not 4. Okay. I can do it using variables as well. So I can do the same thing, saying that, of course, we're going to, so you might be asking, hey, what is the use of this? Like, why just printing true, false? Of course, these are used for comparisons. Like, you can later set up logic, something like, if C is D, then do this, otherwise do something else. So if C was, let's suppose today is equal to Wednesday, and this is yoga day, it's Thursday. So of course, now you can build a logic. If today is yoga day, and you can run it, and it's false. So now notice how readable this is. It's reading like English, right? That's why I love Python. That's why a lot of people love Python, because it's very, very verbose. So the word is verbose. It is very easier to just read through the code and understand, okay, what does this mean? It reads like English. Okay, next is in. So membership operators, what they do is that they check if a certain thing exists within a certain thing. So this applies for dictionaries, this applies for lists, it applies for tuple. So I can do something like this. Let me run this. Okay, for not in list, false, right? Over here, what I can do is, wait, comment all of this out, right? So it's membership checking. It's checking if Edureka is a member of this or not, of this list or not. And this works on lists, it works on dictionaries as well. On in dictionary, it will work like this: print age in A, where it is trying to check if a key is present or not. It says false. So wait, sorry, it says true here. Let me comment this out. Let me comment all of this out. Now, if I were to by mistake do this, because it is case sensitive, it will say false. Again, for comparison's sake, if I run this, right? And the point of this is, of course, not to, in the case of a dictionary, if I do this, where I use a key which is not a part of it, and I run it, I'll get an error, key error, age. It doesn't recognize it. So in case I need to check for a key before I use it, I can use something of this sort. Now let's look at conditional statements in Python. Conditional statements are used to execute. So this is what we were sort of building up to this point. They're around if, else, and else if. If a condition is met as true, do something. If it is not, do something else. We do it every day. If today is yoga day, go to yoga class. Otherwise, no yoga class. Otherwise, chill at home. So that's just something that comes very naturally to us as human beings now. And naturally, we need it in programming languages as well. And of course, the way it works is that you start a program, and this is sort of called as a control flow. If x is less than y, do a bunch of stuff. If it is not, then check again for a certain condition. If that is true, then do a bunch of other stuff. Otherwise, do this. And that just is how programming works a lot. So, a lot of business logic or logic of how you want your application to work gets built in over here. Okay, now let me talk about indentation once more. Okay, let me first comment all of this. So the thing is that when you type instructions in Python, how do you tell Python that, hey, these bunch of instructions need to be followed under if, and these bunch of instructions under this else if, right? So essentially, this is a block of code. This is referred to as a block of code where the instructions won't just come on a single line, right? Naturally, you write more complex things over here. You might need to write 100 lines if this condition is met. You might need to do 100 things. Now, how does Python know that this is within this? Like, one way to do it is, of course, I mean, why can't I write it like this? Right, I can. Why not? But then, does this LF come under that instruction set that I've been writing? Or does it map to this? Like, because now all of them are on the same line. So, should my statement go here or here? There is no enclosure. There is no clear path defined this way. And the way Python does it is through indentation that we talked about earlier, where this needs to be at a distance of 4 spaces. So the IDE does it by itself as soon as you're, sort of typing. If I'm typing, let's suppose if x less than greater than y, and I press colon, so it's always followed by a colon, by the way. So notice the colon, and I press enter, it will automatically go to 4 spaces. It doesn't even ask me. Tab in the PyCharm works with 4 spaces always. Otherwise, you can give 4 spaces by yourself as well. So this is 1, 2, 3, 4. But your code will not work if you don't do this. Okay, your code will not work. So it's not just, so there are there is a very strong reason why this is like this. The reason why it is like this in Python is because the developer of Python wanted to make Python read beautifully. So while it may seem like an odd reason, but if you look at good production level code, so which I mean, if you look at code written by great software developers, good software developers, not even great, just even to be good enough, considered to be good, they would write code which is very readable, very clean. Okay. And Guido von Rossum, the creator of Python, wanted to enforce it. He said it was not a choice. So I'll tell you how sort of otherwise it typically gets done in other languages. So in other languages, you would have something like this. Okay. And then you would have something like this. And then you would have curly braces, right? And then you would have, let's suppose, a bunch of lines. Let's suppose print x, right? And then this would have print y a bunch of times. Now, this looks dirty because I mean, I could have indented it and it would become a little more readable like this. Ignore the underlinings because this is just not valid Python code. I'm just trying to show an example here of how other programming languages do it. So they do it by curly braces. They indicate what is called as a closure or a block of code using curly braces. But Python doesn't have that. Python doesn't have curly braces enclosing a bunch of instructions. What Python has is an indentation, this, okay? And basis that it takes the decision. So if it is true, then it goes inside. If this is true, it goes inside it. Otherwise, finally, it doesn't check anything and just executes. So let's run this. So x is less than y and on line 6. If you just want to do an if else statement, you can do that as well. You can add conditions over here and simply run it. Greater than 25, a is less than 10, a between 10 and 25, greater than equal to 10. Pretty much like how you would write it in mathematics. So if this is true, then do this, otherwise do this. Please note that these and these are not related. Like both of them will always be executed. So if I do this and I make a as 10, right, we will see both the statements. So less than 10, in between 10 and 25. So, but if this was under this, now this is an if else block within an if block because the tab. So to determine what is inside what, you need to really look at the indentation level from the parent statements. So for this line to be printed, okay, this and this needs to be true. For this line to be executed, only this needs to be true. And for this to be executed, this line needs to be false, but this line needs to be true. So the control wouldn't go inside this, but this if else is within this outer block. So in the terms of comments, this is the parent comment, and this person is replying to that parent comment. It is not an individual comment by itself, it's a nested comment. If this is like this, then both of these are parent comments. Next is loops. So there are three kinds of loops in Python. The purpose of loop is to do the same thing again and again and again, like on repeat. If a condition is met, so it would check for a condition and it would continue repeating according to that condition a number of times. So a while loop performs until an expression is true. So it checks, goes in the body of the loop, otherwise it goes out. Please note that the while loop, again, indentation block, followed by a colon, right? Now, in this case, what we are doing is that we are printing till 4. So we are going to increment the value one by one, and we are going to count till 4. So let's run this 0, 1, 2, 3, 4, and then goodbye. So as soon as count becomes 5, right, it will not be true anymore. It will come out of the loop. Let's mute this and instead run this. Okay. So if rank is not equal to 12, it will print from 5 till 11. Right? Pretty simple. So this is a little guessing game that you can try out. So input number 10, the number is too small. Input number 15, the number is too large. If input number is 13, exit. I mean, you will end the loop. Congratulations, you made it. Now for the for loop, this is by far the most important one that you would be using. It iterates over a range. Now a range could be a list. So if you wanted to print a list or a tuple or even a dictionary items, so anything which is a collection, right? That is what it iterates over and will increment, it will keep going iterating over or stepping onto the each individual item. So let's look at the statement here. So we have a list of items, fruits, and what we can do is, okay, ignore this. This is not well written. For fruit in fruits, print fruit. And you can simply run this. So it runs bananas, apples, oranges in that order. And if this is the list, then again it will do the same thing. Print I in list 1, 2, 3 Python. Right. So you can use for list to split the factorial of a number. All you need to do is keep reducing the number by 1 and keep multiplying it and keep using it again and again and again. So you just subtract it, multiply it, multiply it, multiply it, and then you will get an outcome. And of course, you can have nested loops. So you can have a loop inside a loop. Again, same principle of indentation applies. You can have a while loop inside a for loop or a for loop inside a while loop. Purely depends on what you're building, on what you're trying to do. So it depends on the logic, right? So let's suppose the logic is as simple as you're writing a robot and you're saying while Thursday for 0 to 1 million, keep taking the left foot and the right foot forward, left foot forward, right foot forward. So it would keep doing that till it is Thursday. So it will take as many million steps, or let's suppose it's about the instructions are something like this, right? While while day to Thursday for 3, 4, right? So you're basically telling the bot that, hey, while it is Thursday, just keep doing this all the time. So that really depends on what you're trying to do with what your application requires. So again, this is something that you could try out where you could write a code in Python, which is simulating a ATM, where you ask for the 4-digit PIN, where you and then you show a menu saying that while balance, while a withdrawal, pay in, and return card. And then the user selects a value, or it keeps repeating it n number of times, or you could set a limit on it. While the number of tries is not 5, keep asking the user to make a selection. Now there are certain control statements in a loop. If you want to sort of break out of a loop, let's suppose you're looping over a million elements or something, or you're trying to loop over something, and if a certain condition is met, you want to just break out of it. You want to finish the loop right there and there. Then you would use something called as a break statement. If a certain condition is met, however, where you do not want to do it, then you would use a continue statement where it would skip the loop. It would skip wherever it is in the loop and go to the next item. And then, of course, there is a pass statement. This is used not just in loops, this is used in classes, functions, multiple other places as well. This is used to define an empty body. So let's suppose for I in 1, comma 2, comma 3, I want to say pass. Just because I have not written any code yet, I want to write it later. But it's just that I want to, because if I don't do this, then this is not syntactically correct. If you notice, I cannot write any code under after this, even if it is legitimately true, because of the indentation. Python doesn't know that I have closed this. So I will use a pass. So pass again is at an indentation. It is a default sort of way to tell Python that, hey, this is over, and then just go to the next line, which is 24, and don't consider 24 to be inside the for loop. So as I was saying, right, if you're printing numbers between 10 and 50, but as soon as you encounter 30, you want to break out of the loop. So it will stop the loop. And if you're in a range 1 to 11 and you say that j is equal to 5, and after that you want to continue to the next one, it will skip the 5. It will skip over and straight away go to 7. So let's try out this one. So let's suppose range is 1 to 11. So let's run this. Okay, wait, I need to mute all of this and this as well. Yeah, so if you notice that this time 5 has not been printed because on 5 we just skipped. Now if I was to place this above over here and run it, then it would print everything because you're printing anyways. So I mean, essentially the use case of continue is that when you do not for some reason want to process a certain value that you're going to encounter, or if a certain condition is met, you don't want the loop to continue after that, you want it to go to the next one. But if you want to break altogether, right, where you were not expecting this to happen, then it will just stop. Continue will go to the next item. So next thing is command line parameters. So when you're executing Python file, right, you might want to pass certain arguments to it. Arguments being certain values to it. And that happens to the Python command line argument. So Python has a module inbuilt, being that it is straight out of the box. You don't have to install anything. It's like a library. That's what a module is essentially. You have a Python sys module, and what the sys module does is that it stands for system, which refers to your operating system, and it allows you to access the arguments that you are passing. It's a list of command line arguments, and len of sys.argv is the length of command line arguments. So let's look at one of the files for this. So let's actually create a file. First thing that you need to do in the file is import sys, and then you want to say len of sys.argv, and then you want to say sys.argv. Now, one thing that we haven't covered till now is how the Python file will be run. So what I'm doing is right now I'm gone to the folder which contains this folder ds-mod1, okay, and it contains something within it as well. It contains all the files including test.py. To execute the Python file, all I need to do is run python test.py, okay, and then I need to provide the arguments. Now notice that the length of arguments is 6. It's not just 1, 2, 3, 4, 5. The name of the file is an argument in itself. So this can be confusing at first. The first thing that it takes as an argument is the file itself, but then next is followed by whatever you gave it, which is 1, 2, 3, 4, 5. Okay, test.py abc This is what it is printing. Before we do any of that, let's suppose one problem or one thing that we want to do with a Python file is we want to ask the user for an input. Let's suppose we want to write a simple script which will ask the user for two numbers and add them or multiply them or do some sort of an operation with them. So how can we do that? The answer is that Python provides you with the input function. And the way the input function works is that it's an inbuilt function in Python. You call the input function, pass a string. The string is the message or the question that you want to ask the user. So let's suppose you want to ask the user, give one number to multiply with or give one number to add. That will come between the strings. Now, whatever the user types in as the input, that gets stored into the variable on the left side. The function basically returns, or what it does for you is that it prompts the user with a line which is understood in a language that the user will be able to understand. The user types in something and then it gets that value and gives it to you in a variable. Let's look at a quick example. Let me comment this and let me run this file. So it's asking me for my input. Let me enter 3 and it says the received input is 3, which means that the input was stored in str. Let's look at another example. Let's suppose you want to ask the user for their name, their age, same thing. You provide the string that you want to ask using. It gets stored in this variable here and then you can just print it. And then of course, if you want to perform any sort of operations, you can go ahead and do that. Let's quickly run this as well. So I just faced an error. Now what happens is that input expects, so if I'm not giving it a number, if I'm giving it a string like my name, I have to provide it in quotations. So it will work if I do it like this. For numbers, I don't need to provide any strings. Let's run it again. Suppose I give my name as Varun. That wouldn't work. If you're inputting a string, then it has to be within single quotes. It can't be without single quotes. If it's an integer, then it doesn't need any quotation. Next, let's look at files in Python. So if you remember, we discussed that let's suppose you have to build a software which can manage different kinds of files for you, put them in folders, sort them, so on and so forth. So Python provides very neat and nifty methods to deal with files. So let's look at that. So when it comes to files, there are a couple of typical things that you will need to do. So you would need to open and close a file. Even if it's a notepad file or a Python file that you must have created after the first one. The thing that you do with any file is that you open it or you close it. The next things are you need to write a file or you need to read from a file. And then certain other maintenance operations such as renaming the files or moving the files or deleting the files, stuff like that. So before we do anything, we need to understand that opening and closing of files, how does that sort of work in Python? So the thing is that opening and closing a file works with modes. So it's not as simple as opening a physical file in the sense that there are different modes in which you can open a Python file. There is a read-only mode, there is a write mode, there is a write plus mode which creates the file if it doesn't exist. And all of these are for the sake of protection in the sense that if a file was always open in write only mode, right? If it was that you could write and read to it all the time, you might end up doing certain things to a file, certain operations. You might end up messing up the data inside the file. It is basically a best practice that you open the file with the correct kind of mode based on what you're going to use it for. If you're not going to write to it, don't open it in a write mode, open it in a read mode. And then of course there is closing of files. So suppose you are opening a huge file. It's a file which is suppose 500 MB in size. It contains 10 million addresses or names. If you do not close the files, what happens is that when you open a file, it gets loaded into the RAM. Now, if you do not close the file properly, you do not do that management bit of the file properly, then it will remain in the memory and that can potentially cause a memory leak. So just like one of the precautions to keep in mind that no matter how you're doing it, opening and closing of the file needs to be kept in mind. So open the file, we will be using the open function available in Python. It takes the file name as the first parameter and then the access mode as the second parameter. So file name naturally is the name of the file and access mode is what I was just talking about, whether it's read, write or append. So here are the different access modes. R, this is the default mode, open the file for reading only. There is a mode called RB as well. By the way, You pass them as strings over here. This is again, this is going to be in quotes, string R and string then RB. So it opens the file for reading only in binary format. It is rare that you will use this, but it's just something which is good to know about. So for typical files which are sort of decently maintained, not even well maintained, you would not really need to go for RB. And the difference, unless and until you're dealing with some sort of malformed file, is not that much. Or something specific that you're doing with it where you need it in the binary format. Then there is the R plus mode. It opens it for both reading and writing. Then there's the RB plus mode. It opens the file for reading and writing in the binary format. There's the W mode. It opens the file for writing only. It overwrites the file if the file exists. So this is the significant difference between W and R plus, where W will basically overwrite the file. So it's like creating a new file, irrespective of the fact that it exists already. Whereas R plus will not overwrite the file. WB, it opens the file for writing only in binary format, and like W, it overwrites the file as well. Another mode is A, it opens the file for appending. So, which means that it only allows you to add to the bottom of the file. It doesn't allow you to edit whatever is already there. So this is sort of makes sense if you're doing update or append only system where you do not want the previous records to be manipulated in any way. AB, it does the appending in binary format. A plus opens the file for both appending and reading. AB plus opens the file for both appending and reading in binary format. And W plus and WP plus is something that we have already covered. Now, when it comes to writing files, you take the file object, which is obtained over here, right? You open the file, you get a file object, which is basically representing your file in the code. And then you say dot write, and you pass the string that you want to write. And the write method, as of course, I mean, because we were talking about the binary bit as well earlier, that you can open a file in a binary format. So write just doesn't take strings, it can take the binary data as well, and not just text. The read method reads a file string from an open file, and again, it can read binary data as well. Notice the count. So if you give it a count, that is the number of characters it will read at a time. It is an optional parameter. If you do not give it a count, it will read everything. Let's look at renaming files. So for renaming a file, you need to give the current file name and then the new file name. It takes two arguments. And rename, if you're wondering what is OS, it's a module available in Python which you deal with the operating systems. We are going to cover it later in depth, but just know that OS represents your operating systems, because when it comes to renaming, it is really usually done with the help of the operating system. Not that you need to know about operating systems in terms of how they're built or written for this, but it just is a nifty utility available in Python. For deleting files, you will again use os.remove and the file name as the argument for it. So let's quickly look at a couple of examples. So let's start with this. So we open the file. Notice the mode is W plus. So the file doesn't exist right now over here. It will create the file. Now I'm going to loop over numbers 1 to 10, and I'm going to write these 10 lines. Let's see if I'm successful or not. Finished. I have a file. It says, hello, welcome to Python. 9 times because this starts from 1. So if I do it at 0, it will do that. So let me run it again. Now it has done it 11 times. It will simply overwrite the file each time because it's in W plus mode. Now let's suppose we had to read the file and we will run it. What did we do wrong? What we did wrong here was that it's in W plus mode, so it has already emptied the file. So let's run this one again, and before we run this, so now we have a filled file. Let's mute this out and now open the file in R mode and now run this. So now we have this appearing 10 times and we're doing a new file.read. Now, as I said, you could pass it a counter as well. So I could pass it 5 and it would then only read 5 characters at a time. So you get a very weird output. Don't be confused by it, but it's just that it's reading only 5 characters at a time, and that's why it's coming like this. If it was reading 500 characters at a time, then the output would have been again different. 500 works similarly for us. It was reading 50 characters at a time. So I think the first time it would have read all of this, and then it would have read this. Now let's try the OS function as well in case you want to remove the file. Okay, let's first rename the file to new.txt, and we don't really need to open the file, so we can just remove it and we can run this. So if you notice, this has been renamed, that file disappeared and we now have new.txt, and now we can simply go ahead and remove. We run it and that gets removed. Did you notice? It got removed from here. So the file.close method closes the open file. A closed file, of course, cannot be read. And in case I was to reassign new file, let's suppose I was doing this, and then I take this variable and I assign it some other value. What Python will do is that it will automatically close the file whenever I do a reassignment. So it will automatically close the file if I reassign this variable. That is where Python is, of course, really helpful as well, because that's one of the things that, if you remember, that Python is supposed to be a very friendly language to learn. Now let's try another one where we close the file and then we try to write to the file. Let's see what happens. So it gives us an error. Yeah, I'm trying to open it and write read mode when the file does not exist. Let me run it again. Now the error is IO operation on closed file. It says the file is closed. Now there are various attributes of methods available on a file. One is file.close, we just saw that. There is file.mode as well. Let's see what we get with. So we get W plus. So in case you need to, this is used for checking. You can use it for any sort of checks. In case you're confused about it, like if you're writing a large piece of program, at some point there are multiple files and you don't remember, or you want to have a strict checking before you do something on a file. Maybe you do not want to write to a file, or you want to add a constraint. That is when this will help you out. Now the file.name will of course return the name of the file. Let's do that as well. And let's do the other one as well. We have done the mode, and then there is file.softspace as well. Let's run all of these three. So we got the name of the file as well. Softspace is nothing but it returns a boolean, which is 0 or 1, whether a space character needs to be printed before another value when using print statements. Then there is a mode, there is name, and then there is new file.softspace. Few other methods available are seek. It lets you seeking through a file. It's searching for a particular thing. It takes in the number of characters. So like read takes the number of characters. Similarly, seek also takes the number of characters, where you can tell it that, hey, start reading after 40 characters have passed. Tell gives you the current position of the file. So each of these things over here in the file, this is a position. So this is a certain line in the file. So let's try this out and see what we get. Let's open the file in read mode. Run this now. Right, so it's seek to 0. Now let's make it 100 and see if that changes anything in the second output. So you're seeing that this second output is changing based on how much we are seeking. So if I do it, make it 1000, it will go to the 1000 line, and we can also do a dot read at this point. So this is saying that I'm going to pass the first 5 characters, then I'm going to do a read, and then I'm going to do a tell. So this is basically this, of course, new file.read will read the entire file. Okay, this is not just going to read one line, but it starts reading after the 5 characters. So the first 5 characters would be HEL, right? And then 2 characters for the empty. This space also counts as a character ahead of it. The space 1, 2, 3, 4, and then there is a new line character. There is an enter character which makes it come to the next line. So the 5 characters. So we have already gone through this then, right? The different operations performed on a file. Now, most of the time, a lot of time in programming, you will hear the word data. And essentially, that's a lot what programming is about. Apart from logic, it is about data and dealing with data. So, if you have different types of data, how do you arrange them? How do you organize them? It's very, very, very important in programming and in Python. And Python provides some excellent ways to do this. So Python has something called as sequences. Sequences are nothing but continuous collections of data types, data which allow different kinds of operations on them, whether that's indexing or slicing or something else, as you will look. So think of sequence like how you would think of a sequence in a real life, like a sequence of bikes, like a row of bikes standing outside an office, or a row of bikes standing at a traffic light. You need in a showroom, you need to think of that as a sequence. So let's look at a couple of sequence operations. So most common sequence operations are concatenation, repetition, membership testing, slicing, and indexing. Let's look at concatenation. So concatenation is nothing but gluing two things together. So you have 4 bikes over here, and then you have 4 other bicycles over here. Concatenation is joining the sequences together to create a new sequence. Sequence repetition is basically taking a sequence and sort of multiplying it by a number. So which is create duplicate sequence with twice the number of items, or it could be 3 or 4, and it could just create n number of items like that. Next is membership testing. What this means is that you want to check if a certain type of bike is a member of this collection of bikes or not, in the sense that this is not a member of this, right? You cannot locate this particular image or bike style over here, but this one is a member like over here and over here. So there are two occurrences of this member in this sequence of bikes. And then there's a concept of sequence indexing where items are zero indexed, where this is referred to as the index 0 or the 0th item. This is the first, second, third, fourth, fifth, and so on and so forth. It is not indexed like 1, 2, 3, 4. Rarely, I don't think I know of a programming language which is one indexed. Most programming languages are work on a zero index basis. So slicing is basically taking a portion, which is saying that, hey, I want index 1 to 4, which is 1, 2, 3, and 4. So I want the slice starting from this one and going up to this one, but not including the last one. So this is not including 4, this is 1, 2, 3. So 4 minus 1, 3, starting with 1 though. So 1 is included, 4 is not. The last one is not included before the last one. This one is included when you're slicing. So slicing is basically taking a sub portion of any list. Think of it like cutting a slice out of a fruit or out of an apple. So you're taking a slice out of this thing, which is like this. Let's look at a couple of code examples. First one is pretty simple. You have a list which has a list of courses, let's suppose, or programming languages, Hadoop, Python, Android. You can print the first item in the list. You can slice from 0 to 2. This will just include Hadoop and Python, not Android. Or you could do list of -1. So let's just try this out. So it took Hadoop and Python. One prints Python, not Hadoop. And then -1 basically takes the last element in the list. So -1 is a reverse traversal. I could also do -2 and I can also do -3. And let's look at the output. So we can always do this plus React, Angular, data science, and we can look at the output over here. See, so we got a concatenated list plus React, Angular, data science, right? This got added to it. We can do a list repetition as well. So let me comment this and instead have it like print list. So I'll just show you a different example where I'm going to multiply it by 3 instead of 2. So if you see, now the same thing is appearing 3 times. This was appearing once, Hadoop Python and Android. Now it's appearing Hadoop Python Android and then again Hadoop Python Android. Membership testing. Now this gives a true or false answer. So I can do Hadoop list and I can do Angular in list. Some of you might remember that we have done it in the last class as well. The answer is true or false. We have already looked at indexing and slicing. So let's look at the type of sequences in Python. There are lists, tuples, strings, sets, and dictionaries available in Python. Let's go through these one by one. So lists is the most versatile data type available in Python. It's basically a comma separated values within square brackets. Some of the operations that you can do on a list is you can update a list element, you can get the length of a list, you can concatenate it as I just showed, you can slice it, you can delete elements in a list, and you can repeat elements in a list. That is by multiplying it. So when do you want to use lists? So if you have a collection of data that does not read random access. So what is meant by random access is that you want to access it sequentially, in the sense that if you talk about random access, right? If you talk about list 4 like this or list of 3, you really don't know what this means until unless you know the list, right? You don't know what this is going to be, what this represents. When you're writing code and unless and until you know what the second element in the list is, you don't really know what it is exactly going to be. You might know it's going to be one of the courses, but which course or whether it's a course name or the course price, you don't know that. So list is useful if you want to just sequentially access it and process it. Of course, when you have to deal with values that can be changed. So as you might remember, tuples are immutable while lists are mutable. So when you want to change items, that's when lists will also be helpful. So this is something that I just showed to you. You can index the list, you can slice it, and then you can access it in reverse as well. Now let's talk about updating the list. So let's suppose I want to store Java instead of Python as the first element, and this is how I will do it. As simple as just taking it up and assigning it a new value. So let's run this. So now we have a updated list, which is Hadoop Java Android as compared to Hadoop Python Android. To delete the element, what you do is you simply say that the keyword in Python is del. It's a inbuilt function. You call del and you pass it the item in the list that you want to delete. So notice that we are not passing it the index, we are passing it the entire item in itself. So the way delete might work internally is that it will look for that item and then it would go ahead and delete it. See, so we removed this one. Let's look at pop. What does pop do? If we have a list of this sort, it gives us 4. So what pop does is that it just accesses that particular element and returns it to you. If you notice the list, it basically removes the element. Do not think that pop is the same as doing this. It might look like that because you could say, hey, it's just printing 4, right? So why can't I do it like this? But essentially, pop is removing the element from the list altogether, popping it out of the sequence. Remove just totally removes the element, doesn't return it. So there is also something called as a list.remove, and if I do list.remove 3 instead, and let's suppose I do this, and then let's see the output for this one. This doesn't return anything, it just removes it. So there is a difference between pop and remove. Please don't get confused about it. Pop will actually give you the item that it removed so that you can use it. Remove is more or less used when you are done with that item anyway, you don't want it in the list. So pop is more like, going to the showroom and getting a bike out of the collection of bikes. Whereas remove is basically taking the bike in a collection of bikes and just destroying it. So there's a difference. You can also use the type function on list. It will just return that it's a list type. Then what we have here is something very interesting. It's called as list comprehension. Let's look at the example given here. So this is one of Python's very talked about or well-known features among Pythonistas. You can basically create a list by doing this. Forget the print statement for a second. I can do this. So what this does is you need to start reading it from here. For x in 1, 2, 3, 4, 5. So I know the syntax looks a bit weird. So first and foremost, it needs to be within square brackets. So let's remove this for a second. Within square brackets, it's already a list, but it doesn't have anything. Now what we say is how I would have started writing this expression is I would have said for x in 1 comma 2 comma 3 comma 4 comma 5, which is valid, right? I mean, so which is just like writing for x in 1 comma 2 comma 3 comma 4 comma 5. It is kind of like that. I have just not appended the colon here, and then I say do this for every x, which is exponential to the power 2. Now I could have also done the same thing like this. So list has a function called append. I could have done this as well, but this is the equivalent of this. Both line 29 and 31 to 33 will give the same result. It's just that this is a bit neater to write, and it's called as list comprehension, and Python developers love using it just because it's in a single line as compared to 3 lines of code. Okay, we already did append, so it adds an item to the end of the list. Extend is used with another list, so where you say that, hey, extend this list by adding all of these items at the end of the list. So let me show you an example. If I have this and I have this list over here, and then I run this, so it's 1 2 3 comma g comma h. Append is for a single element. Extend is when you have two lists and you want to join them together. This is concatenation. Insert, as the name suggests, it will insert one item at that particular position in the list, right? So it inserted. If you had to do this yourself, you can imagine it is doable, but it would have been very troublesome. So insert, it will take the index and it will say that, okay, at this index, you want this value. At this index, which is 1, you want this value. So let me do that for you. Because had you done this like this instead, it would have overwritten 2 here, which was at 1. But insert will insert it instead of deleting any of the or overwriting any of the existing elements. We have already looked at remove. It will remove that element from the list. So there is another inbuilt function which is called as sorted. It will take a list and it will sort it for you. Let's try it out. So it will automatically sort it in the alphabetical order here. Okay, so if you look at the original list and you look at this one is sorted now. And another thing is that if you want to reverse the list, so let's suppose for some reason you want to print it in reverse order. You have sorted it, you want it sorted for most reasons, but then just while printing the names, or let's suppose there's a functionality in your application where the user can go from A to Z and Z to A. Course in list 4, and then the syntax is colon colon and then -1 print course. So if you look at this, this has printed the list in the reverse order from here to here, but the original list is still the same. So it's a neat little trick where you can use the reverse order of the list without actually reversing the list, which makes a lot of sense. I mean, why create copies after copies of the same thing? And instead, you can just reverse the list and use it just like that. Now, another interesting thing is that you can have that the list in itself can contain dictionaries, tuples, other lists. It can just go on and on and on. And for whatever operations, you can just keep chaining it on top of it. So if you look at this over here, it is selecting the tuple first, and then on the tuple, it is doing the slicing. So whatever it is that you want to do, you can chain this together. So tuple can contain more tuples. There is no sort of limit on the amount of nesting you can do. It's really up to your needs that if you think that okay, this tuple will contain further more tuples, you can just keep adding square brackets one after the other and it will work. Right, so this is a more visual representation. Zeroth element, first element, which is 0, 1, 2, which is 0, 1. Now you can add further under it more and more and more, and you can just keep continue doing that repeatedly. Now the thing here is that even though it's a tuple, right? I mean, you can't modify the tuple even though it's inside a list. So it's not that an immutable item will certainly become mutable if it is inside a mutable sequence. Let's look at tuples. So a tuple is a sequence of immutable Python objects. Tuples are sequences just like lists, except that they start with a regular bracket and similarly, but they are separated by comma. So a tuple has slicing, updation, length of the tuple, repetition, deletion, concatenation. All of those things are available as operations even on a tuple. Now tuples are somewhat faster than lists. That is one of the areas where you might want to use a tuple, and you might want to also use a tuple when you have to deal with values which cannot be changed. So as we talked about last time, right? Immutable, scientific constants, things that you do not want to change, the value of pi, just refresh your memory about that. If there is a set list of countries in your application that you do not want to be modified, that is when you would use a tuple. So basically, if you have a constant set of values and you want to iterate through them, that is when you would use a tuple. Let's open the file that I have ready for this. Let's run this and let's see the output. Now length 3 makes sense, right? Maximum is Python. So the way it chooses the maximum is with the starting of the letter. It's ascending order. And then there is a minimum which is Hadoop. Now what if it had another value 3 inside it or 2 inside it? What will happen? Let's see. What will be the min and the maximum? So the min will become as 2. What if this was a big number like this? What will happen? So string will always win. So it's looking at the ASCII values and that's how it's determining the max or min. So again, sorted and reversing works exactly like strings. Multiplication and membership checking, again, exactly as you've seen till now. You can do repetition, you can do a membership testing, just exactly the same. Now, of course, you cannot update a tuple. That will throw an error that saying that so this will not work at all if tuple 3 was already defined. But of course, if tuple 3 was not defined, then you can add the two things together. And of course, this will throw an error because tuple is not defined over here. So you cannot delete a variable which has not been defined. This is something that we covered in last class as well, and we went through a couple of examples where lists are mutable, where tuples are not. Now, as we saw that lists can contain tuples, a tuple can contain lists as well. Cuts both ways. And then, of course, you can chain it together. So the list in itself can contain multiple lists. Same visualization again, 0, 1, 2. Within 0, you have 0, 1, 2. Within 1, you have all these elements. And this can extend further and can just go on and on and on like that. So don't be confused about this. You're actually updating the list here. You're not updating the tuple. The tuple updation would mean that you're doing it on 0. So let me show you by an example. Let's suppose you have a tuple here 0, 1, 2, 1, 2, 3, and 4, 5, 6. If I try to do this, let me run this. This will not work. However, if I try to do this, this will work. Do not be confused about this because what I've done, this thing has been done on this particular element, which is mutable. This is not mutable. This is mutable, where this is basically a tuple element, what I've selected right now. This is a tuple element. The tuple element in itself cannot be changed. But what is inside the tuple, if the tuple element is mutable by itself, then it can be changed. So you can convert a tuple into a list as well by using the list keyword or the tuple keyword, and you just pass it the tuple or the list and it will just convert it and give it back to you. So I can do this where you can say encrypt print tuple item and print item. Notice the difference? Just that of brackets. But of course, this one is not, one is immutable, one is the other way around. And I can, of course, always do this. I can do this, and then I can run it. And now this entire thing is a list. So it's just helpful to know that these conversions are possible, not that you will necessarily need to use these. Next, let's look at strings. So as you looked at strings, you can create them by enclosing them within single quotes, double quotes, or even triple quotes. And the operations available on strings are again slicing, updating, concatenation, repetition, membership, and then reversing a string. So I know a string, it's a little difficult to sort of imagine a string like a sequence, but you really need to think of it pretty much like a tuple. I mean, where there are individual elements which cannot be updated. Start thinking of a string somewhere like a tuple where, but of course, the difference here is that the members of the string cannot be a list. So it cannot contain another list or it cannot contain another tuple naturally, but it can contain any alphanumeric characters. And you need to think of it really like a tuple where each of the individual elements are not mutable. Of course, strings are among the most popular types in Python, single, double, or triple quotes. So let's try out a couple of operations on strings then. So we have a string, we have a length on the string, we have string 1 to 3, and this is membership checking. Let's run this. Okay, so string 1 gets printed, string 2, string 3, pretty standard stuff. Length of string here is 6. String 1 to 3 is YT, which is starting from 1 to, doesn't go up till the third one. And T in string is true. If it was a Z in string, then it's false. So you can check for a individual character. Now if you notice this behavior, yeah, I mean, of course, now it seems like a sequence. It seems like a tuple. I can do this. So if I was to give you, let's suppose I do this and I replace the string with this. Let's see what will be the outcome. Of course, this one is going to not represented like a string. The length will be the same. Yeah, but the representation here, the slicing representation is going to be somewhat different. So it's just in principle, like it is similar. You can use it as a close analogy. It's similar but not the same. Because when it slices, right, it is giving you YT, and over there you were getting what is again a tuple in return, even with the slice. Next is placeholders in Python. Now these are very, very powerful. What they allow you to do is think of them like fill in the blank. So this is like a blank and you're filling it with a string on the outside. Now this is a better way to do this would be like this, where you have a variable. Now what is the alternative to this? The alternative to this is welcome to plus course name. Now this is messy. I'll tell you why. If I have to type this, you're getting it that it's in the right in the middle of it. There is a space here. I have to take care of the period to end the sentence. I have to give another space. It's not very readable. If I had to do the same thing here, I would just do this. Which is more readable? Compare for yourself. Now you know what you're going to print over here. Another place where it is even more helpful is when you have different data types. Because if you have to do it without using this, only way to get it done, you have to use string to convert it. Because otherwise this won't add. Python wouldn't add a string and a number. It cannot concatenate a string and a number. It can add two numbers, can concatenate two strings. And this is again very messy. Compare this and this. What is more readable to you as a developer? Which matters quite a bit. The output is same, but there is a difference. This is more readable. Think of these like fill in the blanks, and these are the values. Now this way you have a lot of options, percentage %s, percentage %i, and they are pretty exhaustive. So percentage %c is any character, percentage %i is a signed decimal integer, and the list just goes on. There is of course a decimal as well, percentage %f. I would suggest that you go ahead and explore it, but most of the time you'll be using either percentage %s, percentage %d, or percentage %f. Now there are some certain built-in string methods. One is a capitalize. It will, of course, as it sounds, it will capitalize the first letter of the string, not the other ones. Then there is string.count. It will consider the sequence of letters or a single letter that you give to it, start counting the number of times it occurs in the string. Next is encoding. Now, encoding is basically the process of putting it in a certain format so that different computers can support it. The most popular encoding right now is UTF-8. In case you don't know about it, go ahead and please explore it. It's not exactly within the scope of the course, but just know it's the way that different computers across the world represent characters. Because if you look at outside the English language, you look at the European languages which have the accents, and look at the Indian languages which have all sorts of characters, right? How is it that different computers sitting across the world are able to transmit that correctly, are able to represent that correctly on the screen? Or the Chinese characters, that is through UTF-8. So whenever you type something, I mean, are you transmitting it over the internet, it gets encoded and decoded. And that's what encode is all about. So max and min will basically work as per the ASCII value. So max here would give you the value of U, which is the highest ASCII value, and min will give you the value of A, which is the lowest in Edureka. So what does replace do? Replace will search for a particular letter and replace all of its occurrences with the replacement given as a second parameter. So this is the first one and this is the second one. This is the number of times it should replace. So if you notice the output, it did not replace the second E, it just replaced the first one. String.upper will capitalize all the letters. So capitalize was capitalizing only the first one, but upper will capitalize all of them. Next is index. Now same as find, but raise an exception if index is not found. So it will find you the index of the letter K in the entire sequence. So it's kind of like search operation in a list or a tuple where you're trying to find which is the position of a particular element or a particular item in the sequence. So if you look at K, it's 0, 1, 2, 3, 4, 5, K. That's where K occurs in Edureka. For the most string methods, of course, reversal, slicing, we've already done this. Now find is similar to string. However, it will, if it doesn't find anything, it will not give you an error. So st, it gives you a negative one that it did not find anything. Whereas what the other one will do, which is index, it will throw an error that not found. So index basically works with the assumption that you as a developer, or whoever has written the logic, has already checked whether it exists or not. It is not going to help you out in checking. So find is helping you determine if it is present or not, and if present where. Index is just going to tell you where. It is not going to, it is going to throw an error if it doesn't exist. String concatenation, this is something that we have already seen. And string 1 star 2, that will just multiply it. So happy learning, happy learning. If you look, notice this, right? It gets multiplied and prints the string. It gives you the string just 2 times over. Next is sets. So set is basically an unordered collection of unique items. So please notice that the items have to be unique, and set is defined by values separated by commas inside braces. And you can also create a set by calling the inbuilt function set, pretty much like how we saw with list and tuples. Quickly run this and see what we will get. If you see that we have gotten a set here containing the various values, and they have automatically been ordered. So the question is, when would you use sets? And the answer is that if you want to collect unique strings or integer values from a sequence, that's when you will, because it doesn't repeat them. If you notice over here, it is not repeating any of the elements. Even though E appeared multiple times, we only see a small e and a capital E. So if there are multiple duplicates, it will sort of give you the uniques. So one example is, let's suppose that the college administration is facing problems because during information feeding, students are entering same password and ID. Now, sets support unique elements, and we can convert the list of IDs and passwords into sets and get only the unique ones, because it will just collect the unique ones and make sure that the duplicate ones aren't entered into the database. Now, there are various operations available in set. One of them is the union operation. It is performed by using this pipe operator. So it's available on your keyboard. It's available on different locations on different keyboard, but usually it is available on the backslash key, and you need to use it with the shift. Now, if you have this sort of a set, which is 1, 2, 3, 4, and then another set which is 3, 4, 5, 6, and you do print A union B, you would get a union of the two. But again, no duplication. So it would join the two together without any duplication. So look at the example. So it joined them together. Similarly, you have A and B. It is the intersection. It will give you the common ones between the two. So common between these two are 3 and 4. That is what it has given you, the common ones, 3 and 4. That's the intersection. So you can also imagine it like a Venn diagram, that it is a common intersection between the two. Then there is the difference as well, which is A minus B. All of the values in A which are not the values inside of B. So let's try this out as well. Just try to think of what the answer might be, and let me run it. So A minus B is 1, 2, 3, 4, 5, 6, 7, 8. So this is B, the intersection is B. So you can also think of A as like this. So A minus B is also like, both of these are going to be same. The common ones between A and B get removed. Something very similar to what we have been seeking in sequences, membership testing. You can also do a subset check where you can check if a set is within another set. There you need to imagine that B contains A. So A is a subset of B. Then of course with membership checking you can also do the opposite, not in. You can do superset. So for set and superset, let's try it using this. And let's see if set 1 is a subset of S or not. And the answer is true, it is a subset. But if we add a value of C, then it is not a subset. Subset is that it will basically, all the elements of set 1 are found within all the elements of set S. The next check is that if S is a superset of set 1, where it contains all the elements of set 1 as well, which is true. Now if we mark it as C and now we run it, then it is false because S doesn't contain all the elements of set 1. However, if we set it as C and now we run it, then it's true again because now the S set contains all the elements that are contained in set 1. Now, similar to append, set has something called as add, where you can add an element. So let's try it out here. So you have added an element and it automatically ordered it. If you want to remove an element at a certain index, you can do that as well. So this is with by removing one from the set S. Then you have discard as well. Again, you provide an index. So the difference between remove and discard is that remove will remove the element from the set. Discard will remove it only if it is present. So which means that it will not throw an error if the element is not present. However, remove will throw an error. Pop works similar to the list.pop where it will remove the element and give it back to you. S.clear will remove all the elements from the set. So it's going to create an empty set. So let's try s.pop as well, where you have done a s.pop. So it will basically remove one of the elements, which is the first one over here in this case. So we can do a print as well, right? So it removed A and then the set was 1, 2, 3, B. Next is dictionaries. Let's go through it in depth. So a dictionary is an unordered collection of key value pairs. It is generally used if you have large amounts of data, which basically is mixed. If it's not continuous values, that you want to store in an array, if it's like details about a person, right? Where details about a person can take various forms. So just think of your Facebook profile or think of your any social media profile. You can have, your name, your last name, location, you can have your interests. So, wide and varied data, very heterogeneous. You will have your age, you will have your birth year, you will have your jobs, the number of jobs that you're in, you will have your current job. So, all of those things. So, the dictionaries are used when you have heterogeneous data representing a real life situation, really, or a real life entity. When would you use dictionary? So one example is if you want to create, let's suppose, any sort of arrangement of data where you want to store the name, the Aadhaar card number, the social security number. So any Excel sheet that you've ever created, that's kind of an example of a dictionary where each of the header is the key and each of the rows are a value. So name would have multiple values and the key is name. So when the questions that you ask is what is the name of this particular person who's at the 10th row? What is the name on the 10th row? Or what is the social security number at the 10th row? And then the answer is that, okay, social security number is one of the inputs and that's the key because you can go row by row, but then for checking which data corresponds to what that sequence of character represents, that depends on the header. So it might be filled with data and contextualization happens through the header. So very simple, this is how you create a dictionary. Over here given 1 and 2, so it can have integer values as well, but typically it would have string values because see, integer values are something that you've used in lists as well, right? So it doesn't really help out that much. The point of a dictionary is for it to immediately make sort of a readable sense. So in the sense that if I were to create a person dictionary, right, I would say first name, say last name, say age, I would say something like city. And then what dictionary allows me to do is access the elements by keys within the square bracket, which is much more readable than, integers. So if it was in an array and I could do something like this sort, let's suppose same thing, but let's suppose it was like this. So just compare the two. Just that line 56 is much more readable to you as a developer as compared to line 58, 59. you wouldn't know what person 2 actually means, what it is accessing the age or not. It causes all sorts of problems. So it's very, very important to understand which data structure to use where. You can use less tuples sets, you can have your way with it in a way. Like in the sense that think about it that if you have to put a nail in a wall, you can use a rock, but then or you can use so many other things. You can use a spanner, but then you can use a screwdriver. But if you were using a hammer, so essentially a hammer can't do what a screwdriver does, a screwdriver can't do what a hammer does. Using the right tool for the right job. That is why the different kind of sequences exist, because they do different kinds of jobs based on where you're using them and what you're using them for. Updating is very similar. You just take the index, you just take the key. So if I had to, for example, update the age, let's suppose I had to do this and then I'll just do this and you will see that this will work. Yeah, now the age is updated. So it's a mutable data structure. I can delete using again the del keyword. So this comes with the del keyword where I tell it which particular key to delete. So I will say, hey, delete the city key. I don't need it anymore. Print person and we'll run it. And that's it. The city key disappears. I've deleted it. Some of the built-in functions, length of the dictionary, which is number of keys. Basically, it will go by the number of keys, not by what is against the values. String will basically give you a string representation of the dictionary. This is useful, especially if you're doing web development and you're dealing with JSON data structures. Type is just inbuilt methods in Python, which will give you the type of any variable, whether that's a string or a tuple or a list or a set or a dictionary in this case, or an integer or a decimal or something else, or even a class object. It will just give you the type of it. There is one thing, if I try to print something which is not present, so let's suppose I deleted person city and now I'm trying to access it, so it will throw an error. You will see very commonly in Python key error, where it is trying to tell you that hey, this key doesn't exist. What are you trying to access? Like, I don't know what you're talking about. Now, in case you don't want errors to come in the sense, it's not a way to avoid errors, but it's a safer approach. So what will happen when you do get is that it will return null or none. You can still put checks against this. So you can say if person.getCity, you live in, right, let me just use this, person get city. However, the problem is that, so you can't do the same thing with this because the moment it hits this line, it will throw an error. But this will just ignore it. You can do an else, print city not found. City for this person was not found. Now, there are certain very useful methods. One is dot items. It will return all the items in the dictionary. So if I want to get person dot items, and then another method which is keys, which will return all the keys in the dictionary. So let's run this. So person dot items will basically return a list of tuples with the keys and values inside it. Keys will just return the keys. This is first name, last name, and age that are present inside the tuple. Then there is of course dict.copy where you can create a copy of the dictionary, and dict.clear which will empty all the elements. So copy is basically just, you can always do assign a create a variable, but copy is just like a safer way of doing it rather than just assigning to another variable because it does a deep copy. So the thing to note here is that what happens with dictionaries sometimes is that because dictionaries in Python, okay, they are not ordered. So you cannot predict for sure if I iterate over it, it will come in a certain order. So let's just see what we'll get here. So of course it iterates over the keys, it doesn't iterate over the values, but there is no order here if you look at it. It's city, first name, last name, age. There is no discernible order in which it has done this. But if you wanted to do it in order, okay, you wanted to iterate over it in the order of the keys where you wanted to follow the sorted order. This is how you would do it. You would get the keys, you would sort it, and then you would iterate over it. So this is when you want to go the dictionary in a sorted fashion. Your dictionary can contain dictionaries as values, which can contain tuples, which can contain lists. It can just go on and on and on like that. The way that you will access it is, of course, by the square bracket notation, and keep accessing till you get what you want to get. So why do we need functions? Let's suppose you need to write a program which calculates the factorial of a number. That is, if you're given a number 4, then it does calculate the 4 factorial, right? Which is 4 into 3 into 2 into 1. So you keep multiplying the same number by itself until and unless the number is 1. 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1. So you do 4 into 3 into 2 into 1. That's a 4 factorial. Now, the logic to implement the factorial is given here. You just input a number from the user, you set factorial that you want to calculate for, and if the number is positive, you keep predicting the factorial, you keep multiplying it over here as shown in this particular line. So you go from range L to comma n plus num plus L, and you keep iterating over this again and again and again. Now, think about it in this way. Let's suppose you need the factorial in multiple places in your program. You want to calculate the factorial of 1, 2, 3, 4, 5, like different numbers. It won't be of a fixed number. You have to do it in multiple places, not just in one file. You have 10 files. What should you do? Should you copy paste the code again and again and again? You can do that, but then thing is that it would not be the most optimal approach. As a developer, your job is to write code or logic. Your job is not to copy paste the same thing again and again. I mean, that's the job of a clerk. So keep that in mind. That way, if you start thinking about in this way, why am I writing similar kind of things or sentences or directions to my computer again and again? See if you can combine them together. So what are functions? A function is a block of organized or reusable code. So as I said, you have to use the function again and again. And that's where this definition comes from. The function is a block of organized, reusable code. So typically when you create a function, the intention should be doing one thing and one thing only. So as you can see here that if we just sort of put the logic to implement factorial in a box and then use this box for an input and then an output like we did in math. So y is equal to x plus 2. So where y is a function in x. So in a similar way you give input, you get an output. Now this is a very powerful idea. As I said, like wherever you think that you are writing the same kind of code again multiple times, you're repeating yourself, put it in a function. So how do you define and call a function? Let's dive into some code. So the way you define a function is with the def keyword and then the name of the function. So here we want to create a function called add. Now what happens next is that you can pass parameters to this function, which is the input value. So a is an input value, b is an input value. In this function, what it does is that it calculates the sum. So of course you could have done it like this as well, right? A is equal to 1, b is equal to 2, and you could have said sum is equal to a plus b. That's it, you have sum. But why wrap it up in a function? Because if you do it like this, the next time that you have to calculate the value of a or value of b, calculate for a new value of a or new value of b, you have to write it again. So it would be better to put it inside a function like this. And then you can just call it for the different values that you need it for. Now, this is the function definition. The last statement is the return statement, which returns whatever is the output. You have to explicitly ask it to return something or whatever it is that you need. It will not assume by itself. So the reason being that, let's suppose you have another variable inside here. Now it wouldn't know by itself that whether you want to send sum or def, because instructions can be a lot in a function. So it wouldn't know which one you want to send. So you have to be explicit about it that you want to return sum. Now to call a function, all you need to do is you need to write the name of the function followed by parentheses and then the values of the input. So you see I'm reusing this logic again and again and again. Let's run this. So as you just saw, I can just simply type print add comma 1 comma 3 and then print add 4 comma 5. So I just asked to print the output of add. Let's run this. See, we get the output on the terminal. Let me try with a different number. We get the output again. So this is how you call a function. Now why do you need to use the return statement? So as I was talking about, it terminates the execution of the function. It also returns a output. So the other thing is that when you're looking at the control of the function, where is the code, where is the interpreter? You need to think about it in the way that once you call print add, this one, the control passes to the add function, where the add function is then executing one by one, one by one. Then it returns the control to line number 7, and then the program goes to the next line. Then it goes in again, then it comes out again with the use of the return statement. So return is really calling, kind of like, think about it, what do you return somebody? So it's not just returning a value, it's also about returning the control to the main path of the function, where it needs to execute even after line 7. It needs to go on to line 8. So there is this concept of main. Let's assume that we have two files. One of them is 1.py and another one is 2.py. Now let's suppose one has this function and you are printing a function top level in 1.py. It has this condition which is checking for something very weird. But underscore underscore name underscore underscore, it's like a invisible variable present in a file. Okay, it's an invisible variable sort of present in the file, which is checking that if the value of this variable is main, then this needs to be printed, otherwise this needs to be printed. So let's take this for a run. So as you can see, top level in 1.py. This gets printed, of course. 1.py is being run directly, where we executed 1.py. So the name was indeed main. Now let's see with 2. In 2, what you're doing is that you're importing 1 as a module. Things that you're doing over here is that you're printing the top level in 2.py and 1.py will be run directly. So with 2.py, let's see what we can get. So top level in 2.py. So instead of this, line number 4, when we executed 2, we first get that top level in 1.py got executed. Now how is this? This is because as soon as you import a file to another Python file, whatever code is present inside it gets executed. If there is one file has something written inside it, it will get executed once you're importing it. That means not that it will necessarily show that it will cause any sort of problems that you're in. The reason why this happens is because certain variables need to be defined. Certain variables, certain functions, they need to come into the computer's memory for that file to be sort of present. Python will load those things, and the way the programmers intend this feature to be used of Python is that people will declare certain defaults. They will want certain things to happen if a file is imported. So it is by choice that the design is existing. It's not a flaw that if you import a file, it will get executed. So importing files is a bad. It's by feature. So file gets executed. Now this gets executed, and then if you see that this time 1.py is being imported by another module gets called, where it is the main module. When once you're running 1.py, it was the main module which was calling it. But since we have imported it from 2.py, it is not the main module. It is the module present in 2.py which is calling it. Now then finally we print top level in 2.py. Then we call the function 1.function function in py, and then finally for 2.py we get that 2.py is being run directly. So same behavior, it is just that over here we had imported something. So whatever is getting executed in the other file gets printed. So as it says, if 1.py file returns the statements from this, only get executed. And when 2.py file runs, first the statements from 1.py get executed, then statements from 2.py. Or rather than thinking about it in this way, that statements from 1.py versus statements from 2.py, think about it in a way of what order is the import statement in. So if the import statement is at the very top, then the other file, and then the rest of the lines, if the import statements are in the middle, then few initial lines in 2.py, and then the lines from the other file. So it's kind of like whenever the importing happens, it's about which place in the code does the importing happen in. Next, let's look at some of the built-in functions. So built-in functions are functions that are given to you by Python out of the box. They're just very some common utilities or functions that you will use no matter what sort of programming language you're in. So almost all programming languages provide for this, and so does Python. So built-in functions are the functions which are built into already available Python and can be accessed by end users. Now, these functions are available to you as soon as you load Python for the very first. So for example, if we saw the print statement, actually the print is also a built-in function. Now you did not have to import print or install something else. It was just available to you as soon as you installed Python. So some of the common built-in functions are given here: sorted, absolute, all. So we will look at these one by one now. So talking about sorted, it returns a new sorted list from an items in an iterable. So which is to say that any array, tuple or list, any tuple, list or sequences, that's what it will return. So let me show you an example here. So you see it gave us a sorted list. So it checks that if the iterable, which is again the sequence, the list or whatever it is, if all the elements are true. So it checks them for being true. So it's not that it needs to be all like true, comma, true, comma, true. It can be true, comma, true, comma, 1, comma, 2, comma, 3. Even 1, 2, 3 are truthy values. They're truth. So it's just more of how Python labels them to be truthy, what it considers to be as a truth value. So this could be another data type. It could be strings, anything which is not false or none or zero. See, these are truthy values. Let's suppose I change this to none. It's a non-truthy value. So it gives a true only if everything is truthy. So truthy is how Pythonists refer it. That's the truthy value, where it is not the truth value, but it is kind of like a positive value. So think about it in a positive versus a negative way. Let's suppose I change this to 0, again false. If I change this to false, of course false. Any, on the other hand, is a converse of all function. That is, it will give you truthy for all the opposite results. So even if one of them is true, it will return a true value. And if you go to the very first example, even then it will return a true value because at least one of them is true. But if we give it as false and none, then it will give a false value. Next is the Boolean function, which converts the value to a Boolean using the Python truth testing procedure. So the truth testing procedure is the same one which kind of gets applied to all of these iterables in any. Think about it internally, calling bool on 0 or none, or bool of 1 is positive, bool of bool is also positive, in the sense that it is a string. So as you can see, this is like any or all, they would internally definitely use something like bool to determine if the value that is being passed to them is true or false. So this is really the atomic version of any or all. Next is CHR. So it returns a string representing a character whose Unicode code point is the integer. Let's see what it does. So it basically takes an integer value and it returns the ASCII character out of it, or the Unicode character out of it, and it goes till 255. Now what it does is that it opens a file and returns a corresponding file object. This is something that we're going to cover in file handling. Then there is the ABS function, which returns the absolute value of an integer, floating point, or complex number. So it takes the negative value of an integer or a float or a complex number. So Python does have complex numbers, by the way, and it will return the absolute value of it. Enumerate returns an enumerate object with items and index values. So we will check enumerate in a little while. It's further along in the slides. We'll come back to it. Then there is the int function. It returns an integer object constructed from a number or string x. So what int will do is that it will take the string of 1, 2, 3 and turn it into this. We give it ABC, it will not do anything. So only when numerals are written as strings, then it does something to them. Otherwise, it will not work on any other special characters or whatever. It will only work on this kind of thing. So sometimes you might need to convert a string into an integer. Then length returns the length of an object. Length of an object being length of an array or an enumerate. Length of this or length of ABCD or length of a tuple, all of these. So globals is something we are going to cover in a little while. So let's leave it for that point of time. Ben converts a number into a binary string prefixed with a 0b. If we take this, we get a binary string which is prefixed by 0 and b. Still 0 and b. Now eval is a very interesting thing. It executes whatever you have written within strings and passed it to as a parameter. It executes it like it's Python code. So in the sense that if I type eval print 4 plus 5, it got executed like Python code. So the reason it is throwing an invalid syntax is because it's a security flaw. So security problem. So right now in my interpreter, the security is turned on where it will not let me execute anything which is a little more than arithmetic. And that is how, like, usually you will find the setting of Python to be that's sort of encouraged here. Now, the thing is that eval is used to execute Python code, and the reason it can be dangerous is that let's suppose eval something and it deletes all the files from your machine because you just allowed a user to put in an input and that was fed into eval. The user was a malicious user. They end up making you execute their code on your server, whatever they want to do from your Python code. Next is sum basically iterates over the iterable that you give it, which is again an array or a list, and it sums up all the numbers. So if I do a sum of 1, 3, 4, 5, reverse on the other hand will, as the name suggests, just reverse it. So you have to do this with the loop. You can't do this without the loop. So it just gives you an iterator object. It doesn't give you an actual list over here. Let's look at the enumerate function. So what the enumerate function does is that it returns an object. So the value that it must be passed to it should be an iterable again. So you pass it an iterable and then it returns a list of tuples, and the tuples contain the index value and the items from the list. So if you notice over here, what we have done is that we have passed it the list grocery, bread, milk and butter. What enumerate will do is that it will print the enumerate objects over here if you convert it into a list as 0, bread, 1, milk, 2, butter. Let's take it for a run. So first is that the enumerate, this thing returns an object, enumerate grocery, the type of which is enumerate. This is basically a function enumerate which is returning an object with the type enumerate. Then you can convert it into a list using the list function. The list function takes an enumerate object and it will give you then a list of tuples, each of which contain the index and the value in the index. Let's look at a couple of more examples of functions. So when it comes to function definition, you define it by print name, where you do some operations, take the input, do some operations, and you return an output. Call a function, you just need to call it, you just need its name followed by bracket. And finally, you get the result in whatever form you want. Let's look at lambda functions. So lambdas are basically very small functions for a very quick or small operation where you do not want to define an entire function. So it is a shorthand notation. It is a shorthand way of writing a particular function which are not more than one expression in line. So they cannot contain commands and they cannot contain more than one expression. So once you look at the syntax, things will become a little more clear. They can take any number of arguments and returns the value of a single expression. So the syntax goes like this. Lambda is a keyword followed by the input. I know that there are no braces around this over here. So the way you need to look at this above expression is that it's lambda, then z. So this is not the correct syntax, but I'm just trying to show it to you. And then what it must do to z and return at the same time. So this part or this part is what would be returned by this lambda function. And this is the input and then output, where we are saying that for this input, give this output. Now notice that how you have written this in one single line. You could have also written it like this. So even this would work. You can still call line 7, nothing changes. But the difference here is that this way it is just a concise way of writing it. And then the variable that lambda is assigned to. So basically what we're doing is that we're taking a function and we're assigning it to a variable. Like we even do even otherwise, right? If you were to define a function answer, and then it would basically be used from here on afterwards. So like if you had to call this function, you would call answer in this particular way. Even to call a lambda, what you have done is that you have taken the expression of lambda and have assigned it to a variable. Now let's suppose you need to print the answer and this is what will get executed. So you're pretty much calling it like a function again. We got the answer is 28. So to do 2 and run it again, the answer would be 8. 2 multiplied by 4. Now, this is still a named lambda function, but then one of the biggest uses of lambda, the reason why it exists, apart from it being concise, is that it allows you to pass another function, a function as a parameter. So if you had, let's suppose, these typical functions that exist in any programming language, which are map, filter, and reduce. So what map does is that it takes a list of items and it maps them to certain things. So for example, to show it to you, first, let's look at the result of this and then I'll explain what map is doing. So map, what it has done is that it has taken each value in 1, 2, 3, 4, 5. If you can just sort of compare, it seems that it has multiplied them by themselves. So 1 multiplied by 1, 2 multiplied by 2, 3 by 3, and 4 by 4, and 5 by 5. So it has squared them, where this was mapped to this, where you can see that these set of outputs, they came from each of the individual elements in this particular items list, and they're on the same index. So because they're on the same index in both the lists, you can sort of map them. Now this is what a map function essentially does. Now what we can do is that in map function, the first parameter is what do you want the current list to be mapped to. So in the sense that how do you define the mapping? Does it have to be a square every time? What if you wanted a cube? So what lambda allows you to do is that it allows you to do these very neat things. If you notice, this is very concise as compared to writing a function def squared x, not even x, it will take items, and then writing for item in items. So one is that you write all of this or you write it like this. There is a definite neatness over here, but the reason why it takes a function as an object, now doing it through lambda is way better than writing a function like this every time. The next of these sort of functions are filter. Filter will check each item in your particular list and apply a filter to it. It will remove some items from the list which do not match a certain condition. So we took a range of -5 to 5, which is the numbers are from -5 to +5, 10 numbers, and we passed it to filter. Now what filter does is that it takes the list, applies this to each in every individual one. Each and every individual element is applied to go through this lambda function. Now this lambda will either return a true or a false. What filter does is that it keeps the true values. So for whatever items in this list, this expression turns out to be true. This filter function will take those elements only. So x is less than 0 only for -5, -4, -3 and -2 and -1, where x are these values, and that's what it is going to return. Final is reduce. So what reduce does is that it takes your list, applies some operation to it, and it basically gives you a final single output out of it. So it will keep applying the same output to again and again. It's like decrement operator. Think about it like a decrement operator, which takes, let's suppose I do for minus minus and I keep calling it again and again and again. So what it will do is that it will reduce the number from 4 to 3 to 2 to 1. So where it takes the previous output as an input and keeps applying it till the time the list it reaches the end of the list. So let's see what this is going to do. 24. So how did this happen? It took 1 and initially this was 1. So 1 comma 1. 1 comma 1 is 1. Then 1 comma 2 came in. So 1 was multiplied by 2. Now the value of y is 2. 3 comes in, the value of 3 star 2 is 6. Now 6 comes in an input and 4 comes as an input, so 6 cross 4. So basically it multiplied all of them by themselves. Now we can do an interesting thing. Let's see what is the result of this. See that we're going to square the first number and we're going to multiply it by y. So let's see what is the value of y, because our output will depend on that in terms of what is being squared. So when we square this, we get this value. But if you look at this one, the value will be different. So as you can see that we can take two inputs as well for a lambda. So n number of inputs are possible, but only one expression and only one output. Let's look at scope of variables in Python. So Python has two scope of variables, global and local. Now global variables are defined at the file layer. They get assigned as soon as the file is run for the first time. Local variables, on the other hand, are defined within the scope of functions or code blocks. So if you look at this example over here, A is present everywhere in your code. So A can be used even by this function internally, and it would be referred to the global A because it is outside the function. But if I was to use B outside the function, it would throw an error. As the slide says, the local variable present over here is B, which is inside the function and can be only used within the given function. And here is another example. So when you print A, it is outside. But if you try to print C, which is inside add, it is not available to you because it is not a global variable, it is a local variable. So everything which is within add is local to add. Next is memory address. So if you have two variables A and B, you can know the memory address of either one of them through this way. So if you want to know the memory address of a variable in Python, all you need to do is call the inbuilt id function, which will tell you the memory location of that particular variable. So let's try it out in the terminal. So let's say I have a is equal to 1, b is equal to 23, and then I do ida and idb. As you can see, the numbers are different. In terms of where would you use this, it would really depend on what you're working on or what you're building. Usually, it is not something that you need to deal with on a day to day basis, because these things like IDA and IDB, I mean, this is relevant more when you're dealing with lower level things in Python, but not if you are doing data science or stuff like that. This is not really something that you would end up dealing with unless and until you're making something related to memory management in particular, which is anyway already done for you. Next is function arguments. So the number of arguments in the function that should exactly match. These are the required arguments. So if you look at this function over here, string has to be passed to this function for it to run. Otherwise, it will throw an error that print name missing one required positional argument str, the name of the argument that it is expecting, and that in the method call it is missing. So this is basically saying that it needed an input, but you did not provide the same, and so it cannot function just like that. Next, we have something called as a keyword argument. When you use a keyword argument in a function, the caller identifies the arguments by the parameter name. So keyword argument works like this, where I can pass this particular argument where I'm saying that Annie is the value of string. Now, it doesn't really hit you over here, but let me show you another example on why this is useful. Suppose you have a function add which takes 4 parameters. Now, let's suppose it is not just a simple function, just something, just a sum. Instead, let's define a new function called random function a, b, c, and d. It does a sum of a star star b, a star star d, plus c star star b, and it returns the sum. When you're calling the random function, you might need to remember, hey, okay, what do I need to do? Do I need to 2 raised to the power 5? So you'll have to map it, see what is being used where. Instead, if you just label it, where you say that d is equal to this, consider c as 3, consider a as 2, consider b as 5. Now you're telling Python that this is what it needs to map to. So it will not then be dependent on the original sequence only. It will take it as you have passed. This is super useful because as you can see now I can call the function in any fashion as long as I have used the function parameters clearly. The order doesn't matter anymore. And in fact, I would recommend this to you that rather than calling a function sort of, let's suppose, this particular way, where we could call it like this as well, R5, but I would not recommend following this. I think everybody should strictly just follow this particular approach. Much cleaner, a lot of benefits, makes your life as a developer much easier. Now, such as a default argument. I always wanted d to have a value of 3 even if it was not supplied. So I could just do this and I could remove the value of d altogether. So I can pass the value of d like this. So this is also correct. But what I've done now in the signature is that I've given it a default value of 3. That d should always have the value 3 even if it is not passed. Implicitly it should have a value of 3. So another example here where age has been predefined. Unless and until you provide the age explicitly, it will take the default value of 50, which is being supplied when you're creating the function. So you're setting the default value of a particular function naturally when you're defining the function. So another example is of salary. So where there is a basic salary of, let's suppose, 10,000 rupees that is given out any which way, irrespective of who the person is or if the salary is not defined. The reason these default argument exists is either because there are particular parameter is going to have a default value, or in most cases it is going to have a set value of a sort, and what you need to do is that only in certain scenarios you will change the value. So ranging for various reasons, people could be using something of this sort. So sometimes you may not know how many parameters are required, how many arguments are required, and you might need variable length of argument where you can pass it n number of arguments because you just don't know how many arguments would be needed. So let's suppose you're building a very general mathematical calculator in Python. So if you think about multiplication, you don't know if the user is going to multiply 3 numbers or 4 numbers or 5 numbers at a time. They might just input 7 cross 5 cross 4 cross 3, or like the factorial example where we had to repeatedly multiply. So any operation that typically be done repeatedly or have a repeated output, the function receiving the data in this way can probably not define that it needs what all number of arguments it needs. So to handle those cases, we have this star operator. So as soon as you place it in front of a variable, in front of a parameter over here, you can pass n number of values to this function. So see, what will happen is that you might think that okay, this second one is the correct way to call it, but no, even the first one is correct, where this can be 0 or n arguments. There is this option of info any Dave. It could also have had a third parameter, and that second and third parameter would have been accepted here as a list that you can sort of iterate over. So let me show you through a quick example. So I've defined a function print users, pretty similar to one that we saw earlier. Let's suppose Eureka is one of these. And then the other users are, let's suppose, admin, CEO, CTO, manager. Let's call this. Getting back to this, once you run it, as you can see, the first user argument is Eureka, and then user received from variable length argument is CEO, CTO, admin, so on and so forth. And it is received in the same order over here. Now, another way is passing keyword arguments. So these were star arguments, and then there are keyword arguments where you can pass the same thing but with a key value pairs. If you look at this, arg1, arg2, arg3, 1, 2, 3, 4, 5, 6, 7 are args, and then you have these coargs which are named sort of like named parameters, but because they are received after args, they would be available as a dictionary over here. If you look at non-keyword argument, they are available as a tuple. Now Python does it internally. Again, the purpose of this is that to make the functions flexible to receive different kinds of inputs, where there's a lot more flexibility in this mechanism as compared to fixing what the function can be like. So this also deals with the OOPS concept of polymorphism, where you can call a function in multiple ways, and it's just about the way you're calling it that the output will be manipulated. Now let's look at the difference between procedural oriented programming and object oriented programming. So in procedure oriented programming, the program is divided into functions. Okay, that's so functions is the central concept when it comes to procedure oriented programming or functional programming. In object oriented programming, the program is divided into objects. Now POP follows the top down approach, that it views the entire problem from the very top and it builds downwards where it says that okay, I need something which can give me an output of this sort, which can then further be divided into okay, this thing needs to do these five things, so let's make functions out of those. So you start from the very top of it and then you keep adding blocks smaller and smaller and smaller in size. OOP follows, however, the bottom approach where it looks at the different building blocks that are needed, defines them as objects, defines the relationship between the different entities, and then starts building your system. Now, in procedural programming, data needs to move freely from function to function in the system, as definitely is the case. In OOPS, objects need to move and communicate with each other through member functions. Some examples of POP are C, Visual Basic, Fortran, and Pascal. Examples of OOP are C++, Java, and Python. But the thing here to notice here is that even Python, for example, through its lambda functions and through certain other ways and mechanisms, allows for procedural programming. It is not that it doesn't allow for procedural programming, it is more of a style. So ultimately, either of these are just styles of how you program. No language enforces these, but it rather gives you features to do those things with it. So think about it in this way that a car has many features, right? But you might not use all the features. So the car can drive fast, it can drive slow, it can drive in reverse, but you may or may not use all the features. Just driving fast. So some people don't like to drive fast at all. So they will never hit the maximum speed, but the car can actually do that. In a similar way, programming languages have features built in where they allow for you to do a certain thing in a more easier way or they're more oriented towards it. That doesn't mean, however, that you cannot make it do something else. Of course, you need to be experienced enough to make it work like that. Let's look at a few object oriented concepts. So Python is very, again, object oriented. It supports it. It has a extensive class mechanism and structure that we're going to look at in just a few minutes. What object oriented does is that it makes your code reusable and makes it possible for you to write less and less code. It also relates very well to the real world scenario where you can sort of say that immediately when you think about the word object, n number of things can come to mind. So everything is an object, like in the sense that a car is an object, a chair is an object, a table is an object. Now, given that everything is an object, it makes it very easy for you to kind of imagine or model the real world in your application. And naturally, if the code is reusable and all of these nice features are there, the programmer is able to produce faster, more accurate, and better written application. However, Python oops is different than other languages. Naturally, I mean that's why it's a different language to start with. For example, in Java, you cannot create a file without defining a class. So like there are differences, and Python is an interpreted language, as we know. It executes code line by line, and that's not the case with Java. So Java is a compiled language, while Python is an interpreted language. So Python OOP is different than other OOPs. Let's look at a use case. SRT is a multinational company. This company wants to create employees information sheet, which will include the name, employee ID, and their progress. Now let's look at an employee and his weekly, monthly, and his progress column. But it will be difficult to create separate sheets for every employee. So instead of that, they decide to create one class of employees information and create object of every employee called class for the new employees. So this is basically the archetype where they define, hey, this is a blueprint of a class. This is what an employee has. He has a name, he has a first name, he has a last name, he has a salary, he has an age, he has a gender, and this is his role, this is his department. So all of these things are called as attributes. And if you look at it, right, that every employee typically would have those attributes in the real world as well. So a class is nothing but a blueprint of a real world object where we try to model that object by using classes. So when I say model, I mean we try to describe it in code. So when it is the word model comes in when actually you try to be a little more formal with things, especially in the context of science and programming, where you're modeling a certain scenario or a certain situation or a person or an individual or an object. In terms of English, it is more called as description. So when you're talking about languages, it's like describe a ball to me. But when you talk about programming, they are a little fancier. We are somewhat fancy people, so we say let's model the ball. So modeling the ball would involve describing it, storing its height, its width, its diameter, sorry, color, its shape, its material. So the same thing goes here where you're trying to model an employee. What all is it about an employee that is relevant to us as an organization? So similarly, right, another thing is that their employee can be one particular thing, but they're defined with certain parameters, but the attributes will change from person to person.
because at the end of the day, every person is unique. Similarly, class is just a blueprint. So if you look at a cycle, right, or a bicycle or a two-wheeler basically has a blueprint of having two wheels and having a brake. That is a basic blueprint, right? And from that, you can have various objects, whether it is an automated vehicle like one of these, or it is not automated vehicle like this. Whether it has red color or green color or pink or red color doesn't, like, it can keep changing, but doesn't change the fact that this is still a particular implementation or a particular instance of the cycle object. So like a human being, for example, the anatomy of a human being is the same across all the 7 billion people in the world, right? The anatomy is the same. That is the blueprint, that you will have certain number of muscles and certain number of bones in your body. But then still the each and every person tends to be different. So this is what this is. This is the anatomy of a human being. This is the variation that comes from this anatomy. Now let's talk about relationship between class and objects. A class is a template for objects. It contains all the code for the object's methods. A class describes the abstract characteristic of a real life thing. So as I was saying, that it describes something which we see in the real world, but in programming terms. An instance is an object of a class created at runtime. So when you use that blueprint, so just creating the blueprint does nothing. So like you need to, declare a function, then you need to call the function for it to do anything. Similarly, just declaring the blueprint of a class does nothing in Python. You need to actually create an object using that blueprint. You need to say that, okay, let me bring it to life. This is the blueprint. Let me actually construct it in memory. Let me actually set it up in memory. I just have the blueprint with me right now, doesn't have the actual value. And of course, there can be multiple instances of a same class. So to create a class, what you do is that you use the class keyword. Class keyword followed by the name of the class and parenthesis. So of course, a class at the time of creation can take certain arguments inside it, and we'll see what it does with those arguments. But just a very basic definition, you declare a class, the number being the name of the class, and then the statements within that class. To create an instance of a class, what you need to do is that you need to take a variable, you need to call the name of the class and followed by parents, which will create the class for you or create the instance of a class for you. Now, if you look at this, they have printed X, which is says that it's a object at so and so memory location. So then it's like a variable. So this is nothing more than a variable then at the end of the day. Now, definition of a method. So self points to the class object. Instead of self.hello, we write ob.hello. Now, right, what is happening over here is the first parameter of a method inside. So a class can contain methods inside it. First parameter that the class automatically supplies to itself is hello. So when you call this ob.hello, internally Python will call this hello method and it will pass the self object to it. What is self? Self is this object ob that we define.
Next, let's talk about scope of variables when it comes to classes. The variables which are not declared in the class within the scope of the class, they are global variables. So like we saw with functions, right? Where certain things which were certain variables which were defined inside the function, they were local to the function or the enclosure created by the function. Similarly, for classes, the same concept applies, where variables which are defined inside the function are local to it and variables which are defined outside are global. And the global variables, as usual, are usable everywhere. Now, if the variables are defined inside the class, they're local and they cannot be accessed without using the class. So this b is equal to 60. If you try to print b directly, it will not work. Let me show you how. So I'll just comment this. Let's suppose I declare a class demo and it has a variable b, variable 23 inside it, and outside I have a variable b which is 45. So I can do this anywhere. Okay, so even in this class I can print b, like inside a function or whatever. But if I try to do this, it will not work. So even if you notice over here, right, let's try to run this. So it says name is a is not defined even though the variable has been defined over here. However, if we do this, let's see if we can do this. This works. So demo.a, where this variable has been defined inside the class, it is not available unless and until you refer it to in this way. So you really need to see whenever the variables are defined and you get any of this error that variable is not defined, but you can actually see that it is present in the code with the no spelling mistake. You need to check if the scoping is correct or not. Please be very careful. These are some of the initial mistakes a beginners make. So don't be demotivated whenever you see this. It can be very confusing at times, but just look if you can access the variable from that particular location or not. Let's talk about attributes. So, as you said, that classes are nothing but blueprints of real world objects. Now, when it comes to a real world object, it would have certain properties. So, for an employee, right, an employee has properties such as name, employee ID, let's suppose their progress percentage in a certain project or something else. And that is what really defines the blueprint. Where when we model the object from the real world into the programming world, do it by defining its attributes or its properties, because that is how we represent it. Now, you may say that, hey, this is not a complete representation of an employee, in the sense that, okay, I know something about this person now, but I don't know all the things, which is fine, right? You know those things about a particular person that are relevant to you. Like if there is a colleague, you may know a lot about their professional life, but you may know little to nothing about their personal life. Or you might know about their personal life as well because they're your friend or something else. So, in a similar way, depending on what you're trying to do with that object in your software, in your code, you define the attributes that you need, not all that is present. So, there are two types of attributes: built-in attributes and user-defined attributes. The built-in attributes like built-in functions are made available on a Python class object by Python itself. So there are certain properties and you need to think of these. So one question could be that, hey, if the blueprint of the class is defined according to me as an individual, according to my needs as a software developer, why is it that built-in attributes exist? Like how can Python know anything about, so if I am declaring an employee list, how is it possible that the developers of Python would know anything about my employee class, right? How is it that they could imagine built-in attributes? The answer is that these built-in attributes usually are there for obtaining a class and contain meta information about that class or that object. They're not really something that what you see the class as. So these are more things related to how more tools or information that Python needs rather than what Python needs to run that class or to execute that piece of class or code rather than what you would want to describe. And then naturally there are user defined attributes. So user being you as a developer. So you can replace the word user here with the word developer. So developer defined attributes that you are using to model the class. So first let's look at built-in class attributes. So I've done nothing but I've defined a class Edureka and there are certain built-in attributes available. Now don't be confused with this. Why is it underscore underscore? It doesn't mean anything special. We will cover this in a little bit. It's just a way Python writes certain special attributes. So special in the sense that it's just a visual recognition. So it's not that there's a very can't be a string or a number or an integer. The value would be somewhere along those lines or an object. It is just that as a Python developer, the moment you see this, you would know that, hey, this is not your usual attribute. It is either a built-in or it is something else. So it just creates a context where you can just look at this and recognize it as something different from a user defined attribute. So let's run this, see what the output is going to be. So edureka dot underscore underscore dict underscore underscore. What does this do? It contains the namespace of the class. So the namespace is a very important Python concept when it comes to handling files in terms of Python files and code execution. You need to know this if you're really architecting a big piece of code with Python. For now, we don't need to get into the details of what a namespace is, how exactly namespaces work, but just something that good to know that you can sort of get the namespace of the current class. The next one is dot underscore underscore doc. Now, every Python class can contain a doc string, like a comment string explaining the class. And if you want to print that for some reason, okay, you want to print the documentation, you need to use this method call. So it needs to be in a particular way actually. The doc string needs to be within single quote. So if you notice over here, it has printed this particular doc string. Now please notice that if you place this doc string anywhere else, like if you place it outside, this will not work. So let me just show it to you. So there is no doc string, but the moment I place it inside over here and I run it, the doc string is present. Next is pretty simple. It gives you the name of the class. So underscore underscore name, and Edureka class name is Edureka. So whatever is the name of the class here, so Edureka name. I can do the same thing. I need to change it over here as well. Right. So if you're wondering where you might use this would be used if you are really building some sort of framework or library with Python. So in the sense that this is used by large sort of systems that are being built, because that is when these things are sort of needed way more than they're needed if you're just trying to build a website or if you're just trying to do data production or data visualization or analysis. It is not exactly that you will use all of this, but this is required if you are especially architecting a big solution using Python. Next is the module that we are in, which is the main module. So main is something that we covered earlier as well. If you might remember, if name is equal to main, in the beginning of this class, when we were calling the function from two different files. So it is just the module which is calling the particular file, and we know the main module always calls the file. Let's look at bases. Okay, so what are bases? So if the class is deriving from another class, then basis has a value. It's just something that if a class can essentially derive from another class. It's called the concept of inheritance, much like either one of us inherits from our parents. So in a similar way, if the class is inheriting from another class, that is where you use to get the list of base classes you get, and it can inherit from multiple classes as well. That's where you get this edureka dot underscore underscore basis underscore underscore. Okay, let's come to attributes defined by users. So attributes are created inside the class definition. Pretty obvious, right? We can dynamically create new attributes for existing instances of a class. So you can also create dynamic attributes for an existing class. There is no restriction on that. You can keep attaching that as you go along. So there are three kinds of attributes. There is a private attribute, which can be accessed only inside the class definition. There are public attributes, which can be and should be freely used. Then there are protected attributes, which are accessible from within the class or its subclass. So subclasses, what are subclasses? Again, it relates to inheritance or basically that derivation bit. Now, we will cover that soon enough, but just know that there are private, public, and protected attributes available inside a class. So the way this works is that if you want to declare a variable as public, you don't need to do anything. You will just declare a normal variable on self. So self.pub, this is the attribute on the class over here. If you want to define it as protected, it needs to start with an underscore, and if it has to be private, then it has to start with a double underscore. Now, here is the thing. If you want to access it, you can try accessing it like this. Now, the thing here is that ob.pub and ob._pro. So let me just show it to you. Let's see what the output of this is going to be. So I am public ran, I am protected ran, but this one I'm private did not run. This one did not run even though it is declared. Python threw an error at us. And that's it. Like that's all you need to do to make it a private variable. Now it's underscore protected. But how is that working out? Because you told me that the protected attribute can be only accessed from a child class or can be only accessed within the class. Here's the thing. Python is a little fluid or relaxed with these rules. So this is more of a convention. So as a Python developer, this is the fact that the variable can only be accessed by a deriving class or within the class. It's more of a convention than a very strict rule that it is enforced. And you will find that to be true even for the private one, as I will show you that there is a way to even access the private variable of a class. So some people find it very weird and odd that why is it that you can access all three essentially, but why is it that then there's a distinction? It's more on an honor system of each other where Python developers just sort of are trying to indicate to each other that, hey, don't touch this thing, but if you want to, you can essentially. But if you're doing that, then people will notice immediately. So experienced Python developers will immediately notice that, hey, this person is making this particular call and they're going to question you. So in case you're working with senior developers, they will ask you, hey, why are you doing it like this? So you better have a good reason for using it then. Right, so as we saw that Python uses two underscores to hide a method, and two underscores can also be used to hide a variable. So we saw it for the variable, and the same thought process applies to a method as well. So I can declare a method over here. And if I try to do this, where I try to ob.__ private method, see, PyCharm has already highlighted this. There's a problem with it. It's trying to tell me that, hey, you can try and run this, but this will not work. This will most probably not work. So let's try that out. See, it did not work. So yeah, now the big reveal where you can access the private method. You can access the private method, but you need to do this. You need to use this really weird syntax of appending edureka, the name of the class. So this portion, you need to append it to the name of the variable or the attribute of the method and then call it. So let's try and call it like this. See, this runs. So even private methods or attributes this way are accessible. So if I try to do this now, ob dot underscore edureka, and the casing has to be exact. So underscore edureka as it is. You should copy paste, in fact, for if you're just beginning out with this. Then pre, and then you run it, right? So I'm a private method, both get executed. Now, class variable and instance variable. So we've already done this where we have defined a class, we have set the blueprint for a class, and we are defining an instance of class edureka over here. Now you can set the course and you can print. The class variable is shared by both instances, object 1 and object 2. So in the sense that there are two things here, where if there is a variable like this domain which is defined at the class level itself, it will remain same across different instances. So if you look at this one, right, ob1.domain and ob2.domain, both of them are data science, but the name ob1 and ob2 can be different. So think of this as a common shared property across different instances of a particular class or particular instance of objects of the class. For example, for human beings, if the attribute is number of eyes, if the class variable is number of eyes, the default value will always be like 2, right? So there is no human being which is born, which is genetically a single-eyed human being. Yes, there are people who are blind. Yes, there are people who are born with neither of the eyes working. But genetically, all human beings are supposed to have two eyes, not three, not one, and that is going to be fixed. So think of it in that way. It is that particular class variable which is being shared as an attribute across different instances, no matter what the instance is. Okay, next let's talk about constructor and destructor. The constructor is implemented using the underscore underscore init underscore underscore function, where you can define the parameters that will follow the self object. The destructor is defined using the underscore underscore del underscore underscore third name, and it is called when the object is deleted. So think of constructor as building constructor really that does the construction of your object. You laid out a class which basically is the blueprint of your object. Now to create an instance of that object, the constructor will need to swing into action to actually make that object. And similarly, the destructor will basically come into play when you delete that object. So think of like a skyscraper which is being constructed and which is being destroyed. Construction would need certain things to happen, right? And destruction would need certain things to be cleaned up and deleted. Now, init basically stands for initialization. So that's initialization and this is deletion. So let's look at an example. So over here, for example, this is an constructor which has the private, protected and public methods, public attributes being set on it. And similarly, I can define a destructor where I can say, let's suppose I can set it to none. Let's print. Now let's talk about multiple constructors. Now multiple constructors are basically used in case you want the same kind of blueprint of an object, that is the same kind of class, in different ways. You want to initialize it in different ways. The way you do it is by using a decorator such as @class method on a particular object. Now what this decorator does is that it passes the CLS or the self object to this particular thing as well. So for example, let's suppose I wanted to create another constructor. I would declare a class method. And this basically takes CLS, which is pretty much like self, and let's suppose this time I want to so if you notice over here, right,
What has been done is that you need to call the particular method at the time of creating the instance. So what I'll do is that I'll create an object ob is equal to edureka dot my customer constructor and pass it a value of 400. So normally I would have created an object. So if you talk about a default object, it will be created in this way. If you create a custom object, it will be created in this way. Now, certain key concepts within object-oriented programming are abstraction, encapsulation, inheritance, overriding, and polymorphism. Let's look into these one by one. Abstraction. Abstraction is simplifying complex reality by modeling classes. So what this means is that if you look at a fan, right, you don't know how it works internally. Most of you wouldn't know how a car works internally or how an engine works or how the horn works. But you just know how to interact with it, make use of it. If I talk about something as simple as this statement of print hello world, does it work? How does it work? How does it print something on the console here? I'm pretty sure most of you will not be able to answer it, and even I would not be able to answer in the sense that it would require for me to look at how this has been executed. So the details of how this is happening have been sort of abstracted away from me. I need to really open up the Python libraries and the Python code base to understand how this is making something print over here. So when it comes to learning Python, right? If we were to start doing that for each and everything, we would never end up finishing learning Python. We would never be able to learn anything for that matter, or be able to learn to use anything. So abstraction needs to happen, and it happens in every programming language where certain things are working in a certain way, but you don't know. And you don't know till the point you need to do something out of the ordinary with that particular method or object or whatever it is that you're presented with. So in case you want to repair a fan, because there is no repair person around, and or it is too expensive to repair a fan or a car, that is when you will end up learning about it, not when you just need to turn on the fan. Encapsulation refers to combining the code into interfaces. So this includes writing methods, creating variables, using classes, any sort of enumerates, creating a list, where you're encapsulating, where you're collecting it in a more transferable way for it to be reused in multiple scenarios where it is flexible in that sort of way. Inheritance simply refers to the fact that there is a relationship, there is a parent child relationship between most of the things that we see around there. If you look at the vehicle, right, there is a parent child relationship where bikes belong to the category vehicle, cars belong to the category vehicle, buses belong to the category vehicle. Probably cars, buses, and trucks could have another subcategory after vehicle, which could have been four-wheeled vehicle, and then subcategories underneath. Same goes for bikes. So inheritance is something very naturally occurring, and same is available to us to use in our programming to model the real world, because that's what software is all about after all. Now there are multiple types of inheritance. One is a single inheritance, that there is a parent class, there is a child. Then there could be multiple inheritances, that a class C is inheriting from A and B, and then there could be multi-level inheritance. So this is like a parent and a father and a mother. This is like a grandfather, father, son, grandson. So B is the father of C, C is the son of B, but B is the son of A, and A is the father of B. Let's talk about simple inheritance. So basically what inheritance does is that it allows us to extend the properties and methods of one class to another class. That is, if one blueprint has certain properties and certain things which have modeled the world around us, right? Where an object, for example, I suppose an object definitely has a weight in the real world, right? Doesn't exist an object that you would call an object in the real world that doesn't have a weight or doesn't have a width. So those are common properties, but then there are properties which are unique to a certain object, such as, let's suppose, the color of the object might be different for different objects and may or may not exist for certain objects. So for example, if we consider even water, like a mass of water as an object, then the water will not have any color because water is essentially colorless. The color property doesn't exist, but the other properties still exist for this particular object. And the way this works is that you can define a base class, and you can define its attributes and its methods. Then you can define another class which inherits from the base class. The way inheritance works is that you just need to supply the name of the class to the child class. And now when you create an instance of the child class and you call the function fun, even though it is not defined over here, but it is defined over here, this gets executed. So let's try this out and see if this works or not. So in class base 1, now I can always have another fun class over here, and I can run this one instead. Now I'm in class sub. So the way this works is that it will first look for the class name within the immediate class, and then it will go up the chain of finding it for the parent classes. Let's talk about multiple inheritance, where you have one class which is being inherited from two classes. So let's look at this one first. There's the first object, there is a second object, and then there is a third object which is inheriting from this first, second, and the first one. And when the init method is called, let's see what gets executed. Right. So when we are doing this, we are also calling the super method, which is calling this one. So this is basically saying that call my superior, call the class which is sort of which I'm inheriting from. And because it is inheriting from both second and first, both of these methods get called. First gets called and then second gets called, and of course even the third one is printed. Then of course there is multi-level inheritance. So multi-level inheritance, the way it works is that a single class, as in the grandfather, the father, and the child. So you have an animal class which can always eat. You have a dog class which will bark, and then you have a baby dog which will weep, which has a weep class. So you can create an instance of the baby dog class. You can call d dot eat on it. You can d dot bark, d dot weep. So if you see, we wrote less code. Otherwise, we would have had to define these pieces of code again and again. So this is a very, very powerful concept that is available to you in programming, that you can reuse pieces of code again and again through creative ways, either by creating them as functions or wrapping them within classes and creating these sort of relationships between them. Okay, so method overriding. Now this is something that we did even for in the earlier example when I had showed you classes, right? I had shown this to you where I could override a method, but let's look at another example. So if you look at this, this is a parent method which is my method, and then there is a child which is another my method. Now I can create an instance of the child variable and I can call my method on it. Now even though my method is present in parent, the child one will get called. So let me run this for you. So child method was called. See how we did that? So this is another relevant example. You have a class rectangle and you have a class square which is inheriting from rectangle. Now when you call on get area, we call the one which is present inside the square because we want it to be printed in a certain way, is the area of square. So this will not naturally, if we call get area of rectangle, it will print is area of rectangle, which is not incorrect because every square is also a rectangle. But then we don't want to do that, right? We want to call get area of square, and that is where method overloading or overriding will help us out, where the child class overrides the parent class method. So polymorphism is the ability to leverage the same interface or different underlying forms such as data types or class. Now, in the sense that a millionaire and a student both have to pay the bill, but maybe the way they pay the bill is going to be different, and paying the bill changes based on what is being called on. So polymorphism basically says that the same thing or same object can behave differently in different scenarios. So if you are a student, you may pay your bill by taking it from parents, but if you're a millionaire and you're paying your bills, you might pay it through the credit card or you might pay it through your debit card, in through different ways. So since that paying bill is something that is common to a person, right? But the way it is done, it might change based on who is paying the bill. Look at this one, right? The class cat is being derived and the class dog is also being derived from the animal class. If you observe that both of them have the talk method, right? And c.talk and d.talk will behave differently. So polymorphism, I mean, of course, now what you have done is that you have used the concept of method overriding as well over here. But animal.talk is present on all animals. However, and cat essentially is also an instance of the animal object. This is polymorphism is because essentially both cat and dog are animals. But when called talk on it, both of them behave differently. So same kind of attribute or method being called, but the behavior is different, and that is polymorphism, where you have multiple forms of the same object. So there is also something called as a getter and setter method. These are more or less, programming conventions. So you can directly access the attributes or you directly set the attributes of a class. But then you can also use getters and setters where you set values and you get values. And this is basically more of a conventional way. The reason these methods are prevalent or are used is because a lot of times you may need to modify your data before you're using it. You may need to, add symbols to it or do some modification before you're setting it, and you just don't want anybody to be able to do it. You want it to be done in a safe and secure way. Maybe this object is being set by the database and you don't want just anybody to access the database just like that. You want the access to happen through a proper defined channel because it is complicated otherwise. That is where you will use setters and getters. So let's have a look at an example. Class Edureka, we are setting the course name. We are creating an object of Edureka. We're going to print get course name. Then we're going to set the course name. So we could have also done this, by the way. The alternative could have been this, right? But let's suppose you had to use the uppercase. You had to uppercase it, right? Every single time. You have to print only the uppercase one. This is a transformation that you have to do on the data when you're updating it. If this is to be done every single time, it would be cumbersome to write dot upper every single time and make every developer in your team remember that. Or the same thing could apply to this, where when you're returning the course name, you're always, setting it to uppercase. So that is why you would use getters and setters. See how we did that? Now we are done with OOPS. We have had a basic introduction to OOPS. Let's move over to standard libraries that are available in Python. So standard library is a collection of tools that come with Python. It includes the following. It includes the built-in functions, the modules, the packages. So some of them we have already been using, and let's look at some others. Modules used in Python. So module basically allows you to logically organize the code. It can contain classes, functions. So one simple thing is that I have a utilities module, or you can have a DB module which does all the DB interactions for you, or something else. So any sort of logical wrapping of code, logical being not ones and zeros, but logical for you. That hey, this chunk of code should go in this file. So this file deals with database, and this file deals with let's suppose PDF, and this file deals with file handling, and this file deals with this. So let's divide up the code into logical breaks, and then you call it a module. Finally, they are nothing but Python files with the .py extension. So it's not that they are different from any of the other Python. It is just that they're called modules because they're organized in a certain way. And as I said, a module is a file containing Python definitions and statements. So when we used import, whenever we have been using import, you tell Python to load a module. When the Python interpreter encounters an import statement, it imports the module if the module is present in the search path. So if it can locate the module where it is in the same directory and the path has been given, same directory, same folder as the current file, it will end up importing that module. Now, see, there are two things. One is that you have your own file or your own module that you have written which you are importing, or you are importing something from the Python standard library which would always be available in the search path. Dir is a built-in function which returns a list of strings containing the name defined by the module. It gives the list of variables functions defined in that module. So every file in this way is a module, and it has, so what dir does is that it gives you all the variables, everything that is available in that module. So certain hidden things such as underscore underscore doc underscore loader, all of these are also by default available. Let's have a look at this. Let me close all of these. So let's suppose I do import math 1, b is equal to list, c is equal to, and I call the dir. Let's see what the result will be. See, A, B, C and math are present. And if you want to particularly check what all is available inside math, we can do this. And this sort of gives you a lot of functions that are available in the math module. A lot of functions, a lot of variables that might be. And these can be a little confusing. What are these underscore underscore kind of variables? But you just need to know that they are internal to Python, and Python uses them to organize and run code. It is metadata about code that Python uses. So the import statement allows you to import specific attributes from specific module into the current namespace. It works like import, but it allows you to import specific things. Where if you look at this, right, we imported so many of these functions. What if we do not need all of the functions? What if we only need cosine or tan or square root? Why wouldn't we do that? So what you can do is that you can import from math import. Suppose we import square root, or let's import cosine. And now let's do this dir of this particular library. Let's see what the result is. So if you look at this, now it's not that we have imported the entire math module. We have just imported square root. If we want to use any other function which is available in the math module, we won't be able to. If you want to use all the functions in the math module, we need to use import math, which will import the entire module. But here we are being specific. We are saying that, hey, go to the library and get this book. Or we are saying that from this book, get this particular page. Import math is like importing the entire book of math, which is very, let's suppose, big and fat. So you don't want to import everything. But this is more efficient where you want to import specific things. So it is recommended. This is actually a better practice that you import specific things, only the ones that you need. Because what happens is that they get loaded into the computer's memory. And if you have a lot of unnecessary functions lying over there, it can cause a problem in terms of dealing with them. There is also the import star. So you can also do this from math import star, which is pretty much same as import math. However, this is not recommended.
This is not recommended because I mean it's pretty much the same, but you're importing everything. And consider a scenario where let's suppose a variable has been defined in the math module,
which is the same name as the variable you are using. Now I know the chances are less, but then the more number of files, the more number of libraries you're dealing with, the chances of collision where math module, which is another file, has a variable find in the with the same name as you are using. So you really want to be careful about what you're importing as it might cause unexpected errors. Now these are not errors that you will see immediately. These are errors that you will find at runtime because the output will not be correct. So just be careful about how you use the import statement. The most responsible way of using it is through this particular way. So the reload function basically is a very nifty tool. What it does is that it reloads a particular module. So let's suppose you're working on two files and you've made modifications to a certain file and the other file is already running. You want to just reload the module that it runs the fresh code. It will just re-import the particular module that is being asked to reload. Now, these are some of the very important modules available in Python. The sys module, the os module, math module, date time, random module, and the JSON module. Let's learn about some important modules in Python now. The sys module. So the sys module basically what it does is that it avoids the access to some variables used or maintained by the interpreter and to functions that interact strongly with the interpreter. Strongly being that they are closely related to the Python interpreter. Now the way it works is that you import sys and some very common thing that you can do with it is that sys.argv. So it stores any command line argument that are passed when you start Python. So let me show you an example. Now let's suppose I go to the terminal and I execute this file and I pass in arguments. So if you notice sys.argv, it takes in the file name that is being executed 1, 2 and 3 as strings. So any of the parameters that are being passed as strings. So I can also do this, right? So this is whenever you are executing a Python file through the command line and you want to pass some arguments to it. What sys.exit does is that it basically shuts down the terminal. It shuts down the execution. So nothing different. I mean that happens anyway, but sys.exit might be something that you use when you are looking to exit from the execution. Let's suppose you're running Python file through the command line and you want to end the execution after a certain point based on some error conditions that have happened. That's where it will tell the interpreter to quit. So another thing I can sort of show you is if I do this and I say import sys.exit, see it closed the terminal. It closed the Python interpreter. Now some other important things in sys.winver. So this will not work on my machine because I'm on a MacBook. But if you were not on a MacBook, if you're on a Windows system, this will give you the version of Windows. So let's run and see what output I'll get for this. So yeah, it will throw an error for me because I'm not on a system which is Windows. So this will not work, but we can try out the other one. So let's see what sys.flags is all about. It gives us some flags. So what are these flags? And like these flags are set to 0 or 1. So it exposes the status of command line flags that are available. Now these flags are essentially how command line sort of works and it basically gives you those values of the command line. Let's look at sys.prefix. Okay, sys.prefix basically gives you where is it that the virtual environment or the Python path lies. If you have set up virtual environment or if you have the Python installed, it will basically tell you where the Python is installed in your system that is being used to currently run this program. Okay, now the thing is that sys module is more useful again when you're interacting with the operating system or you're interacting with the command line. You will not use it a lot if you're using it for data science purposes or if you're using it for web development purposes. So this is more useful if you're dealing with the operating system that you're working on. Let's go to the OS module. So OS is also related to the operating system and it lets you do certain things such as directory or file manipulation. So it allows you to create a directory, it allows you to make a directory, it allows you to remove a directory. So let's try these things out. Okay, so what we will do is that we will start with the some of the things available to us. First is os.name. So I'm on a POSIX system, which is basically what MacBooks are on. So the name of the operating system is not Mac OS. I mean, if that's the marketing name, but it is POSIX. Then OS.environ, what it does is that there are certain environment variables that are stored on any computer. This is true for even Windows, where certain environment variables, environment being the entire operating system, it has certain variables set, and this gives the entire key map or a dictionary of the environment variables. Then there's something called get login, and then there is a get ppid function which gives in the process ID of the current function. So if you look at this, returns the name of the operating system dependent module imported, returns the mapping object representing the string environment, returns the name of the user logged in or on the controlling terminal of the process. So the user which is logged in on this terminal is underscore MySQL. It has got nothing to do with DB as such, it's just the name of the user on my system. And it returns the parent's process ID. So os.getppid, it returns the ID of the process which is running this particular Python file. Now the other ones that we saw on the previous slide, so we can also get the current working directory. So let's do that. So as you can see that I'm on this particular directory right now, Python Edureka dsmod3 dsmod3. I can also make a directory using this, so I don't need to exactly print it. So I know this is shown as print, but let me make a directory without using print, and I'll just make a directory over here with the name test. So if you notice, a test directory has been created. I can change the directory now to test. I'll just comment it out so that we don't create another directory. We have changed the directory. I can print os.getcwd. CW is current working directory. So Python knows which directory it is on at any given point. So now that you see, the current working directory is this one. Now if I try to, let's suppose, import any of these files over here, it will not work because I'm in a different directory. Finally, I can remove a directory as well, and for that what I'll do is that I'll just give it the name of test, and if you notice, this particular directory disappeared. Right. So the OS path module is very helpful. It allows us to do a couple of things to the current path where we are on. So why is this needed in Python? So one thing that Python uses the OS module or the path module internally is to find the files. So whenever you're doing any sort of module import and you're trying to import functions, inbuilt functions or anything of that sort, Python relies on these methods internally. And it definitely is sort of good to have an idea about how Python is dealing with these things internally, that it's not just magic. It's, just code which is written by other developers, and internally it is finding out and doing all of those things one by one. So let's look at os.path.join. What it does is that it takes one or more paths, joins them by using the current operating system's path separator, whatever it is, whatever the path separator is, and it basically gives you the return of it. So let's try this out. So I'll just change it to users apple and users apple shared. Let's run it once again. Right, so it joined the two paths together. Let's suppose they were completely different. Let's see what the output will be then. Okay, I hope this is clear to everyone. Let's look at what absolute path does. It takes a relative path name and returns the corresponding absolute path. What we can do is that we can just give it ds underscore mod. So where we are is ds underscore mod 3. So let's see what we get by running. So if you notice that it took ds mod 3, which was present within its domain, and it figured out that hey, this is the backward path of it. So this is the absolute path of it. We can also try it on a file name. So let's suppose we try it on this file contr.py and we run it. So it has automatically found where this file, the full path of this file. Let's try it out for something which is not present. Let's try it out for something over here where we use input.py. So what absolute path does is that it takes the current working directory. So it will take the current working directory and add the string that you're passing inside over here. That's all it does. So it will get the current working directory like we did over here, which is going to be this path, and it's going to concatenate it with whatever you're passing to it. Now norm path. It converts path names from a non-standard format to a standard format. So what is the standard format? Let's have a look. let's again reference the osmod.py file. Okay, so this is the normalized path. Now let's take this. Okay, and this is the normalized path for this. Now let's suppose we give it this. Let's see the output then. Okay, this is the output, and this one is for this. os.path.split, what it does is that it takes a path name and returns it in two parts, the directory part and the file name part. Now this is very useful. Let's try this out. Let's take the entire path, give it to os.path.split. So you can see that the first part of this is the tilde directory and the second part is the actual file name. First part is the entire directory and the second is the file name. So os.path.exist very simply tells you if the path exists or not. The particular folder or path exists or not. So we can try it on this and the value will be false because I don't have a folder of this sort. But if I try it out on this particular thing, right, which does exist. So let me try out with this class demos, right? This should exist and the value is true that yeah, it actually exists on this system. The next thing is that it checks whether a certain thing is a directory or not. So if I pass it a file name, it should say that it's not a directory. So it is not a directory because it's a Python file. Now if I say this and I run it, yeah, then this is a directory over here. Now os.walk, what it does is that it walks or traverses the path that you give to it, and it gives you, let's see what it gives in return. So it gives you generator or it gives you an iterator. So let's actually use it in a better way and see what it actually gives us. Right, so it gives us a bunch of things. It gives us a bunch of files actually. It lists the entire set of directories that is present in class demos slash python slash edureka. So probably it's a bit too much. So let's go back a little and try over here and see what we can get out of this one. Just purely just in ds mod 3, what is available in this directory structure should only be the files, because earlier what happened, so why you're getting so much output over here is because there are a bunch of things under python edureka. This folder is huge, so instead let's try this. Now this is a little better. So there is .idea, which is just a system file, ignore it. There is something called a PyCache that's related to Python caching something. But yeah, if we look at this, this is the list of all the files which are present over here. So what os.walk allows you to do is it allows you to go into folders or navigate through the different folders present on your system, folders and files. Let's talk about the math function. It provides access to the mathematical functions. Let's look at a couple of important math functions. Okay, so math.ceiling. Let's run this one. Right, so ceiling is it rounds to the highest number possible, which is 11 in this case. Okay, that's what ceiling does. Copy sign, what it does is that it copies the sign of whatever is on the right hand side to the left hand side variable. It's just a better way of doing it rather than just multiplying it by -1. And of course it takes care of complex cases such as complex numbers or any other kind of system. Copying the sign is non-trivial. So this will return the positive value of the negative number that has been given. If the number is positive, let's see what is the output. The output does not change. And if it's this, an integer, then, so this is f absolute, which is floating absolute. This is not, so this will convert even the 19 into 19.0, as you can see. Then we have math.exp, which basically is e to the power, gives you the result of e raised to the power of whatever you pass to it. Then we have expml, which is e raised to the power x minus 1, where x is 2 in this example. And this is log, so math.log 10 of 10, which turns the logarithm of base 10 to 10. Now in case you're not aware of e or log, it's just like sort of mathematics that you need to revise, but these are nothing complicated at all. You can just give in the input and get the power and logarithmic values that you want. Similarly, we have sine and cosine. You can get a cos of a certain degree of angle degree, then you get a sine, a tan, cos. You can get all the values available here. So as we said that Python has a wide variety of use cases, which includes scientific use cases. This is why this is inbuilt in Python, where, as compared to, let's suppose, C++, where you need to import it and you need to have it, or some other for languages where you might need a special module. All of this comes inbuilt in Python. There is inbuilt support for all of this because Python is used in domains such as science particularly, and a lot of scientists use it. So that is why these things exist out of the box in Python. And similarly, there are Python math, there are angular hyperbolic functions. You can convert math.degrees, math.radians. You can get the value of pi, the constant value of pi. You can get the value of e as well. Okay, let's talk about the random module. Random module. So sometimes you might need a random value in a certain range, or you might need a random number for whatever reason. This is where the random module comes in. So let me show you an example. So import the module and rand range. What rand range does is that it gives you a number within the range of 0 to 100. So let's run this. Okay, it gave you a value of 52. Every time you run it, we'll get a different number. What rand range does is that it gives you a number between 0 to 100, but with steps of 20 over there. So start, stop, and step. It will start from 0 and with steps of, right? So if I need to get better results, I should increase this upper limit. Now all of these are going to be sort of multiples of 20. It's not that it's going to give us multiples of 20, but it is moving in steps of 20 every time. And then there is rand int between 0 to 30. So let's try this out as well. So which one to use depends really on your use case. You can just go ahead with either one of them. So what does random.getState do? It's another method available to us. It returns an object capturing the current internal state of the generator. So what happens is that Python somehow has this concept of a generator which maintains what random values have been generated till now, so that it can actually truly randomize the next value, and it gets the state of the current of the generator in its current form. It's just an object. Next is random.uniform. It returns a floating point number such that n is between a and b, where a and b are the values that you are passing to it. So this number would be between 3 and 6. So again, it's like saying that any decimal value between 3 and 6, just generate that and give it back to us. So what are the real life applications of generating random numbers? So it could be for generating a random passphrase for a banking system on the internet, and it could be for video games that you're developing with Python that randomly the monsters should appear or the spaceships should appear for the person to shoot them down. Or it could be for simulation of any random event or seemingly random event like a rainfall. Okay, this is where it is going to be. And there are similarly several other similar real life applications where you might need a random number. I mean, if you're building a casino website, let's suppose, and there is a random number to be thrown, there is a dice to be thrown. You're building a roulette. A roulette is basically one of those things that you see in the casino where you can just throw a ball and it will land on a particular number. Now, if you're building any sort of a chance sort of game with Python, you would need a random variable. Or even if you're building any sort of probabilistic theorem. So let's suppose you are doing machine learning, you're implementing an algorithm, and often like machine learning relies on random numbers in terms of certain algorithms. This is Gaussian naive Bayes algorithm, and that's where you might need the random module. Next is the datetime module. So the datetime module includes tools for working with dates, times, and combinations. So let's have a look at some of the methods available. So datetime.max here, what does it do? Let's run it and see. So it gives us the maximum year that is available to us, the minimum year that is available to us on the system, and datetime.time basically gives us the time object. The max year is 9999 and the min year is 1. It returns a time object with hour, minute, second, and microsecond. And this one returns a time zone object. But this might not work on all systems, as you have seen just now that it did not work on my particular system. That module has no attribute time zone. So just be careful with where you are using this. It works on certain systems, it does not work on certain other systems. Next is the JSON module. The JSON module provides an easy way to encode and decode data in JSON format. Let's have a look at this. So JSON is basically, it looks like a dictionary in Python, but essentially it stands for JavaScript Object Notation, and it is something that is used a lot on the internet these days to transfer data or to store data. It's very popular these days. And it's not that you need to know JavaScript before using it. It's just a format for data. Like MP3 is a format for storing music. Similarly, JSON is a format for storing data in. So yeah, let me just find the file. Okay, I can just write it here. So first you need to import the module, put JSON. Then let's suppose we create the data, okay, which is a dictionary. And then I can create a JSON string, which is json.dumps is the method available, and I need to pass the data to it. Then I can print the JSON string. Let's run this. So you might say, hey, this looks nothing different than what I printed over here. But trust me, this is actually different. This is different because if I do the way Python looks at it is going to be very different. Sorry. Yeah, so if you look at this, the type is string. This is not a dictionary. It can look like a dictionary, but it's not a dictionary. If I try to do this, yeah, this will not run because string object does not support item assignment. Okay, so it's a string object. Let's talk about regular expressions next. Let's suppose you want to find a particular data in a large text of data. So you want to find, let's suppose, all the email IDs that exist in this entire text of data. You want to find the name of certain colors. You want to find certain words. You want to find how many times does the word flag appear over here and replace it with the word flags. So any of these things, right, where you need to match for certain patterns or words and either replace them or find the number of occurrences can be handled very easily by regular expressions. Or let's suppose you want to verify email addresses. So this is something that we see very commonly, right? That when you're signing up for a website, it tells you automatically whether the email ID that you have provided is looks like an email ID or not. So the thing is that there are so many patterns, so many ways in which email ID exists because there are like websites which end with .in, .co.in, so on and so forth. So how do you make sure that an email ID actually looks like an email ID? How does the computer figure that out? That's where regular expressions help us. So what are regular expressions? A regular expression is a special text string for describing a search pattern. So it will describe a search pattern, the pattern by which we will look for a match in a given string. So you can do that as a human being very well, but how do we tell the computer to do it? The way we tell the computer to do it is by telling it of a certain expression and asking it to match it to a given string. So you find a word in a string, you generate an iterator, match one or several of the letters. So this is done internally by Python generating an iterator, and then it matches one or any of the several letters based on the input that you have given, or it matches a series or range of characters. Then you can probably replace the string, or you can match a single character. So Python has the RE module available for this, and it has several methods available on it. So one of them is sub. So let's have a look at this. Okay, so what happens over here is that re.sub. Now this over here is what is called as a this is what is called as a regular expression. This is what we meant by describing a search pattern. So this is a search pattern, and what it says is that match A or D. So whenever the way it is written is that you write a whenever something is between square brackets, and let's suppose you give it the characters to match within square brackets, anything is an optional one. So it is going to match for A or D within this given string. So it is going to find A or D and it is going to replace them by stars. So let's run it and see if we get the correct output or not. Okay, so if you look at this one, right, all the A's got replaced by star and all the D's also got replaced by a star. Let's do another one. Now we want to match the pattern ABC. So this is not A or B or C. This one says that it has to be ABC in that sequence and replace all the ABCs. So it replaced ABC with a star here and here. Let's compare it to the first one. You see the difference? If we did, let's suppose A and D, and let's see then. Nothing changes because AD is not in a sequence. But if we put in square brackets, then yeah, we get nearly the same output, right? Now this is another one. This says A or B or C and then 1 or 2 or 3. So let's try this out and see what output we get. So A1 gets matched, okay, B2 gets matched, D4 has no match because there is neither D near there is neither 4. Let's suppose we had D, even then it would not be matched because there is no 4. But if you add a 4 over here, yes, then you get a match. So it says that first character should be either an A or B or C or D, and the second character in the string should be either a one or two or three or four. Let's do another one. So the thing is that this is again like one of the simpler ones, but then there are complicated ones as well. So there is this dot. So regular expression has their own notation. Okay, has their own notation of how you describe a pattern. So let's see what we get with A dot B. Okay, what is A dot B doing? It says that basically match any sequence. A which starts with A, capital A, then has any character. So dot stands for any character on the keyboard. And then B. So A to B gets matched. AXB gets matched and gets replaced by a star. AXXB does not get matched. A dollar B gets matched. If I were to add another dot, then what will happen? Then none of the first three match, only this one matches. And this could literally be any character. It could be AB in itself as well. Or it could be dollar and this one. And it would still match. So square brackets, dot, all of these are notations. And now what is AB plus? So it says A and then B n number of times. So let's run this. So it matches A and then B once. So that gets replaced by a star. Then A and all of these B's get replaced by a single star. And then A, C, this is left untouched because it doesn't match. Getting it? So this says, hey, find for a string within substring within this one. Sub being that find any matching patterns which have the first character as A and then the second character as B plus. What does this do? So this says AB but B between 3 to 6 times. So when it is curly braces, then it is saying that B has to be 3 to 6 times. If it is less than 3 times, then it will not replace. So ABB doesn't get replaced. If it is greater than 6 times, it will not replace. So it will replace only till this point, till the first 6 characters. Then the last 3 B characters get left out. It matches this and it matches this naturally. This is a very important one. This is for matching anything which starts with ABC. So the starting portion of the string which starts with an ABC gets matched. Notice that this is not matched. So whenever you have this upper cap, this caps operator over here, it will look for the starting of the string and it will start replacing it from there. It will not look at the end of the string. If you want to match at the end of the string, you need to do it as ABC dollar. And naturally, if you want to match either way, then you just keep it as ABC and then it will replace both at the starting and the end. But only at the end, you need to put in a dollar where it will start looking from the back of the string. Upper cap, it will start looking from the front of the string. Now, similarly, there are many more of this sort. Like there is something as complicated as this one. This is a little big in terms of how what all is present, and the best way to get better at it is basically by finding more and more regular expressions and practicing more and more on it. So then we just did a substitute, but there is also search and match, which tells you whether it can find a certain thing or not. So it just gives you a match object. If this was, let's suppose, ABC and you did this, it would give you none because it could not find ABC within this string. So you just confirm the search object to find a match, but do nothing to it. You just confirm that, okay, this string exists within this string. And then there is the match object. Okay, so what does the match object do? Match looks for a match starting at the beginning of the string. Search looks anywhere, but match looks at the beginning. So this is similar to, in fact, the output would be similar to saying that. So it depends on you how you want to write it, whether you want to write it using re.search or re.match. But re.search is usually used when you expect multiple, for a word to occur multiple times, and re.match is more at the starting of the string. So if you are matching an email ID, you would use re.match. But if you're looking for the word blue in a particular text document, then you would use re.search. So you can use it to match email IDs or mobile numbers. This is like a very, very typical application of regular expressions. Let's talk about packages in Python. So a package is a collection of Python modules. So we learned about modules and which were nothing but Python files. But packages are basically a bunch of modules logically combined together. A Python package allows you to break down large systems and organize their modules in a consistent way that you and other people can use and reuse efficiently. So again, if you look at programming, there is a lot of stress on reusability of things. Whether it is functions or classes or modules or packages, a lot of things are about building blocks and combining them together and making them work together. So we have done this, right? Where from backpack import pen, paper, calculator, we have sort of covered this particular bit where we have learned about the import function and the from one. Let's talk about exception handling. So exception is a signal occurs when an error or unusual condition has occurred. So a very classic example of an exception is when you try to divide by 0. Now mathematically this scenario is that programmatically you haven't written anything incorrect, but mathematically this can't be done.
So what Python does or any other programming language does is that it throws an error saying that zero division is error, it is not allowed, right? Which is an exceptional scenario. It is not something which is incorrect, but it is an exception which has occurred because of something failing at a very fundamental level. Fundamental level being something which is just impossible or unexpected scenario. So unexpected scenario in the sense that an earthquake is an exceptional scenario, right? So think about exceptional scenarios when you think about exception handling. Now you need to kind of take care of these exceptional scenarios. You need to anticipate them as a programmer and make sure that you are handling them within your code base. This is very important for a graceful degradation of your software. This is very important for showing the correct kind of error to the user, and it is an overall a very required good programming practice. So the syntax in Python is try. So try says that, so what happens in the try block is that you write whatever you're trying to do. Let's suppose you're trying to divide. So it will come under the try block as defined over here with an indentation, of course. And then you will handle certain exceptions. So let's suppose when you're trying to divide two numbers, you expect three kind of exceptions. One exception could be that the user might try to divide by 0, or let's suppose the user might try to divide very large numbers, or the denominator might be so small that the number is so large that it cannot fit in your computer's memory. That is possible. Like computers have their limits. Like probably our computers could write up to in hundreds and thousands of trillions, but it will reach a limit where it cannot store a number larger than a given number. Now, all of these things are different exceptions, and it is better that you deal with different exceptions in a different manner. For example, dealing with a very large number would be very different from dealing with tell the user about a zero input. So probably if the number is too large, you could still, try and figure out how to represent it in a different way and still give the user a solution. But division for by zero, you might just tell the user, hey, that you gave a bad input. So don't confuse this with if else at all, because in the sense that I have seen people use this instead of if else at times when things could have been done through an if else statement. But these things, this is to be used more when you are expecting something unexpected. Yeah, so I know it's a head spinner, but you are expecting, you're anticipating. So rather than expecting, I think I should be using the word anticipating. We're anticipating that, hey, this thing might go wrong. I might get a bad input. So let me just make my program malleable enough to kind of handle that scenario. So a try clause can have any number of except clauses to handle them differently, but only one will be executed in case an exception occurs. So it will raise a value error and only one will be executed, the first one that it finds. You can also do something of this sort where you have defined multiple errors which are being handled at the same time. That the type error and zero division error are being handled in the same way. Let's suppose the user inputs a string and you want in both cases the user to be told that, hey, you have given a wrong input, as compared to a value error where something else has gone wrong, right? As we discussed. So let's suppose this is more about the large number error and this is the type error or the zero division error. And then there is except, which is for handling any unexpected or unanticipated exception. This is even one level beyond where where you can't even anticipate, but you still know that this might break because it's a context is that you're doing this for mission critical application. So let's quickly look at an example, right? So we are trying to get a input from a number. Now Python gives us the raise keyword, which we can use to raise an exception. So over here we are artificially raising an exception. This is not how it is usually done, but we are artificially raising an exception just so that it can go into this block. Okay, I think we should look at this example instead. So let's suppose for entry in random list, we are trying to divide, right? As I said, you can get unexpected input. So let's see what happens when we run this. Right. So if you look at this, the first time it executes 1 divided by a, the entry is a, an exception occurs. Oops, this gives you the info, next entry, and it goes to the next entry. It is a 0. Nothing can be done. When it is 2, then you get some result out of it. Okay, then you get some result out of it. But if you notice that what has happened now is that you have otherwise your program would have stopped at the very first step, but it executed till the end because you were handling the exceptions as they were occurring. So some way or the other. So imagine that you're getting random input and you're iterating over it, and this is how you're sort of going to deal with it. So there is also the finally block in the try statement. It can have an optional finally clause. This clause is executed no matter what and is generally used to release external resources. So this is in case, let's suppose you're reading a file and some exception occurs
and you're not able to handle the exception, but still you want that regardless of whatever, after the file has been dealt with, it should be closed because it's a very, very large file. And you just do not want to leave it to chance to leave it in the memory because that will cause a lot of problems. So that is where you will do any sort of cleanup. So finally is mostly used for any sort of cleanup, whether the DB connection needs to be severed or the file needs to be closed. That's why you will use the finally block. So this is an example. We're trying to write to a file. Let's suppose an error happens that you can't write to a file. Ultimately, you need to close the file. Okay, you did not have permission to write to the file, an exception occurred, and finally, you need to handle it gracefully where you need to actually close it. Now, there are also something called as user-defined exceptions. So you can define your own exceptions as well. Till now, we were seeing key error and name error and value error and zero division error. These were inbuilt exceptions. But as a programmer specific to your application, you can define your own nature of exceptions. The reason why you would do this is because it would basically throw errors which are relevant to your application. And this is something which large companies or large teams do usually, where it's a very, very large system. And because what does an error do? So think about it in this way that when you see an error on the screen, it is essentially a piece of information to you which gives you a clue that hey, something has gone wrong and this is how you can probably fix it. Errors, if you look at errors, they are supposed to be informative. The laptop or the Python interpreter doesn't say that hey, something is wrong, figure it out. It tells you, tries to tell you as specifically as possible. You can understand that what kind of an error has occurred. Otherwise, it would be very, very difficult to find problems in your code. So similarly, if you're working in a very complicated system, right, and you know an exception has occurred, and you know as a developer when you're creating that piece of code that why the exception will occur, which is very dependent on your own use case. That is where you will define your own user exceptions. Now, how do you do this? The way to do this is there is something called as an exception class. So you create a class, error class, which derives from the exception class, either directly from it or you can have this sort of multi-level inheritance as well. Really up to you. And then you just use it. So you over here the class is declared over here itself, but if you wanted to import it, you could import it and you could raise it as an error. Now, of course, you can add multiple things within the class in itself, and that will help you do certain things. The stack trace, the way it gets printed, all of that. But what I would say is that that should be left for later when you're actually working on bigger systems. But for now, you can just keep it in mind that, hey, there is something as creating my own exceptions as well that I can do. You can implement methods, override methods that are available in the exception class so that certain thing gets printed every time or some extra information gets printed. All of those things are possible. You can make it as customized as possible for yourself. That's what programming languages tend to be a lot about. So good programming languages allow you to customize them in the way that you want to use them for. Let's suppose we get data of unemployed youth across the globe from 1947 to 2014. And this has various information about regions which had a high unemployment rate. So for example, Afghanistan in the region of in that time duration would have a unemployment rate. But again, it's data from all over the world, and this data size is going to be huge. There are 7 billion people in the world right now. Even if you collect only 10% of the data, it's a huge number. That's 700 million people then. Even at 1%, that's a huge number. Then that is 70 million. So this data size is huge. How do you deal with it? How do you draw insights from it, from such a large data set? Excel will not work out at all. Let's look at use case number 3. We want to look at geographical distribution of posts. So let's suppose there is a protest going on at Wall Street, Occupy Wall Street, or there's something going on in Syria, or something going on in Libya, where either a revolt is happening, a revolution is happening, or let's suppose an event is happening. Let's suppose multiple sporting events are happening across the globe, and you want to kind of figure out the geographical distribution of a post with a particular hashtag. Around the world, a marathon run is happening, and everywhere the athletes or the supporters are using the same hashtag. And you want to see which geography is the post coming from, because that sort of, let's suppose, dictates that where is the moment in terms of if you know where the geography of the post is, that this is the location where it is, and the momentum is changing from location to location to location. Let's suppose it's Olympics which is happening, and within a country it is happening in multiple stadiums at multiple times. So then you know where the action is based on the geography of the post. Now, large amount of data, lots of insights to be drawn. How do you do it without using programming? So, what is data analysis? All of us have heard this term over and over again. There are so many jobs out there which say business analyst, data analyst, and all the titles in between. But what really is data analysis? So, data analysis is the process of inspecting, cleaning, transforming, and modeling data with the goal of discovering useful information, suggesting conclusions, and supporting decision making. Let's break it down piece by piece. So, you have your raw data here. This raw data can be even something as simplistic as the name, age, gender, and salary of a person. Okay, even that is your raw data. But what happens is that when you collect this raw data from the world, a number of times it might have discrepancies in it. Discrepancies such as, let's suppose the last name is missing in certain cases. Let's suppose the age is missing in certain cases. The salary is missing, or something else is going wrong. So there are various things that can be wrong with the data or are not exactly in the format that you want. So let's suppose the salary is given only in floats. Even the decimal values have been included, but you don't care about the decimal values. Or you need to transform age into integers perfectly. Wherever the age is missing, you don't want a null value, you want a zero value because null would throw off your calculations. It would give you errors. So all of this comes into data pre-processing, where you transform data into desired format and you clean the transformed data. So transform data in the desired format could also be the row and column arrange, where maybe you don't want certain columns, maybe you want to label certain columns a certain way. So any of these things where you arrange the data in a clean cut way that before you can even start with any sort of analysis on it. So where you know that predictably, okay, there are no null values, there are no empty values, there are no extreme values of data. Extreme being, let's suppose, salaries are given and you're supposed to figure out the CEO of the company has a very large salary. He will drive the average salary to a particular point. Let's suppose every employee in the company has a salary of $50,000, but the CEO has a salary of $500,000. Now, what will happen ultimately is that you might get an average salary of $125,000 or $150,000, but that is not correct. That is what that does for you is that it gives you a false impression that this is the average salary, because that is not the average salary. The average salary might very well be 50, 55, 60,000. So, those kind of things are required to kind of decide how to manipulate the data to get into proper shape before you can even start anything with it. And then the final step, which is modeling the data. Now, the way you model the data, so modeling is basically drawing insights from it, which could be just simply taking an average, which could be taking a variance, something else, where you say that, oh, the variance is so much, so which gives you a trend. Well, the average age is this much. For an average age of 24, the average salary is 60,000, which can enable decision making. Now, decision making is not done by computers, it is done by you as a human being, where you know the context, where you know whether, this is correct or incorrect, not correct or incorrect, but basically what to draw from it, whether to take any action or not, and what action to take, in what direction. So that comes from analysis of trends. Trends are brought forward by the model that you prepare on the data. Okay. And honestly, these are the things that you do in your daily life. So in the sense that, let's suppose you see a discount on a website, right? You see a discount on Amazon, you see a discount on Flipkart. You would compare it, right? That's the data. So sometimes what we do is that when we are comparing items, on one website it is published as 799, on another website it is published as 800. So what we do is that we say, just let's consider it to be 800 on both. 1 rupee doesn't make a difference. That's transforming and cleaning the data. That's pre-processing the data in your head. And then you prepare a model. You prepare a model that, okay, one website gives 10% off and another website gives 20% off if I buy another item with it. So then the model is prepared where you do the maths and you figure out, okay, what is the total discount you will get on both the things, whether you want the second thing or not. How much money do you have? How much do you want to spend? And you analyze and you then make a decision. Again, so where you did not involve a computer because the data set was very small in size and you just were comparing two items, but just make that into 2000 items or 3000 items. So if it is 3000 items, then the data set becomes difficult to do that analysis mentally. But otherwise, when it comes to data analysis, it is something that we do on a daily basis. Next question is, why Python for data analysis? So Python provides various methods for data analysis, manipulation, and visualization. For data analysis and manipulation, we have NumPy and Pandas, and for data visualization, we have Matplotlib. And we're going to cover all of these in the subsequent classes. in this module and the next module. But as I've already told you that this is Python is very, very useful in this respect. So, and widely accepted, widely used. So now let's do a short introduction to NumPy. So NumPy is a package for scientific and I would say even data science computing. It has certain features like multi-dimensional arrays. So till now we just studied a single dimensional array in Python. A is equal to 1 comma 2 comma 3 within square brackets. But what if we need a multi-dimensional array? Multi-dimensional array, imagine a matrix, a row and a column set up like an Excel sheet. Okay, that's a multi-dimensional array. Then once you have the multi-dimensional array, naturally you want to do certain things to it. You want to read from it, you want to write to it, you want to update it, you want to delete it. You know the typical CRUD operation. You want to calculate the sum of the column, sum of the rows, the average of the rows. That's the method for processing arrays. You might want to do an element by element operation, which is something like a sum. And you might want to do mathematical operations like in linear algebra. So that depends on, so now of course which things you do versus which things you don't do depends on what you're trying to do, but it has multiple features which enable you to do multiple things. So in NumPy, you can basically divide the operations into three categories. One is mathematical and logical, average, sum, median, variance, all of that. Second is more scientific. So if you're familiar with something called as a Fourier transform, if you're not from an engineering background and taking this course, it's okay. It's not that you need to know that to be able to deal with NumPy, but it's just one of those things that is available in engineering, that it's a mathematical function and it's used in signal analysis and so on and so forth. So something of that sort, the linear algebra, a lot of use cases, even for things like social media posts and everything. If you ever end up doing machine learning after this course, you will see that linear algebra, the one that we studied in 7th or 8th grade, has a lot of real world applications. It's just not theory. So installing NumPy, very simple. You just need to go to the terminal, and I hope you already have pip installed, and you just need to do a pip install NumPy. I can't show this to you because I already have it installed, but this is the command, pip install NumPy, as simple as that, nothing more. It's all small, by the way, no caps, and that's it, and you will end up installing NumPy. Now let's look at the NumPy array. Now NumPy has something called as an ND array. It's a multi-dimensional array object consisting of two parts, the actual data, some metadata which describes the stored data. This is two key differences here. First and foremost, from a normal Python array, that it is typically multi-dimensional. The treatment always on a ND arrays, it is set up like a multi-dimensional. But the clincher, the big difference is the metadata which describes the stored data. Now, if I had to go to Python and let's suppose I had to describe a multi-dimensional array. If I had to describe a multi-dimensional array without using NumPy, I could do it like this. So how is it a multi-dimensional array? Because I can do this. So this is me saying row 0, which is the first row, and the second column. 2 is in the second column. So you can imagine it being arranged like this. So if you look at this, this is multi-dimensional, right? So if I can do this in Python, why do I need NumPy? Because apart from a lot of other things or a lot of other functionality that we will see, one key difference here is the metadata. So what is metadata? Metadata is information or data about data. So let me give you an example. When you store a file on your computer, any file, you can right click and you can go to properties or details or something of that sort, which gives you extra information about the file, such as when was it created, when was it last modified, what is the length of the file in terms of minutes. Let's suppose it's a song file. It tells you about the format of the file, it tells you about certain other things. It tells you about the author, if there is a description. If you have ever used iTunes or any other media player, it automatically shows the name of the album and everything. Where does that come from? Where does the name of the album or the artist come from? It comes from the metadata that is stored within that file. So the file in itself is data. It is song data, right? It contains ones and zeros which make up a song for us to listen to. But then this data has information about itself. Even its name is a metadata. So one is the song in itself and then the song in format of a file, but then more information like when was it created, who created it, what user on the system created it, who is the original author, what is the copyright on this, several metadata points about it. So that is one of the key differences here, where the way NumPy arrays are created, they're not like regular arrays. They can look like regular arrays as we see, but keep this in mind that there is a lot of additional methods available on it, additional functionality available on them. Plus, they have metadata about themselves. which can be very, very useful and which is very needed when we are dealing with large amounts of data, because it tells you about the data, and unless and until you know about the data, you can't do anything to it. Next is that each element in an ND array is an object of data type object called D type. So every D type is something that you will see even in pandas and all across NumPy documentation and even in these slides. D type basically tells the type of the data. Now ND array contains a header. So this is an entire ND array, okay, over here. It contains a header which is meta information essentially. So the first piece of meta information that it contains about the data that is stored inside these cells. So think of these individual cells as the array items. It contains the data type. Now when you extract an item out of an ND array, okay, where you select a particular item to read it or to manipulate it or whatever, the data type gets attached and it becomes an array scalar. So this is an ND array, which is an actual complete array, and an array scalar is nothing but just one item from that entire array. Now even this one item, when it is extracted, it is not just the data. The data type comes in and attaches itself to it and internally. So this is not something that you have to do explicitly. This is just for your understanding sake, where there is a header again which contains information about this array scalar. So scalar, why, what is scalar? Basically just the raw data. So this might be 4, but the head might contain that it's a float or it's an integer or it's a complex number. So you might have values as 1, 2, 3, 4, 5, 6, 7. But is it a float? Is it an integer? Is it a scalar? Oh, sorry, is it a complex number? That is determined by the data type. And whenever you detach one of the elements, that data type gets attached to it as well. And why is this important? Because even if it's 1, 2, 3, 4, 5, 6, 7, if you're applying some sort of mathematics to it which involves complex numbers, or you are using it for division, you need to treat it like a float, because a division by a float can give you a different result than a division by an integer in Python. So if you divide by a float, I recommend that you go back and try doing that. If you divide by a float, you will get a float in the result. But if you divide by an integer, you might get a zero result. Definitely not get the float value unless until you convert it. So that is why all of these things are very, very important to know the data type, especially when dealing with large amount of data. So let's create a first NumPy array. So the first thing is that you import NumPy, and this over here is an alias. This over here is an alias. Import NumPy as NP, and then you have a method available. So the reason is that NumPy in itself is a large name. So typically it is when you see code online as well, you will see a lot of people use NP as a short form. Okay, and I would suggest that you become familiar with it, because this is something that you're going to see in a lot of places. Now you can do np.array and you pass it a normal Python array. That's it. This is the simplest way to do this. np.array 1, 2, 3 and print of a. So let's run this. Now the output doesn't look much different, but it looks like just like an array. But if you notice, there is one thing. Let me show it to you. Let's suppose, maybe some of you have already noticed it, maybe some of you haven't. So I'm going to pass it the original array, and I'm going to pass it I'm going to print both. Okay, wait. Right. Notice the difference? This is not with commas. This one is with commas. The original array, like we have known it all this while. Not that it makes too much of a difference for you when it comes to accessing it, like once we will go down that road, but just notice that there are subtle differences, and a is the type is going to be, like, if we do this, see, and this a has metadata about it. Okay, so this is the simplest way in which you can create a NumPy array. Let's look at creating a multi-dimensional NumPy array. This is quite simple. We do nothing but 1, 2, 3, 4. Okay, now one thing is that this needs to come within square brackets as well. Don't make this mistake of missing the square brackets. In the beginning, people tend to miss it. Individual items, number of these items within this array will decide the number of rows. So let's print it. Again, see, the commas are missing and this is written in a certain way. Even the output is coming in a certain way. Whereas if we had a multi-dimensional array with list inside it, it would come with commas and it would come in a flat structure. Let's see what happens if we add another value to this, if we add another column. Then it is not able to represent it like earlier, but this converts it into an array. If the columns are not same, it will just treat it like a single dimensional array. This is a single dimension, and if they are same, then it will make a multi-dimensional array out of it. It will not assume that, right? It doesn't know what the value of 5 is going to be, so it's just going to treat it like a single dimensional case. It will not create a multi-dimensional. And this is something that I've already shown you, right? I passed it a list. It just created an ND array out of it. Another way to create an array over here is I can use the range function. Sorry, the A range function. I say 0 to 1000 and I run this. See again, no commas. And this is flat. This is not indexed like this. This is not a multi-dimensional array. This is a single dimensional array. And it would exclude the last value. 1000 is not included. Starts from 0. First one is included. The second one is not included. Another important method over here is creating an array of zeros. Now, some of you may wonder what is the usefulness of creating an array of zeros. Well, the use case is a lot in scientific computing and in machine learning again. Sometimes you need things like this. So what it takes is it takes a tuple of the size that you want and it gives you that. So it's 5 cross 5, and if you look at it, it's a multi-dimensional array. I can do, let's try with 5 comma 3. So 3 columns and 5 rows. 3 columns, 5 rows. Let's try it with something random as 5 comma 15. 15 columns, 5 rows. And we can do 15 here as well. So all of this. Another method available is linspace. So linspace creates a linearly spaced vector. Okay, now this is relevant if you are familiar with the concept of a linearly spaced vector, which is sort of a fancy way of saying that, okay, these numbers which are separated by in a linear space, in a sense that in this particular dimension, there are equal steps between them. And what it takes is 3 parameters: the start, stop, till what point it needs to go, and then step. So it's kind of like, think of the x-axis that you draw on a graph. X-axis that you draw on a graph. So this is one of those things which will help you, like once we cover matplotlib, this linearly spaced vectors can come of help over there. So I'm gonna cover np.linspace 0, 20, 5, and let me run this. Okay, I get this output. I can do it like this as well. Then it will be a shorter one. Yeah. So this is the number of steps. Okay, so don't confuse it with the differences. So it will not be 2, 4, 6, 8. This is going to be the number of steps that you want to reach 20 in. So if it is 2 steps, then it is going to reach it in 2 steps. If it is going to be 10, that is why you will get these random numbers. So it's going to create 10 values, which are ultimately going to reach to 20. So in steps of 10, so reach 20 in steps of 10. In steps of 10 being in 10 steps. So divide 20, so take the second number and subtract it from the first number. So that in this case is 20. So it says reach 20 in 10 steps. It's not in exactly 10 steps. That is what this is saying to it. Or if we do it as 8, so it says reach 20 in exactly 8 steps, or reach 20 in exactly 6 steps, where 0 is always going to be the first step and 20 is always going to be the last step. So you need to figure out the rest of the 4 steps. Okay, so we did this even earlier, right, where we took an array, a list, and converted it for our use case. So this is pretty much the same, where you can use the as array method as well to convert an existing sequence into an ND array. Let's talk about restructuring a NumPy array. So restructuring, what do we mean by that? It converts a linear array of 8 elements into any sort of reshape or resizing that you want to do to it. So let's try this out. So let's take this and let's create an array of size 2 comma. So let's create an array of 8 zeros. Okay, simple. And then let's resize this into 2 comma 2 comma 2. We're going to print a first here, and then we're going to print a here. So first it was like this, and then we reshaped into this size. Let's see if we can convert it into 4 comma 4 or not, or 4 comma 2. Now why can't I do 4 comma 4? Cannot reshape the size into 4 comma 4. So 4 comma 4, it's basically going to multiply. So 4 cross 4 is 16. So if you have 8 elements, you cannot make 16 elements out of it naturally, right? So you need to do it in a way where you can make finally 8 elements out of it. So it can be transformed into 2 comma 4. That is 2 rows and 4 columns, or you can transform into 4 comma 2, okay, or 1 comma 8, which is the same one, right, or 8 comma 1, where 8 rows and 1 column. Now the use case is, again, whenever you're doing any sort of, so let me just give you a little bit of background about where you might end up using this. So when you're dealing with machine learning, right, machine learning is ultimately, it's nothing but the mixture of math, statistics, and
programming. Like that's like the overlap. So there are these three so think of a Venn diagram where maths or statistical maths, linear algebra, and probability and programming, all of them meet together. That is where machine learning happens. Now, when you're talking about linear algebra deals a lot with matrices or multi-dimensional arrays. So a matrix is nothing but what you see in an Excel sheet, rows and columns. And that is what we're doing here with the NumPy array, where we had a normal array, but we wanted something more. And in that domain, there are a lot of mathematical computations that need to happen. Transforms need to happen. Arrays need to be reshaped to perform certain mathematical things on it, functions or operations on it. And that is where all of these are used by Python developers in turn, like for either making those libraries that are doing machine learning or for writing their own machine learning code, where these transformations are really, really helpful. So just good to know for now. If you're wondering where am I going to use it, eventually when we get into the application part, there you will see that we're going to reuse these things again and again and again. And it's very, very important that you know about these. There is another one called Ravel, where so Ravel, what it does it that it levels up the array, it flattens it out. So if I've gotten a reshape, right, let's reshape this into 2 comma 2 comma 2, and then let's print the Ravel out of it. What will it do? It will basically just give you the same one. So we can do a reshape and then a Ravel. So it will take this, flatten this 2D array and flatten it out. That's all that Ravel does. So you can take a flat one and reshape it, or you can take a shaped one and flatten it out. So it's just a two-way transformation. It is a converse of what we did earlier. Let's talk about the indexing of NumPy arrays. NumPy array indexing is very, very identical to Python index. So if you want to collect an element, so let me remove all of this, and arr is equal to np.arange 2,20. Okay. Now I want to get, so earlier as we saw, right, where we were selecting a particular element out of it. Let's run this. Okay, now what we have done is simply we have accessed the sixth element out of this. Let's look at the type and see what it is. Because over here it looks like an integer. Is it like an integer? No, it's not. It's a NumPy int64 type. So this is one of the gotchas where, you know, initially you might get stuck where you are looking at it like an element, but like a simple number 8, but it is not simply a number 8. So let's try another thing on it. Okay, so this is what we got, and we picked out the sixth element. Let's see if we can print element plus 7. So we can, okay, but still understand that this is enabled by Python, that it is allowing you to add an integer to a NumPy array int. This data type and this data type is not same. So element has a different data type, 7 has a different data type. This is an object of the belonging to the NumPy libraries, whereas 7 is the normal 7 integer value that we have. Yes, you typically cannot add, so this is like adding a cat to a dog, which in the real world doesn't give you cat dog. But what is happening is that Python is handling it internally. But at the same time, we need to be conscious about what we are doing. Let's try to see if this is a type conversion or not. What is the type of element plus 7? Is it giving us a NumPy object or is it giving us an integer object? See, so what Python is internally doing is that it is taking this 7, first converting it into this NumPy int64 and then adding it. Because if this was simply 8, okay, if this was not the NumPy one, you would get type as int. You see, 8, this 8 plus 7, it's giving us in NumPy int 64, and this type is different of 8 plus 7. Okay, what is slicing? So we covered it a little bit in when we were covering Python, the first few classes. Python's concept of less slicing is extended to NumPy. The slice object, now over here we have a more sophisticated way of doing slicing, where we can create something called as a slice object that is constructed by providing start, stop and step parameters to the slice class. So this is a slice class, this is a constructor. We covered this in the last class, I hope you guys remember. And we're creating a slice object and we're just passing it to the array, the NumPy array. Let's try this out. So we have an array of np.arange. Let's make it of 20, and then we are going to cover it as np.arange. Okay, wait, sorry. Here a slice of 1 comma 10 comma 2, start, stop and that. Then we're going to print arr. Let's print arr first as well. So it started from the first one, went up till 10 in steps of 2. 1, 3, 5, 7, 9. 1, 5 and 9.
Now there are various ways of slicing. So you could have also done it in this way, by the way, where we could have used the similar notation. So where we wanted to start from 2 and let's suppose go till 9, we could have done this as well. This is something that we covered in array. So even that works. But this is a more sophisticated way of doing it using the slice object, and you can not use the slice object and do it directly like this as well. You can always use this one where it starts from 2, it starts from 10, from the 10th element and goes up till the end. Or you can take it to the last element that you wanted to go till. So I wanted to go till 12 starting from the top, so it goes till 12 minus 1. So 12, it says 12 first 12 elements. Now here is again, now this is something very cool, very nice that we can do with this, where we can extract specific rows and columns using slicing. So we can slice the first two rows and the first two columns like this. Let's try it out. 0, 2 and 0, 2. We do not have a multi-dimensional array. So let's create a multi-dimensional array. Okay, let's try to cover this, which basically brings in everything. But first is for rows, the rows that we want. So we can want 0 to 3 rows. Okay, let's try 0 to 4 and see if it gives us an error. No, it won't. So it doesn't give us an error, it just ignores if the rows doesn't exist. So first is rows and then the columns that we want with it. Let's see if we give it a huge column name. Yeah, it will still work, but not really. It will be confusing for other developers in terms of why you have used a higher index. So don't do that. Just like keep in mind the number of rows and columns that you actually have. You could also tell it that, hey, just select the rows in this range. So we could also do it like select every row after the first one. Or we could tell it, hey, ignore the first column, or could tell it that, hey, include everything till the second column but not after that, which gives us the same result, but we can go with it like this. Okay, so this one says everything after the first row, which is the first row will contain 1, so it ignores 1. This everything from the first row onwards. This could have been 0 as well, right, which is the traditional one, which would include 1, 4, 7. So we do it as 1, so then it becomes 4 and 7. And this one says, hey, all columns up till the first column, so which is not going to include anything which is like 2, 5 and 8. So this column gets dropped. After this column 2, 3, column 5, 6 column and 8, 9 column, that gets dropped. Let's look at few NumPy array attributes. These are very helpful. We can get the shape of the array by printing arr.shape, which is 3, 3, makes sense. Next we can get the dimensions of the array, which returns the number of array dimensions. Because it's a 2D array, so it will return 2, right? Next is item size, the number of items in the array. So this is the length of each element of array in bytes. So it will take each element and based on the data type, it will give you the number of bytes for that particular element. So 1 is usually stored in 8 bits, and so integers are stored in 8 bits, and that's where it will give you the size. Not very useful, but sort of something good to know. Okay, right, there is something called as numpy.empty. It creates an uninitialized array of specified shape and d type. So uninitialized, where it doesn't have a value, it just has been created, and it uses the following constructor where it takes the shape. So you need to give it an array which defines the shape of it and the data type, and it will just basically give you something with zeros, but essentially it's uninitialized, it's just empty. Let's try this out. So we give it a shape of, let's suppose, 3, 5, and we give it a d type of int. Let's run this. Okay, so what it is doing right now, it is picking up random values and it is just populating those in the rows and the columns. But if you look at the size is being maintained. Let's try with float and see what we get. So again, random values. The empty basically is useful that way. Now it can also give zeros, but then that just depends on whatever values it picks up. Next is reading and writing from files using NumPy. Now NumPy provides the option of importing files directly into the ND array using load.txt function. The save.txt function can be used to write data from an array into a text file. So let's try this out. So let's save text and test.txt, and let's pass it an array. Sorry, I got the spelling wrong. Okay, let's try this out. Let's see if a file got created. So yeah, test.txt got created and this was written to it. So of course it writes it in a certain format. So let's try to create an array using some other ways. Let's create an array using this particular condition. So let's see what the output is then. Right, so of course, if you need to write in a different way, you would need to specify that, and those are higher options. But for now, this is sufficient. And similarly, you can load it up using np.load.txt, and you can give it the name of the test file, right? So you can load it up from the, now notice that what is there on the file and what is being loaded is slightly different. It's just that when it is storing it in a certain way. When it is accessing it in a certain different way. And those are just minor differences. Ultimately, the objective here is not to have the file in a human readable format as such. It's more about storing the data on the hard drive and using it in the NumPy array and not any other way. Now, another thing that we could do is that we could save it to CSV file, right? Using something called as a delimiter. Now, delimiter, what it does is that it separates out the rows, the subsequent values that are present in the column using a comma. So, delimiter is something that you specify. I'll just show it to you quickly. First, let me save the file in a certain way. So, first, let's save the file, and we are going to use the same save text feature. Okay, we are not going to try out, we can use the same method and we can specify a delimiter. So the first delimiter that we'll specify is going to be a comma. That we're going to separate our data using commas. Let's try this out. Let's see what is there in CSV. So now you see that these are comma separated. We could have also separated it using any other character. Let's suppose you want to separate it using the semicolon. Let's check the CSV file now. Now these have been replaced by the semicolon. We can also use anything. We can use something like a dollar. We can use any sort of delimiter that we want. It is purely up to us that we want a delimiter of this sort. Of course, it is best to use comma because that way, like, it becomes clear. A reason when you would not use comma is when your data in itself contains commas. So if you have any string, if you have any sentences data, let's suppose a Facebook post or a Twitter post which has commas inside it, then probably using commas is not a good option because the library or like your Python programming, it will get confused between what is the comma coming from your delimiter or that is separating the data and what is the comma that is coming from the data itself. So likely it will read, it will break it up into comma, that it will also consider the commas that are coming from the data in itself when you're storing it in a .csv file. So please be careful about what delimiters you're using. But typically if it's a numbers kind of data, if it's just numbers, you can use a comma and it will work fine for you. Other thing we can do is we can use the gen from txt function. And over here we need to specify the delimiter. So which does pretty much the same thing as it did earlier when we were using the load text file. This load txt when we were doing, gen from text does something similar. And it allows you to, again, deal with data in different formats. So maybe you need to pass the file to somebody else, and that is why you would use these file operations. Or you're receiving the file from somebody else, you're receiving the file from, receiving it from the sales manager. The sales manager asks you to go through it or something else, or you need to create a report on it. And that is where you would end up dealing with files, because a lot of times data in companies is maintained in Excel sheets and files, and you would export it to a CSV or something else of that sort, which is compatible with NumPy, and use it. Now let's go on to Pandas. So Pandas is an open source library providing efficient, easy to use data structures and data analysis. Now Pandas is basically built on top of NumPy. Okay, Pandas is built on top of NumPy, and the name Pandas is derived from, not from the animal, but from panel data, which is sort of a very technical term, an econometrics term for multidimensional data. Now, Pandas is well suited for tabular data with heterogeneously typed columns, which basically means that any sort of rows and column based data which contains different types of columns, which contain different types of data types, heterogeneous. It is not homogeneous, where one could be name, age, sex, gender, city, different strings, booleans, all of that heterogeneous data. It is very, very well suited for that. It is also suited for ordered and unordered time series data. Time series being that anything which is time stamped. So let's suppose there is a sequence of events, like we were looking at the geographical use case, right? Where it's a sequence of events which is marked by a timestamp. So any sort of ordered and unordered time series data, that is also what pandas is very helpful for. Now the third thing is any sort of arbitrary matrix data with rows and column labels. So which is pretty much similar to the first one. Matrix data, rows and column labels, and I mean it's like an Excel sheet. It's talking about it's kind of describing an Excel sheet in technical terms. And any other form of observational statistical data sets. The data doesn't need to be labeled at first. Pandas is very powerful. It gives you labeling tools as well where you can label your data. So when I say label your data, I mean give a column name to certain columns which are not present originally, but it will accept them and allow you to add your own column names as and when you want. Now let's look at installing pandas. So same command, you need to pip install pandas. I'll just have a look at the virtual environment I'm in. So I am at, okay, so this doesn't have pandas and I'll have to install it. Okay, so now pandas is installed. We should be expecting that it will be available to us. So after the pandas installation, let's look at the data structures which are present in pandas. So kind of like how nd array or numpy array was available to us, similarly pandas has some data structures of itself that are available from itself as well. The first one is series. So this is labeled homogeneous array of immutable size. So immutable size being that you cannot change the size of this array after you have created it for the first time. It is a labeled homogeneous array where the data is not heterogeneous. Now, of course, we looked at pandas. The initial thing was that it could handle heterogeneous data. For that, you need data frames. Now, data frame is a two-dimensional data type available. It can have heterogeneous types and it is size mutable where you can change the size. So as compared to series, for this one you can change the size of the tabular data structure. So it is like saying that you can add rows and columns even after you have created an Excel sheet. Series is more strict that way. You cannot modify the number of values inside it after you have created it. Third one is panels. It is a labeled size mutable array, but the dimensions are 3 in number. So it's a 3-dimensional array where even an individual element can be a series or a data frame in itself. So that is where the 3 dimensions come in from. Okay, which the panels is the most complicated one out of this because it's 3-dimensional, so it can be a little difficult to deal with it. But yeah, it's one of the important ones for sure. Now, one thing to notice that all the above data structures are value mutable. So what does that mean? Value mutable means that you can change the individual values, but in case of series, you cannot change the size. So you can have 4 elements in that homogeneous array and you can change all the 4 elements, the value of the 4 elements, but you cannot change the size of the array in itself. So please notice the slight minor differences when it comes to mutation. Mutation being change. So what kind of changes are allowed on these data structures? You need to be sort of familiar with when you're using them, or otherwise there's a chance that you might get stuck when you're programming. Let's look at series. So a series is a single dimensional array that contains homogeneous data, that is data of a single type. All the elements of a series are value mutable and size mutable. So the elements are size mutable, of a value mutable and size immutable. So you cannot change something which is like a float to an integer because the size of the element in itself is fixed. Size of the element and size of the entire series array is fixed. You cannot change it. So data can be of multiple types such as nd array. So you can create a series which contains nd arrays or which contains lists, constants or series or dictionaries, etc. The indexes need to be unique, hashable and have the same length as data. It defaults to a certain value. We'll look at this in a short while. Data type of each column, if none is mentioned, it will be inferred automatically. So the data type needs to be present for each column. It will determine it by itself if you do not give it explicitly. And when it comes to copying the data, it deep copies the data. So what is deep copy? Deep copy is that it will copy as much as it can about that thing that it is trying to copy. And it is set to default, false is default, but you can do deep copy as well. So deep copy means that any of the references, so even the memory reference, it's not a copy, it's not a Xerox copy, it is like the actual document in itself. So it is kind of creating a duplicate which is very valid as the original one as well. It is not simply a Xerox. So it's like getting a duplicate driver's license which is as good as the other one, the original one so called. It is not a Xerox. It is not a simple Xerox. Okay. So this is very important to know when you're, trying to copy it and pass it around and you make changes to your series data type. series variable in one place, but it does not reflect in the other place. So you need to know where you're deep copying and where you're shallow copying. The opposite of deep copying is shallow copying. Let's create a series. What we need to do is that we need to import pandas, okay, and we need to create a series.
Let's run this. If you see that it has given a series, it is an empty one as there is nothing present over here, and the d type is float 64. Now let's suppose we want to create a series with some data inside it. One of the typical ways to do it is by creating it using an indi array. So let's also import pi over here, and let's create an array, and let's pass it to series. And now let's see what is the output. Okay, sorry, it needs to be one dimensional. Right. Okay, this is can be a little confusing. So let me instead give it in the reverse order, and let me give a little bit of random values so that it doesn't seem like exact same thing. Right. So 9 has an index of 0, 8 has an index of 1, 2 has an index of 8. The second 8 has an index of 2. This indexing the left, this column 0, 1, 2, 3, 4, 5, that has been done automatically by pandas. This is not present in your original array. Now you can define the indexing by your side as well. I mean, you need to pass in an additional parameter, but if you do not, it will automatically index it. Indexing being that it will automatically set up an index next to it through which you can access it, as I will show you later down the slide. But just notice that this column over here, this one, has been auto generated. Okay, this is something that Panda series will always do for you. Now you can also create it using a dict. So let's suppose you want to create a data dict, and you want to set A as 1, B as 2, C as 3, and we pass the data dict and then we run it. See, now the indexes that it has picked up has been given by you in a way. When you give it a dict, it will automatically create the indexing using the keys, and the second column will be the values. So when you give it an array, the indexing is done. You can sort of think it like this, that when the array is given, the numpy array, the elements are indexed anyway. So this is 0, 1, 2, and that is what the index is. In this case, when it comes to dictionary, the index is A, B, and C. So index being, so think of an index of a book, right? You need an index to go to a certain page. So the page here is 1, 2, and 3 in this one, and the index is A, B, and C. If you want to go to 1, you have to refer to the index where it is, and the index here is A, and that is what the series used to create an index for A, B, and C. Next is accessing data from a series. So slicing works as usual. So in the sense that, let's suppose it had more values, let me just do that. So it will access 2 to 4 minus 1. Of course, the last one is not included any slicing in Python. So 4 minus 1 is 3 over here, which is with the value of t. So that is how it will work. You can always do this as well till the end, or you can do it like this. What happens if we give it a value that doesn't exist? This is C, but if we give it 7, so yeah, it will just stop at F and not proceed further. So yes, definitely there is a similarity between this and arrays, but then again, as we will proceed with using pandas in the future classes and the future modules in this one, you will figure out that, hey, this is the normal functionality is present plus extra things are present on all of these libraries, on all of these new data types that we are learning about. Next is data frames. So data frame is a 2D data structure in which data is aligned in a tabular fashion consisting of rows and columns. Now the constructor for the data frame object, pandas.dataframe, the first value is data, the second is the index that you want to define, third is the data type, and the fourth is a copy, the value of the copy. Now, which can be true or false. Again, the deep copy concept. Now, data can be of multiple types such as ND arrays, lists, constants, as we have seen in the series one. Index can be rows and column labels of the data frame. It defers to np.arrange_n. So similarly, like earlier we had a default value, it will in this case as well have a default value depending on the data that you have passed to it. And d type is the data type of each column. So this can be essentially a list here, or any sort of iterable or an enumerate, which contains the data type of each and every column, since this data frame contains heterogeneous data. Okay, it doesn't contain homogeneous data. So data type here will be heterogeneous, and that is what this will contain. Let's create a data frame. So we'll create a list
10, 20, 30, 40, and we will create a data pandas dot data frame, and to this we'll pass the list text. Okay, and then we will print the table. So you see the index was created automatically. Now the column was given a name by itself. Notice that the column was given a name by itself. You did not provide. So 0, if you're wondering what this 0 is, this is the name of this column. This is the name of this column where the values are. Now why did it pick 0? Because so we had not given anything to it by default. Okay. And when we don't give it anything by default, it will automatically assume something, and it has its own rules based on which it will give a name to the column, also called as a label. Okay, so label and column name are two things that I will be using interchangeably. As we go down the next few slides, you will see how we can change the label. Okay, so if you're using a dictionary, if we change the data to this, it's a list of dictionaries where we have A as 1, B as 2, we have A as 23, we have B as 41, and then we have A again as 45 and B again as 47. Now if you look at this, A and B, now where did this come from? It came from these keys. So the way, again, don't be confused about when would the label be what. So whenever it is considering a dictionary, even when earlier we saw the dictionary keys, right? What it does is that the right side in the dictionary is always going to be the value. So that is going to be the value in your cells. So if you consider this as to be sort of an Excel sheet, these are the values 1, 2, 23, 41, 45, 47. These are the row numbers on the left 0, 1, 2, and these are the column names. Now if the column name is not explicitly provided, it will automatically try to figure out, hey, what can be the column name. Now A is a column name for these three cases, and B is the column name for the other ones. Okay, so please notice that this is how it will basically infer if you have not provided it explicitly. Now what happens if, let's suppose, one of the dictionaries has a column that has not been defined for the other one? So we get something called as nan. So nan is sort of a null equivalent. So equivalent would be equal, but it is similar to how we have, it's sort of not applicable or not present as a value for these other rows. It goes for 0th, which is the first element, right? And it says, okay, A, B have a value, but C doesn't have a value. So it will put nan. Then it will go to the first one. Okay, A and B have a value, but C doesn't have a value. So it will put nan. Similarly for the third one, A and B has a value, C has a value. So it will put it as 48. So please notice how it works, where nan is a sort of a null, is not a number, is stored in areas where no data is provided. Okay. Now let's suppose you wanted to give it your own index. Now till now what it was doing is that it was giving a 0, 1, 2 based on the position in the array. So it was looking at the array. This is the 0th, this is the first row, this is the second row. Let's suppose we don't want it like that. We want to label it in a different way. So we will give it an index, okay, and the index will definitely be a list of items. So we want to instead be very explicit and say this is row 1, this is row 2, and we want to give it a row 3 as well. So we have row 1, row 2 and row 3. Why would you do this? Because it makes your code very readable. I mean, it just makes your data set very readable. That is why you might want to do it. Okay, let's suppose for a second these were test results for 3 people. Okay, one's name is Jim, another one is Dwight, third one is Pam. These are the test results for somebody, right? So now you're seeing how readable this is as compared to how it would have been otherwise. So you can store it like this, you can store it in a dictionary key value pair as well, but then this is just way more readable. This is, if you look at the console, right, when you're going through this, when you're looking at this, it is arranged like an Excel sheet. That is where it comes in a lot, because when it comes to data analysis, a lot of times it's just looking at the data. Now we have Python and it does store the data really well in dictionaries and lists, but then viewing it is a pain unless and until you arrange it in a very particular fashion. But this does that for you, where it loads the data in a certain format and it makes your life way more easier. Okay, there is another way to create the data frame using pandas.series. So you can convert a dictionary or series into a data frame, and there's a trick to it. This is another. So let's suppose I'm creating a series of 40, 45 and 60. Okay, and the index is maths, chemistry, physics, and I create a series 2 pandas dot series, and this is 70, 72 and 74. So imagine a student's marks data. Again, math, chemistry, physics. Okay,
Now what we can do here is that we can, to the data frame object, we can say Jim has series 1 and Dwight has series 2, and we can print the table. Right. So now we have a data frame for marks of Dwight and Jim. So Dwight and Jim are making the columns here, and the indexes are being created by maths, chemistry, and physics, and the values are being populated from over there, where series 2 belongs to Dwight for maths, chemistry, and physics, and series 1 belongs to Jim. So let's look at data frame addition and deletion of columns in the data frame. So a new column can be added to a data frame when the data is passed as a series. So this is something that we have already seen, right? Where the new column can be added in the sense that, let's suppose I add C++ over here, and this has a value of 90. So naturally for Jim, the value will be nan, where it is not a number. It is not given. It doesn't exist, like we saw earlier. Now, let's suppose you saw this, but you want to add a new column now, third student. Okay, so how can you do that? Now, adding it, creating a series every time is cumbersome, right? So let's add it directly. So let's suppose we have to add the data for Pam, and this contains marks like 90, 91, 92, 3, and the index is maths, chemistry, physics, C++, and let's add even one more column for her for English. Okay, and let's run this and let's see the result. Okay, so what happened? Now English was not present for the earlier ones when the data set was created. So it will be ignored here. Okay, the other ones are considered because they were present at that particular time. Had we had this like when we were creating it earlier, right, then we would have had a fifth column of English. But if you are adding it like this, let's see again what we get. Then you're not getting the English column. So column like this will be added only when like you're adding it for all three. So we will come to that as well in terms of how to add a column. But this is at least we have learned how to add a row. Okay. So a column is added, but the row over here of English has not been added because of this one. Now you can also delete a particular column from a table. So let's suppose I want to add Pam, but I want to delete Jim. That's it. So that's how you delete it using the del keyword. Now delete keyword doesn't return anything. Okay, but if you do something to get the data as well as remove it, you have to use something called as pop. And instead of printing table, let me print Jim series, which prints the series that basically of for Jim, right? This is 40, 45, 60 coming for Jim. Delete and of course even in the table now Jim doesn't have a record because that has been popped. So again Dwight and Pam. So slight difference between delete and pop. Delete doesn't return the original element that is being deleted, but pop will return the element as well. So pop is like popping. You pop something out, you take it out. Delete is that you just delete it. So if you have a, let's suppose if you have a box of candies and you pop one out, you're taking it and you're removing it from the set. But if you are just deleting it, which is you're just destroying it, which means that you're not taking it away or you're not consuming it. Let's look at addition and deletion of rows. So where we saw recently, right, that we could not add the English row when we added the column later. So let's see how we can add a new row altogether. Now, first and foremost, you can select the data rows by passing the .lock function. Let's use that. Print table. Let's look at the maths for everybody. Sorry, I did not use the lock function. So you need to use the lock function and you get the results for Dwight, Jim and Pam. Now notice that how it has automatically given it to you in a readable form. It has not just returned 70, 90, 40 and 90 to you. It has given you it with the labels as well. Okay, it will give you the result with the labels intact so that you can make sense out of it with the all the column names. Now in case you want to use a mathematical row reference where you want to use that I want row number 2 instead of the label of the row, then you need to use ilog, which is integer location, which will vary like this. So we can try it out for multiple. Okay, so name is chemistry, even look, so it gives you this as well. So again, these are not just simple things. You can actually access the name, like there are ways to access it, right? You can check what row name is being accessed ilog. Now let's talk about appending to a row. So to append to a row, what we need to do is, let's suppose we have, and we want to append to it. So we need to define a new data frame. Okay. Now the new data frame needs to have the values. So let's suppose we need to have the value of 30, 60 and 95. And the columns are Jim, Dwight, let's run this. So we have run into an error which says shape of pass values 1 comma 3, indices imply 3 comma 3. So now you need to sort of visualize the data that you have. Visualize the data in the sense that there are 3 columns, okay, and you want to add a new row for the columns. So how would you do this? So let's look at what is happening over here in the example that is given on the slide. Now 11 and 13 are being added to 2 and 3. Okay, now the columns are 2 and 3 and they are being mapped to this one. So that's all we had to do. We had to kind of pass it as an array and give it the values within the array instead of giving it without the array. So in the sense that otherwise, if you look at this, right, it's an array of arrays over here. It's an array of arrays where for the first row, you can add multiple rows in this kind because the data frame will always contain multiple rows, right? Always contain multiple rows. So you wanted to add one single row. When I was doing it like this, right, it was implying that I want to add 3 rows, but or create a data frame of 3 rows, but I want to create a data frame of only one row. I wanted to create a data frame of only one row which would contain the marks of the English column, right? And for doing that, I will use this where I will append this data frame to the row to this, right? And then I can change the table 0th index. I can later do a label change. Now drop function is used to drop rows where labels are provided. So you need to provide the label. So let's suppose I want to drop the table now, drop the row now. So I'll say drop 0 and then I want to print table. Okay, maybe I need to use the numeric one. Okay, now let's suppose instead I want to drop the C++ column, sorry row. C++ is drop. Similarly, I can drop chemistry or I can drop math. Let's look at importing and exporting data using pandas. Now, similar to how we were using it with NumPy, you can have a data set, okay, and you can read the CSV by just giving it the path to the file. So let's try this out. Let's just create a new CSV file for us. I'll just comment all of this out. Okay, so it will read this 10, 20, 40, 50. It is present over here just like we loaded it using NumPy. But now it's a pandas data frame. The data type is of a pandas data frame. And any table that you have at your end, it can be written to a CSV file as well. So in the sense, let's do this and so if you notice that data set has been exported to the file. The table that we had over here has been exported. So again, makes it easy to, kind of have a prepared data set. So it happens often that, let's suppose you have a large data set and you might process it on one server or one machine and, you might give it to somebody else. So it is very handy that way where you can just import it and export it in a very compatible way to different people and you can just give your data to different people. Let them handle the same. Now, similarly, you can read Excel sheets as well. You just need to provide it the path and you can write to Excel sheets as well in case needed. It is just like super simple, just like how CSV works. In case you ever face issues with this, of course, my first recommendation would be convert it into CSV. All Excel sheets can be converted into a CSV. So you can do that as well. So here is a use case or a problem statement. Now let's suppose Bob wants to track the demographics of his country by age for every year.
So what he wants to see is that how does the country's population, the demographic, vary according to age for every year. So how many young people are there in every year? 50% of the people are below 30, 40% are above 30. So he wants to create that sort of a distinction. Now, he collects all of this data about the country's population from the census, from the internet, from numerous websites, and now he's trying to look at it. But if he was to look at it just on an Excel sheet or even a pandas data frame, how easy would it be for him to digest that information in a single go? More than that, if he had to share that with somebody, would it be easy for that person to look at the same thing and infer the same thing? In the sense that he could have it arranged and everything, but it's not immediate. The solution that we have for ourselves is a matplotlib library provided by Python, which helps us in plotting the data. Now, there's a saying that picture speaks 1,000 words. Even when you have very complicated data, once you plot it on a graph, it becomes relatively easier for you to understand what might be happening as compared to looking at the raw data in it. So, a short introduction to data visualization in Matplotlib. Matplotlib is a Python library that is specifically designed for the development of graphs, charts, etc. in order to provide data visualization. Matplotlib is inspired from the MATLAB software or the MATLAB programming language and reproduces many of its features. This doesn't mean that you need to know about MATLAB or anything, we'll still be writing Python. But yeah, it is good to know that it is based on something very strong. One of those languages that are used by academicians and scholars in universities a lot, provides a lot of mathematical operations straight out of the box. And that's where a lot of Python gets. So a lot of things that you can do in Python with respect to data science or machine learning can also be done in Matplotlib. It's just that Python tends to be more favored because the ease of writing as compared to something like Matplotlib. So installing Matplotlib, it's pretty similar and like the previous commands that we have been using for installation. This is how the screen should look like. The command is pip install matplotlib all small, no difference from the way it is written over here. Pip install matplotlib, pip space install space matplotlib. Let's look at plotting in Matplotlib. So the first plot that we're trying to plot is going to be this one. Let's head over to the IDE. So first you will import matplotlib.pyplot as plt. This is very important that you import it as an alias because otherwise this entire name can be quite big. This is again a usage that you will see as multiple places. This is similar to when we imported numpy as in np and when we imported pandas as p. Very simple plot. We're going to plot 1, 2, 3, 4 on a plot and we're going to show the plot. So this first command, this just sort of passes the value. It is not that the plot has not been created, but just that you haven't asked to show it or save it. Unless and until you tell it Python explicitly that, hey, I want to look at the plot, it won't do anything. And this is also important because sometimes you might want to generate plots and save them, while sometimes you may be actively looking at the plot right there and there. So let's take this for a spin. So you will notice that something else will appear. It will not appear over here. Whatever machine you're on, it will appear in the tab. Like in Windows, it will appear at the bottom, right next to the start menu. So this is something that Matplotlib has generated for us. It has several features like zoom and everything. So that's really nice. But here is our plot. It starts at 1 and goes up till 4. So we were plotting the y-axis over here. If you look at this, we plotted the y-axis. So 1, 2, 3, 4. If I add a value of 10, let's see which axis goes to 10. So you see that this value has gone to 10. This is not that value at all. Now, we haven't given the x-axis, but Matplotlib has sort of figured it out by itself. It has taken certain default values. We don't need to worry about it because normally we wouldn't be plotting it like this. So normally we would be providing our own x-axis, but otherwise it's like the 0th item is at a 1, the first item is at 2, so it's index based. The way the x-axis has been marked has been the index of these items. So 10th is at 5.0 because it's the 5th item. So list of vertical coordinates of the plotted. You're importing matplotlib as plt and displays the plot. And the x-axis values are implicit from 0 to n minus 1, where n is the length of the list. So this is 5 minus 1, 4, 0 to 4. Now we can also specify the x values by ourselves. The way we can do this is, let's suppose we collect this into an array. So if I am a little more verbose with it, for the sake of demonstration, I'm going to create some mock data for the x-axis. So the second array that I will get with, and this is list comprehension. So this, I'll print it for you here as well first, so that just in case you forgot what this does. So this will plot the y values, and this is going to square all the y values. So 1 square, comma 2 square, comma 3 square, comma 4 square, comma 10 square, and it will collect all of them as x-axis. Now let's see what we get. So x-axis is 2, comma 4, comma 6, comma 8, comma 10. And now you have the y-axis over here. So first set of values was the x-axis and then the y-axis. Now you can also use NumPy to generate the list of items, and you can use that as well over here. What we'll do is that we'll use NumPy dot arange and put plot dot plot. We want to plot x and we want to square the other value. Let's see what we get. Let's compare it to what we wanted to print. So x is going to be 1, 2, 3, 4, 5, and this is going to be squared up from 0 to 25, which is the maximum square. Let's print a range. Let's print this just so that we can confirm the result. So a range will take you from 0 to 5 in steps of 0.1. So it is continuous values. It is plotting all of these values that are being provided over here. Let's go to the next one. Now, often we would require multi-line plot. That is multiple lines on the same plot. This is again very commonly used and couldn't be an easier way to do this. There couldn't be an easier way to do this. All you need to do is you need to call the plot again and again. Think of calling this method plot over here as a way of putting a line on the graph. That's it. So every time you're calling plot, it is putting a line on the given graph. So what we'll do is that we'll do x is equal to range of 5, just a simple Python range of 5, and for this one we will do raised to the power 10, so that we can see the difference. So the reason I've done raised to the power 10 is that so that we can spot the difference between the two statements, the two plottings. So naturally this line over here, this is for 10, this is for 10 and this is for raised to the power 2. The x-axis that they have is the same one. The x-axis is a shared one, 0 to 5, 0 to 4, that is range minus 1. Now in case you wanted to plot multiple lines using the same plot function, if you think this is a little cumbersome, you can just simply copy paste the same thing over here in a single one and it will run. We got a similar graph. Okay, let's try another thing. Let's try it with 3 lines, and this time we're going to do I raised to the power 100 so that you can really see the difference. It seems like we have gone out of range here. So you can plot multiple figures using a single plot function as well. Let's try with this. One thing that you might have seen that earlier when I was showing you the plots, even though we had used 3 of them, the lines were not clear enough. So the reason for that was also because they had sort of merged together. The values had increased so much now, but we have like sort of comparative values, still we can see the difference. Let's see if we can remove the x, still make it work or not, or do we need to give the row every single time? So it seems like that doesn't work. So it's giving a different sort of a plot. We need to give it the same x-axis that needs to be followed everywhere. That's when you'll get the 3 lines. So in case you want to show a grid in the background, which is just a visual thing, so you can just set this parameter to plt.grid and run it. So we have a grid in the background. So another thing that we can do is that we can limit the axis. Rather than limiting the axis, let's suppose there's a very large graph and we just want to see a certain portion of it. So we can do a demonstration. So the first is for the x-axis. Let's suppose I want to see only 5, 10. I want to only see the portion of the graph which is between 5 and 10. And for the y-axis, I want to see something between which is 15 to 20. So this is a coordinate space. X can be between 5 to 10 and y can be between 15 to 20. Let's run it. So we got nothing because probably the graph is not even in this space. Like there is no point that any of the graph has in this space. So let's change this and see if we get something. Still nothing. Let's change it to 0, 4, 0, 3 and 0, 3. We should definitely get something over here. We get the 3 lines. Let's suppose we start watching it from this point. So think that we are going to cut a slice of this graph along this axis and this axis where we just want to see the lines emanating. We don't want to see the single line. So we can set x as 1 to 3 and same goes for the other one. So if you just set it to 1, 2, 3, 1, 2, 3, as if it's just launching. We can do another one. We can do 1, 2, 1. Okay, so anything beyond 1.75 and we are lost. So let's do 1.25 and 2, 1.25, 3, and over here let's do 2.0. You see how we slice that portion? So this is the limiting the access part is really for seeing a particular section of the graph. That's how you need to think about using it. Now you can also use alternatively xlim and ylim in case you think that remembering this is a problem. So we can do the same thing by using something like xlim, which would be one point same thing, right? 1.25 comma 3, and this one it will be 2 to 3, and we'll pretty much get the same results, same kind of graph. Now, of course, it's up to you which one do you want to go for. I would personally prefer this one because at least it's explicit. You know what you're trying to look for in terms of what you're setting. Let's talk about adding labels to a plot. So very simply, we can just, okay, so let's remove this first. And that's it. X-axis and Y-axis as exactly as I wrote it in Python. In case you want to add a title, learning matplotlib. Let's talk about adding a legend to our particular graph. So for this, it is preferred that you split up the plot statement in case you have multiple plots. So don't forget to give the call to the legend function as well. So you need to set the label over here like this, and then you need to call the legend function as well. So let's run this. See, now it's looking much more professional, much neater as typically we see things to be, right? Let's look at saving plots. Very simple, nothing much to do. You can just give the name of the file. It will create the file by itself. So this is created now and this is saved on file. Save fig save image function. Next, let's talk about plot type. Matplotlib provides a lot of types of plot formats for visualizing information. This includes scatterplot, histograms, bar graphs, and pie charts, and many more apart from these as well. But these are the primary ones that are typically used or asked from developers. And let's have a look at these one by one. Histogram. So histogram displays the information of a variable over a range of frequencies or values. It shows the distribution of a variable over a range of frequencies or values. Please notice what it is for and sort of try to understand that it's not a bar graph. It displays the distribution of a variable. Now, what we're going to do here is that we're going to use this function called random.randn from NumPy. And we haven't covered it earlier, so let me just show you the documentation of this function. So numpy.random.randn. So what it does is that it generates an array of shape d0, d1. So whatever shapes you give here, that is the shape of that will generate, filled with random floats sampled from a univariate normal Gaussian distribution of mean 0 and variance 1. So please know that the input variables over here are not the range or anything of that sort that we are looking for. This is the dimensionality of the matrix. So let me show you by example. Two rows and three columns. Rows and columns with values that are according to a Gaussian distribution, which is a mathematical expression. So it's according to some mathematical equation. That's what you need to understand. In case you're not familiar with Gaussian distribution or you haven't studied it, like, or you don't remember it right now. But it's just over here that we are defining the rows and the columns. We are not doing anything else. Now we want to print 400 rows and 10 columns. This is dot 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 where basically Python has obfuscated that, but we can do it with 40 and 10 as well, I think. Or let's try with 2. Yeah, this is much cleaner. 40 rows and 2 columns. So let's plot a histogram with one of these values. We're going to take y is equal to this, and then we're going to hist for histogram, short for histogram. We're going to give it the data value. Then we're going to say plot.show. Let's run this. So we get a histogram. Now don't confuse it with the bar graph because it looks like that, but it isn't around that idea. In case my sample set was larger, which I will just make it, it will look a lot more like the graph that we just saw on the slide. So it's showing the distribution. This is a little heavy, so it's stuttering. Now the histogram groups values into non-overlapping categories called bins. This is just sort of a categorization that the histogram can do for you. And to get it done, we need to pass a second parameter called the bin parameter. It sets the bin value. So let's take it for a run. So the reason why I changed the parameters is just because it sort of becomes heavy with 100 in the sense that with that the array size, the plot size is pretty huge, and so it would take a lot of time to kind of, that is why that rocket figure was jumping up and down. Just keep in mind, it's not that it's stuck, it's just that it is taking a lot more time, and the time would be lesser if you are on a more powerful laptop or a computer which has, let's suppose, 8 or 16 GB of RAM. So then it would be instantaneous, but it's just that the computer is doing all the calculations to plot this. It's not exactly trivial in terms of time. So the output takes a little bit of a time and there's a little wait time. Next is the bar chart. To plot the bar chart, we need to provide it two arrays. The first array is the midpoint of the lower face of every bar, which basically means this. So this is 1, 2, and 3, where the midpoint of the bar graph should be. This is the height of the successive bar graphs. So let's try this out. We're going to set the bar graph as with arbitrary values, and we're going to give them values of 45, 85, 89. Let's take this for a run. So the gap came because I gave it a very random odd value, right? This is not how we are usually conditioned in school to kind of make these sort of bar graphs. It's just that over here I wanted to prove a point that you can pass any sort of random values and it will take the midpoint over here. So if you look at the midpoint of this and you look at the values that are coming over here on the right, so around 1.5 is when you will see that exactly in the middle. Yeah, this is the exact middle where my cursor is right now. And then 2.6 for this particular bar graph, and then 4.8 for this bar graph. So you can also plot a dictionary using a bar chart. I have the code ready for this. Now what we're doing here is that we are iterating over a dictionary using the enumerate object. Let's first have a look at what enumerate does. Basically it gives an iterator object, so it will just give you the I and the keys. This is saying that the 0th, this is the first, and this is the second value. So what enumerate kind of does is that it would split it into tuples of this sort. So it's returning that, and we are taking the for the 0th value, but on the 0th point with the key value of this, we are going to plot the bar graph. So the 0 here coming from this I that's being set, then the 1 coming from this I, and then the 2. Now you can also do it like this, I plus 1, doesn't matter. It basically the involvement of dictionary over here is just doing an enumeration over here. That's the only demonstration that even if you have a dictionary, you can sort of manipulate Python. So all of this is not that it's a matplotlib concept really. This is more of programming that you can cover it like this as well in case you have a dictionary and you want to plot it on a bar graph. Yet another way to do it is to show xtext. So xtext, what they do is that they will take the dictionary, they will take the range that you have set over here, which is 0, 1, and 2, and they will replace them with the labels that you want. plt.text. If you look at this 0, 1, 2, so I could have gone for the dictionary keys as well, but I want to show you a different demonstration. A tick, B tick, not tick. Let's just do it as B bar. Now if I want to do a similar thing using just the dictionary, I can do it in this way. It's because what is d dot keys? It's ACB. So earlier I had done it by passing it manually, passing the array manually, writing it by hand. But you can of course use the values provided by d dot keys as well. So this is for placing the labels on the x-axis. Let's look at the pie chart. Pie chart is relatively very simple to make. All we need to do is now we need to give the size initially over here. The size of the pie chart, we need to give the dimensions. So size of the plot in inches, which is, let's set it as 3,3. Then what we can do is that we can set the pie plot values. So it will calculate the percentages by itself. Please notice that you don't have to pass it the percentages. It will do a sum and calculate the percentages by itself. And we pass the labels. Should have been labels. Let's run this. We got a nice little plot here. So you can similarly increase as many number of labels as you want and just keep dividing. So let's suppose I take a very disproportionately large value and I say for this machine learning. So we get these values on a pie plot. Next, let's look at a scatter plot. So scatter plot displays values of two data sets as they're visualized as a collection of points. Now we need to do here is that take this up, comment this. So this x is the number of points. And then let's print x and y and see what exactly this is going to be. So these are 2 points. This is 1 point and this is another point. These are two values of x and these are two values of y. When you do a scatter, you're saying that, oh, I want to plot 2 points. So there are 2 points which have been plotted. Now the values that are generated over here, these are again Gaussian distribution values. So think of them as randomly generated values which are following certain rules. So they are random, but they haven't picked randomly based on certain rules. And 2 here is really the number of points that you want, because this will be an array of sorts, like an ND array of sorts of 1,000 columns, and this one will be again 1 cross 1,000, and we're just going to do a scatter plot of these. Let's do the big one. So these are 1,000 points on this plot over here. We can do lesser always, we can do 20 and we can do 20 again. So these are 20 in number. Let's see if we reduce the number. Do we get an error? If the numbers don't match, what happens? So x and y must be the same size. You will get a value error. Because what happened was that there were 10x coordinates for which it could not find a match in the y coordinate. in the y section. So it wouldn't work. Finally, let's look at styling our plot. So let's suppose we had a line plot, a range 1 comma 3, and then we were doing a plot of y. Now what the second parameter is doing is that it is specifying a color. Now you may ask which color is y. Now this is based on a color code provided by matplotlib in itself. So C, and then we find say plot dot show. So these are the color codes. B is for blue, C is for cyan, G is for green, K is for black, M is for magenta, R is for red, W is for yellow. So please keep this in mind. This is not just as simply translated always, because black is for K, surprisingly. So you need to refer to the color list. Name NP is not defined. We got colored lines according to the coloring that we wanted to give it. Now sometimes you may want to style your line in a particular fashion. So for that we also have this option. Now you can either do it in a single plot as we are seeing over here, or you could, I think, potentially do it even in here as well. So let's try this out on one of the lines first and see the output. We made it a dashed line. Let's see if we can give it a color at the same time or not. So let's give it MNC is taken. So let's give it a red color. So this can't happen, right? So let's just give it. So you can't give it the color and styling at the same time. That you will have to use something else. But for now, in case you want to make a dotted and a dashed line, and then you want to make a line which is made out of colon statements. So this is how you do it. So this is a colon line, this is a dot and a dash, this is just a dash. Solid line, dash and dotted line. Now you can also have customized markers and you can specify the line styling as we have just seen. So let's try this out for one of them. So let's see what O does, and let's completely remove the other two for the time being. Okay, let's try it out on this because the other one had very low number of points. Let's see what happens with D. So D is for diamond, O is for a circle. So this is talking about the points that are being plotted. What is the line styling for the points? So that will happen, the particular point. So the other one was the entire line was being styled in a certain way. But this is referring to the control markers. So which is the specific data that you have given. This is not for any of the, let's suppose I was doing this. These are specific y square values. Let's try it with the hat, run it, and you have it with this. So again, it's just styling. So introduction to data manipulation. Using NumPy, Pandas and Matplotlib, we will analyze, visualize and manipulate large datasets in order to extract valuable information and insights from it. Let's look at the basic functionality of series NDEM. Now NDEM is the attribute available on the data frame object, okay, from Pandas, and it returns a number of dimensions of the data structure. So let's try this out. So here I have a data frame which is Pandas series dataset. Naturally the dimension is 1 because if we print df over here, right, it is a singular one. This is the index column and this is the actual data column. Now of course we can do it in this way as well, where we pass it a dictionary. And then if you look at the dimension has changed, right, because now there are 2 columns. So this is basically the number of columns. So NDEM basically tells you the number of columns that are present in your data frame. What access does is that it returns a list of the access of the row labels. Let's have a look at this. What do we get here? Okay, we got 0, step, 50 and 1. The index is an A and B, right? And the D type is object. Let's suppose we change this to 1 to 101, or let's suppose a random number as 103, and let's leave it at 51. Let's see what we get. Right. So if you look at the range index, it is 0. It starts from 0, then it goes till stops as 102 and is in step 1. So just to kind of reiterate over this, it is referring to this particular column 0. It starts from 0, goes up till the maximum value is, don't look at this 102, this is the maximum value, this is the stop. So it is a total cumulative value. So these are 102 items, right? The range index and a step of 1. So in case you want to create a range, you will say 0 to 102 where the last number is not included. So 102 will not be included, but from 0, if we go in steps of 1, we will reach 101. So we have to stop at the number which is lesser than 102, which is this one, correct? So this is basically again sort of giving you an idea about your data, part of data analysis, to kind of know your data in depth really well even before you start doing anything with it. Next are values. As the name implies, pretty simple actually. So let me remove the df print and run this. And what do we get? So we get sort of an array of two values, the two columns, 1 and 51, 2 and 52, 3. So each individual row is a collection of arrays, not exactly arrays. You'll notice that these are more like the series. If we had just one and not two, let's see what we get. Then we get each individual one. Let's look at the head command. Very, very important. You would be using this quite a bit in real world scenarios. The head, what it does is that it gives you, so the first five rows by default, just that much, because typically your data will have lakhs and lakhs of, like, millions and millions of rows, hundreds thousands of rows, and you maybe don't want to print all of it because it takes too much time. It doesn't make sense printing all of it. You just want to look at the first 5 rows, or if you want to look at the first 50 rows, or let's suppose you want to look at the first 10 rows, so you can pass it a value like 10 over here. So without value, it will take a default value of 5. If you pass it something, it will take a default value of 10. Now, similarly, you have something called as tail. So head and tail. Now, tail will give you a value from the back. The last 5 values, okay? So you can of course specify that I want to see the last 20 values. Please notice that these are more for viewing the data yourself. Yes, you can of course put it in another variable and everything. So not used essentially for slicing or dicing. So I don't prefer doing that. Where so slicing and dicing being that if you want to take out the last 6 rows, I might write it in a different way, the way that we have discussed earlier of slicing a data frame. But these are more for quickly accessing parts of the data which are at the start or at the bottom and going on from there. Okay. Now let's look at some very, very useful functionality. Now we have something called as a sum available on our data frame. For that, let's set up the data frame properly. Let's suppose we have a data frame with odd values, and we will change this to np.arange, and we want to go from 1 to 100 in steps of 2 so that we have odd values, because it will start with 1 and then 1, 3, 5, 7, and then we have even values. And similarly we have np.arange in steps of 0 to 100 to 2. Let's just first print the data frame that we will get. We have got even values till 98 till less than 100, and we've got odd values less than 99. Let's see what do we have. Something very simple that we have is we can just call dot sum on it, and let's see what it does. Brilliant, right? So otherwise you would have had to write an if else condition to do this, put in a check yourself, which can get tricky as you have complicated data. But then df sums up the data for individual attributes and gives it back to you for even and for odd. It automatically just looks at it and it just creates that for you, right? Now the std function is for standard deviation. So if you want to observe the standard deviation in your data, you just call std on it, dataframe.std, and you will get the standard deviation. Of course, it's going to be similar for these because these are similar kind of numbers, similar ranges, and it depends on the ranges of the sample set rather than the value of the number in itself. Because standard deviation is basically counts the deviation from the mean of the numbers. Because these numbers are very homogeneously spread from each other, you would expect the standard deviation to be similar. Okay, next we are going to cover iterating through a data frame. So let's suppose you want to go row by row or column by column, and that is what we're going to cover over here. So let's first create a data frame as given on the slide. Let me remove this. So we're going to create a data frame which is going to have random values from 5 comma 4, and then columns are going to be, so we have 4 columns over here. We're going to add col 1, col 2, col 3, col 4. Now, kind of like how we learned about iterating over dictionaries, we can do the same over here, and we can just print the key and the value. Let's see what dot iter items does. So you might remember iter items. This is even used in case of dictionaries, okay? This is available. This is the same method which is available for dictionaries as well. Even the data frame object has this method available on it. So let's see what it returns for data frame and if it was as per our expectations or not. Just try to think about what it did for dictionary. So for dictionary, it returned the keys and values over here, the key and the value part of the dictionary. Let's see what it does for the data frame. Okay. So for data frame, what it does is that it picks it up column by column. That is the key, and then it gives you the value. So in fact, let me separate this out because it might not be exactly clear which is which. So this is the key and this is the value, right? Let's run this. The key is column 1 and this is the value that is being printed for you. Let's just look at the type of value so that we have a deeper understanding of what it is returning. So it's a panda series data type. It is a panda series data type that it is returning once you're iterating over it. So as the slide says, the key value pair iterated over consists of the column label as the key and the series object of column values as the value. Let's look at iter rows. So over here we have another one called iter rows. This one is not available on dictionaries because it doesn't fit over there. This is a data frame specific method that is available to you. And what it does is that it iterates over the row label as the key and the series object of the row values as the value. Till now what we were doing is that we were getting all the values for column 1 when we were doing iter items. For iter rows, we are going to iterate row by row like you would do in a database. Like if you were to look at an Excel sheet, right, you would go at, okay, what is there on the first row? What is there on the second row? For column 1, the value is this, column 2, the value is this, column 3, the value is this, and so on and so forth. That is the same progression. Let's see if we can use value.endem over here. Right. So let me mute this out. Let me even remove this. So if you look at the value dimension, it is 1 for the series because it returns a series data set, but labeled with the column name, right? So iter tuples returns an iterator yielding a named tuple for each row. So in case you want a named tuple for each row, so this is again something you would use when the use case presents itself, but maybe you want it in a different format. So this is basically just a different format than getting it in the pandas data series dataset, but it is still iterating over the rows. So but what it does is that it doesn't return two values, it returns an individual row. But if we look at the type of the row, let's do both. Okay, so it's first and foremost it's a pandas class that is being returned. It looks like a tuple, but it is a pandas data class. Okay, and the second thing over here is that you get it in a named sort of way, so you know which is which. So you know which is which. So for index 4 you have all these values, index 3 you have all these values, index 2 you have all these values. It is a named tuple that is given to us. Now let's look at some more operations in the pandas dataset. Now this is very important. Please make sure you're paying attention. This is the group by operation. So there is a lot of ways that you can group values by. Let's try this out. I think I have the data set up somewhere over here. Okay, let me quickly set it up. So we have a data frame, we have a dictionary first actually, we don't even have a data frame. We have a dictionary which contains some data related to the World Cup. So it contains the name of the team. So we have West Indies again, India, we have Australia, then there is Pakistan, then we have Sri Lanka again, then we have Australia again, then we have Australia again, then we have India, and then we have Australia again. Okay, and then we have the rank column which has values 7 comma 7 comma 2 comma 1 comma 6 comma 4, and then finally we have the year. Maybe some of you have been able to figure it out. Some of you are already familiar with this data set. It's a real data set, but some of you are maybe trying to figure out what it is. It's actually the winners of the Cricket World Cup in different years. That is what this data set is about. Who won in which year? And we will simply create a data frame out of this. Let's see what we get. Okay, missed a comma, and let's run this. Okay, so from 1975 till 2015, we have a list of teams. We have the rank that they initially had and the fact that they won. Okay, so this was the initial sort of rank before they started, and the year and the team which won the World Cup in that particular year. So this team won the World Cup, and West Indies won in 1975, Sri Lanka won in 1996, and these are the ranks. Now, of course, this data would usually be like if you were to kind of deal with it, you may think about, hey, let's save this in a database. And that's fair enough. Or you might be getting it from an external source. It might be streamed to you in the sense that it's at the end of an API, like a JSON API, or you're reading it from a file. But let's assume that you have this data in your code now. Now, of course, there are things for those of you who are familiar with SQL. There are things such as grouping and everything in SQL, but then it tends to be limited in what it can do. Plus, with the flexibility of Python and the ability to easily, right conditions and everything. Data frame having a group by function, which allows you to columns, is immensely powerful. It is makes life much easier. You just get your data set into Python. You don't have to worry about the syntax of SQL. You can write all sorts of conditions. You can view your data in n different ways, which SQL might or might not allow for, and or which it might allow for, but which would make it very cumbersome. And naturally, you don't want to be messing around with the database in terms of variables and everything and writing if else conditions. So you can write if else conditions even in SQL, but then strongly not recommended. So let's look at what this would do. So if we go ahead and do a df.group by, and we pass it the value of team, and then we ask for the group. Okay, so it has grouped the different teams for us, and the value that is available over here, so it's a dictionary by the way. The value that is available over here are the indexes where you would find. So West Indies is at 0 and 1. India is at the occurrence of 2 and 9. Australia is at the occurrence of 3, 6, 7, 8, and 10. Sri Lanka is at the occurrence of 5, which is correct. If you look at this, Sri Lanka is at 0, 1, 2, 3, 4, 5, and that's how it appears even in the data frame. So nothing but just the groups that are present. Now, of course, you can iterate by groups. You can pick up each group value, look at the number of occurrences that it has had, and take decisions accordingly and proceed from there on. Now, let's suppose you wanted to group by multiple columns. This is that you wanted to group the team by team and the rank, where you're creating pairs of the team name and the rank that the team had. So when India was ranked 2, there are 2 occurrences. When Australia is ranked 1, there are 5 occurrences. But let's look at something which is occurring again, right? So Australia ICC rank 1, Pakistan on rank 6 as a 4th occurrence, West Indies in rank 7 is on 0 and 1, and Sri Lanka on rank 4 is on 5. So let's actually create some data so that we can sort of see a duplicate. I'm just going to manipulate the rank here. I'm going to change the rank of Australia to 2. So this last one, Australia, I'm going to change the rank to 2 to see if we can get a new group for Australia in 2. So immediately, if you look at this, so Australia rank 2, and then we have Australia rank 1 group as well. So this is one group with Australia being rank 1. This is another group with Australia being rank 2. So unique combinations of a given country and or a given team and its a rank that is provided here. Now to iterate over groups, what you will do is that you will simply use something called as grouped. So for name and group in df.group by, let's suppose we want to iterate by team. Let's see what we will get. Row by row. Okay, we have got the name of the group, then we have the group in itself. Let me in fact draw up a separator so that we can see it clearly. Okay, group is Australia. So if the group name is Australia and this is the data set related to that group name. Group name is India and this is the data set related to that. So you can iterate over each of these now. Let's look at what is the type of the group so that we know what data, what object we would be dealing with. So we would be dealing with a pandas data frame. So in fact, I have to do something like group dot sum. Let's suppose just for the sake of it, I can do that. Doesn't give me insight, or I can do group rank. So then only the rank column is printed, or I can group. So I'm basically on row 19, I'm dealing with the pandas data frame. I'm not dealing with anything else. So years get displayed. Now, let's suppose you want to get a single group. I mean, you don't want to iterate over it, but you just want to get a single group now. So let's suppose we create a new one called df group, and we go by df.group by team, and then we want to get values for India. So the method is get underscore group, and we say, hey, we want the India group. Naturally, if we have the wrong key, it will throw an error. It will say that, hey, the group doesn't exist. We can try out with Australia as well, right? Okay. Next is aggregations. So an aggregated function is a single aggregated value for each group. So you might want to do a sum of certain things, or you might want to do some sort of aggregation, an average or a standard deviation. All of these are aggregating functions which give you a single reduced value of a particular column or a set of values. So let's suppose we need to obtain the group of all numbers labeled odd in the data frame. Now this is one way of aggregating it. where we've aggregated all the groups in a single value for each group. And this gives us a group of all odd numbers. Next is concatenation. Okay, let's suppose we have a list of World Cup winners and then we have a list of World Cup chokers. So chokers are basically teams here that were supposed to win, that were doing really well in the tournament, but they kind of fluttered at the last moment and they couldn't complete it. They couldn't like really win, but they were the favorites to start with, but they fluttered at the last where they could have really made a difference and they could have really won. So points would be 895, 764, and then 656. Let's add the points here as well. We did not have them earlier. 874, 753, 855. So let's create two data frames. And we can simply concatenate. We can call pd.concat df1 comma df2. Let's look at concatenation now. So concatenation is a process of combining two or more data structures. One thing that you need to keep in mind while concatenating two data frames is that the number of columns in each of the data frame should be similar. So let's try this out. Let's suppose we have a data frame with three columns, key, A and B. Key has values K0 to K3. A has value A0 to A3 and B has values B0 to B3. Similarly, we have a data frame with D column, column C and column D. What we are going to do is we are going to try and merge the two together. Let's see what happens. So if you see, we have concatenated this data frame to this data frame. Now why are the values nan for A0 to A3? Because the key C doesn't exist, the key D doesn't exist. Similarly, for values where C and D columns are present, A and B don't exist, so they are appearing as nan. I hope this is clear to all of you. We can also use something called as an append function, which would append the data instead of concatenating the data. However, to call this function, please note that you have to call it on the data frame object, not through pandas.concat. So this is for pandas.concat, right? When you concatenate. If you want to append a data frame to another one, so you're going to say left.append right. Let's see the result. So this basically determines, let's suppose we try to append right to left. Let's see if there is any difference in output. Yes, there is a slight difference in output. So when you're appending left to right, so it takes the left data frame first and appends the right one to it. This portion is right being appended to left, and this one right having left appended to it. This is right and this is left. Let's see what the access column would do. So we type in print, then we given the access column, access value. Okay, this doesn't tell us much. Let's give it a different value and see what the output is. So there is no access name 2. So let's try to look at the access for this. Right? So if you concatenate on the axis for 0, you get this sort of an output. Okay, the left array is coming first and the right arrays and then the other one. If you have axis as 1, however, so axis basically stands for the dimensionality. So axis of 0, so this is basically a 2D array, right? When it comes to the dimensions, this is a 2D matrix, left and right. When you're giving axis as 0, what is happening is that it is concatenating along this vertical. When you're concatenating across, this is the default value as well, by the way. When you're giving an axis of 1, it is concatenating across the columns. So try to imagine an array or a matrix or a two-dimensional space. Axis 0 is saying that, hey, go along the x-axis, and axis 1 is saying go along the y-axis. Right, so in a way that in this one, the first one axis 0, it is just a adding of rows one by one after the other. But when axis is 1, then it is combining the value. So a0, b0, k0. So it is combining along this particular key. Okay, let's talk about merging and joining. So merging is a pandas operation that merges two particular data frames. So yes, we just did merging as well, but there can be a different way that you can merge two data. So merging along a particular column. Let's suppose we had to merge on World Championship year and World Cups played year. Or better than that, let's merge on the team, which is common. So when you call merge, you basically remove the duplicate column and instead give the final result. So let me show how we can do that. Let's suppose I'm trying to merge left to right. And I'm going to suggest that, hey, you merge on the value of key. Let's see what I get. Okay, my bad. This doesn't need to be an array. This will be sequential values. Interesting. So we got a result like we did here, in fact, with x is equal to 1. Nearly same, because when it was concatenating, it was keeping both the key columns, but when it merged and gave you a single column that it has merged on, because this is a simple concatenation operation. It will just put them together. This is joining on a certain column where you're saying that, hey, for every value of key 0, there is a value of C0, D0, A0 and B0. You're merging these two together and the common part gets is not duplicated. Now, there are multiple kinds of way which you can merge or join two data frames. The one of them is a left join. Now, think about it again. So this is what makes it very, very useful, where as we saw that through pandas, you can just load a data set into memory. Now, it is providing you almost DB level querying in the application itself. Very powerful, very easy to write, reduces, like in case you are working as an analyst especially and you are dealing with the database, reduces the amount of time you have to spend writing database queries, because they can tend to be very long and confusing as compared to simple Python code. Again, because of features like these that you see it being used a lot in data science, machine learning, and so on and so forth. So let's see what the left kind of join would do to us. So let's suppose I say merge left. Okay, we get a certain output. Let's do a comparison. So it says merges is on the left object. The left object is the first object over here. The leftmost object. So slide should actually say the leftmost object. So it's right and left. So don't be confused with the names over here. Okay, let me just actually rename them. Let me call them A and let me call this one B. So first I was doing A comma B. Let me now do B comma A and see if the result changes. Okay, the result did change. So left basically says A remains as it is, merge B to it. So merge B to it, which is this one. When you just interchange, it gives you the opposite when you merge from B to A. So B comes first and then A comes. This can be important if you are, you have unequal values or columns or something of that sort. So yeah, this can be a particular way in which you arrange your data. So this can matter, especially when you're trying to analyze the data. Let's look at the right join then. What does the right join do? Let's take this and do a right. Pretty sure that some of you might have already guessed what it might do. Right, so if you look at the right join immediately after this one, okay, and let's do the right join on this one. Let's see what we get. Okay, so this must be pretty clear, right? What is the difference between left join and right join? Let's look at the outer join. In this particular case, a full union of the two columns is made on both the objects, and let's see how we can get a outer join. This is, as it says, it merges two objects based on a full union of the two columns of both the objects. So what it does is that it does a full union, makes sure that both of them are present. Right, similar output, but this time it's an outer join. So the reason for a similar output is just because how the data is. If the data was a little different, then you would of course naturally have a different kind of output. So let's say the data was kind of like this, that there was a fourth value, a fifth value. Let's see what we get on an outer join. So on an outer join, we get both of them. If we were to do a right join in this case, what would we get? So right and outer are similar. Let's see if right and left are similar. Okay, so left is not similar. So what left does is it says I'll keep all the values of the first data frame. For B, if there is any extra row, which is in this case K4, C4 and D4, I will ignore it. So look at this output, K4, C4 and D4 got ignored. There is no fourth row because it was doing a left join. It was giving preference to the A data frame. When it is a right join, it will give a preference to the B data frame. And when it is an outer join, it is not that it is giving preference to either. It is basically going to join both of them irrespective of different values. So let's suppose it has a K6, okay? This was an A6 and this was a B6. Now you might think that, okay, now both of them have 5 rows. But real question is the key matching? Basically trying to match on the key. Now when it is an outer join, it is ignoring the fact that, okay, this key K6 is not present in the right one, K4 is not present in the left. So it is giving you this and this row. However, when it comes to merging on right, it is only considering the key, all the keys from the right data frame, which is B data frame. When you're doing a merge on left, it is considering all the keys from the left data frame and making sure there is a row for each one of them. So if you look at this one, right, this is K0, K1, K2, K3, K6. So the entire A data frame will definitely come. If B doesn't have values for a certain key, they will come as none. That's left. The first one gets preference. So right is the second one get preference. Outer is nobody gets preference. Both of them are included. I hope this is clear enough to all of you. Let's look at the final join, which is the inner join. What does the inner join do? Okay, inner join basically is like the simpler thing that we were doing earlier. It will just merge on the keys that are common to both. So an inner join or a normal join. So the default value when you do this, inner is the default value. So line 24 and 25 are same essentially. 24, 25 are the same line. Let's look at a particular use case of pandas. Let's suppose you have provided a large data set of country-wise statistics to extract knowledge from. Country, landscape, population, GDP, rural population, a lot of other things. Let's look at this data set here. So we have country, we have land area, population, GDP, rural. So rural is, I think, a kind of score. It's the percentage of rural population, whether it has internet or not, or what percentage has internet, what is the birth rate, death rate, elderly population, life expectancy, female labor percentage, and unemployment percent, right? And we have it for about 216 countries, which pretty much represents the world as of today. Let's explore the dataset. First and foremost, I'll import pandas, and then I'll import the dataset. I need to give it a path of the CSV. So all first thing I need to look at is the number of rows and columns, which is the shape of the dataset. So it has 215 rows and 12 columns. Okay, so first is the header itself. So it has 215 countries to 200 line 16, and it has 12 columns 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is correct. Let's check the kind of data types available in this data set. Okay, so the country is an object in terms of the pandas data frame, and everything else is a float 64 data type, which is also correct because all of these are numbers. Let's look at the first 5 rows. So one thing that it does is whenever the number of columns are huge or like they are of a certain more than, let's suppose these 6 values or 7 over here, 7 columns it can accommodate. Otherwise it will go to the next line, but you can basically see that it is referencing it as row 0. So this is just a representation. It's not that it has broken it down or anything. It is just displaying it by sort of breaking it to the next row. It doesn't have the space. So even though if you look at my computer, it has the space, but then there's just like a limit in terms of till what line it will print to. So it will just break it up, and these columns are, so this is essentially 5 rows. So don't think of these as 10 rows. This is 0th row, Afghanistan's land area, population, GDP, rural, internet, birth rate, and then Afghanistan's death rate, elderly population, life expectancy, female labor, and unemployment value. Similarly, you can check the first n rows of the data set as well. So let's pick a random number 16, run it, and here we have it. Okay, let us look at a statistical summary. So you might remember that we did this earlier. Very intuitive function. If you look at, I'm just calling dataset.describe. This is like one of those things that I definitely like and really admire about pandas or even Python in general. It's very descriptive. You just can sort of read it and understand it there and then. So dataset.describe. Now for land area, we have a count, mean, is standard, minimum 25%, 50%, 75% max values. And so we can immediately see that, okay, the GDP mean is 14,333. Rural internet all over the world is 43%. Female labor all over the world is at an average of 58%. Life expectancy is at an average of 70 years. Elderly population is at a 7.9% all over the world. Death rate is 8%, birth rate is 21%, and unemployment overall, the mean is 9%. The count tells us that, hey, these are the number of countries you have got the value for. Then you have the standard deviation, you have the minimum value. So the minimum value for birth rate is 10%, death rate is 3%, elderly population is 5%, life expectancy is 9 years old. Okay, that's pretty low. Female labor is 17%. So, it tells you something about your data set. So maybe, after you look at this and you're like, okay, 9, which are these countries which are sort of driving this value down to 9 in terms of life expectancy? The minimum value of, sorry, 45. Yeah, sorry, my bad. It's not 9. So that is standard deviation. That's the deviation from the mean. That's minus 61 plus 61 from 70. Now, doing this generally gives you clues as to where you might want to look. To a data scientist, oh, this is interesting. Which countries have the best internet? So which country has 96% internet? I'd like to know that, right? Like 96% of the land mass is covered with internet, is provided with internet. That's great, right? So that's where usually a lot of data science starts from. You look at your data, you try to make some sense out of it, and then you decide, okay, I'm going to use this algorithm or this analysis tool or this analysis process to kind of distill more insights and opportunities out of it. Let's look at extracting insights from data. Can we write a program to find the list of all countries within a size greater than 2000 or 1000 square kilometer? Let's first select only the specified columns from the data set. So to do this, what we would do is that we would make a variable selected data. I hope you guys remember log. We are going to go column wise. So we're going to refer to it by column. The first is that we want all the rows but only the columns country and land area. Next, we're going to write a simple for loop to iterate over this. For I in selected data dot iter tuple. So pretty simple, right? We just wanted to find countries with a size greater than 2,000 square kilometer. We just write it a simple for loop and here we go. See, so easy. The name of the country is greater than. So India, China, Canada, Brazil, Australia, Algeria. These are the land masses. We can also do it greater than 1,000. Then the number would definitely be higher. We can do less than 500. Let's see if there are any countries of that size. Pretty small. So a lot of countries, actually a lot of countries of that size. Let's do less than 100. I'm pretty sure we might find some. Okay, a lot of countries less than that size. Let's see if there is a correlation between the GDP per capita of countries and their birth rate. So, which is say that, hey, if the GDP of a country is high or low, how does it relate to the birth rate in that country? And what we're going to do is that we're going to go ahead and plot it on Matplotlib. We're going to plot our findings on Matplotlib so that we can visualize the data. So if you look at this particular problem statement, the reason why you would think about using Matplotlib is that it might not be easy to see a correlation through just numbers as compared to it being represented on a graph. So we're going to call plt.figure. I'm going to create a figure instance in memory. We're going to set the size as 50, 50. Next, we're going to read the dataset. We have already done that. Now, we're going to use this one and we're going to just select GDP birth rate. Okay, so we're going to plot a scatter plot. What we did here was that we created a NumPy array using the column just to see these data. Then we want to create a scatter plot. Of course, we want to call x limit so that we can just see between 0 to 2000 portion of it. And let's go ahead and do that. Let's go ahead and run it. And we have the rocket back for us. And yeah, so I mean, it gives you a certain level of insight. So these values are, of course, so I just went lazy here a little bit, did not mark this particular axis, but you guys should mark the axis. Now 2000, that would typically be a value of the GDP, and birth rate is going to be a percentage. So a birth rate, not such a strong correlation. In fact, countries with a higher GDP, if you look at the countries with a higher GDP, a lot of them have values less than 35. But if you look at the density over here, countries with lower GDP, they tend to have, so look at these values, for example, the GDP is the lowest, but it's one of the highest birth rates. And you look at this one, this is the top, right? Nearly 50% birth rate. Huge, massive birth rate for a country to have. And look at the GDP, it's tiny. So the correlation sort of exists, but not in the favor of the countries with high GDP. Countries with a lower GDP probably indicates inefficiencies, indicate developing economies, kind of struggling with population crisis, population boom. Definitely India and China and third world countries would count in. So yeah, kind of gives you an insight into what is happening. Really cool. And you can do much more. You can do similar analysis on so many other things in this data set and draw insights from it. Please go ahead and look at the columns, keep changing them one by one, and keep just running this particular thing, and I'm sure you will get a lot of insights out of the data. So this graph is a little different. It may be just that the data that I'm using and the one that was used for this one is different. Doesn't matter though. You can just use the data that you find on the course material, or you can use your own. Let's compare the GDPs of the 10 richest countries of the world. This time we will only select the country and the GDP. We already have the plot. Let's sort the data. So we have sorted the data by GDP. So I'm just gonna remove this and we're going to print sorted data.iloc, and we're going to print the first 10 ones. And we are also going to plot a pie graph. And we have the graph. This looks a little prettier. The selected sorted data of different countries, the top 10 GDP countries in the world. Let's look at developing web maps using Folium and Pandas module. What do we mean by developing web maps? Let's look at the problem statement. Let's suppose there is a person called John and he works for a disaster management organization. He's a researcher currently searching on volcanoes in USA and population in different countries. So he wants to basically map the population and the volcanoes in a given region. What is the benefit? He would be able to know how many people can be shifted to other countries or would need to be shifted to other countries if there's a volcano eruption happening in a given region. So he wants to look at the fact that, hey, if there is a volcano which goes off in a certain region and there is a large population or there is a small population, where all could it immediately go to in case there is a natural disaster of that sort. For this, he wants to design a map which will give him an idea about volcanoes and the population of different countries in a single map. So the single map bit is very important here, and we would look into it in terms of how to get that. Let's look at the logic to implement this. So the first thing that we need to do is we need to use something called as Folium. Folium is a Python library that can help us in dealing with and generating maps. So this is not Google Maps that we are talking about or Apple Maps. We are talking about generating our own map using the library called as Folium. Next is that we would want to create markers to show specific locations in a map. Markers meaning these icons, these pins. Next, we're going to import the pandas library for data visualization. We've already used this in the previous classes. Through it, we're going to read a data file containing the list of volcanoes and then use Folium to mark volcano's location on the map. Finally, we are going to import something called as world.json, and this file is going to allow us to mark the countries by population. And together, using the first part and the second part where we have created the markers over here, and using this, we're going to generate something which is going to look like this, which is showing the population of the entire world. Let's look at the steps to design a web map. First and foremost, you need to install Folium. The command is very simple: pip install Folium. In case you have any issues or doubts with this, please reach out to support. Step 1. So Folium makes it easy for you to visualize data that is being manipulated in Python on a very interactive leaflet map. Leaflet map being just a small map, not a navigable map like Google Maps, just a leaflet map like a fixed static sort of map that like the physical maps that we are used to, just the digital representation of it. Just the digital representation being Google Maps is very interactive with a lot more features, a lot more interaction, a lot more detail. But Folium is not going to have that level of detail. So, for example, Google Maps shows you locations, nearby interest areas such as hospitals or train stations or metro stations. But Folium doesn't do that. It's just a leaflet map in the sense that the level of detailing is not as much. It's not meant for navigation, right? The next is that Folium results are interactive. So there is some level of interactivity, but not as interactive as Google Maps. But definitely there are certain features that you will see soon enough which make it interactive. And Leaflet is the leading open source JavaScript library for making mobile friendly interactive maps. Now don't be confused by this. It's just that not that we are going to learn JavaScript. It's just that Folium makes use of the Leaflet JavaScript library which can generate these maps. Once we look at this, you will realize that it would internally be using some HTML, CSS or JavaScript to generate these maps. And for that, the Python library Folium basically relies on Leaflet, which is a JavaScript library. Let's look at the commands used. So over here, first and foremost, you import Folium. Then you have folium.map class, and these are the values that the constructor takes. It takes a location of arrays. This is the latitude longitude pair. Next, it takes the zoom level when you're starting the map. So when you're launching the map, you need to define the zoom level. The values can be anywhere between 1 to 200 or 300. I will show you the different results for the different values. And then the title of the map. So this is the title of the map that we would be generating. Now, for the sake of demonstration, let us try this out. So I've given it a random latitude longitude. I've given it a zoom level. Let's take this for a run. So now we have folium.html present with us. Let's open it in the browser. So we are not seeing anything here, but if you see that I keep zooming out, we do see something. So it's just that the zoom level was set very high. So let's set it to 200 and see if we get a better result. The process is finished. The file would have been refreshed. Now if you load it for the first time, still too deep. So let's just set it to a very low value now and see if that works. Reloading. Yes, that works. Zoom level 10 works. Let's try a deeper zoom level and run this and reloading. Nothing. So it seems that the values that it can take are limited by those numbers, but zoom start essentially gives you that level of depth. Let's try even a lower number and see what it shows us. Okay, now a wider map. Let's try 12 and see if 10 is the upper limit or not. So 10 is the upper limit. Even with an 11, I think we should get a problem. Okay, 11 apparently works, but 12 just does not. Okay, so now it's 1 to 11 sort of value. So the minute I go above 11, it just goes blank. There is no detail. So this is again one of the things. Like it's not like Google Maps doesn't have that level of detailing, but yeah, if you can zoom out and you can view the rest of the map. Now, what about the latitude longitude? That's where you want to place the center of the map at. So it starts. So the center of the map is that coordinate over here. Okay, that is what the center of the map. So if I was to change this to, let's suppose, 11, let's see what would be the new center of the map. Let's reload it. The center is this much. Let's change it to 5. Now this is going to be a drastic shift. Okay, now if you see, it's in the ocean. So we move downwards quite a bit. Let's set it to 40 and see what we get. Okay, we are somewhere. So we have almost reached Kyrgyzstan. We are quite high up. We have crossed India and we are now in the Chinese region of sorts. So this is how you can create a simple map using Folium. Now notice that this doesn't have any markers or anything of that sort on it yet. Now the next thing is that you can create something called as a feature group. Now this is another class present through Folium to you. What happens is that you create different feature groups for different kinds of things. So feature group that we want to create right now is volcanoes. What it will do is that it will give you an instance where you can add items to this group of items. So we will be creating objects. We have created a feature group object and we can add a list of or a bunch of items to it, not just one of them. So let's first create this feature group. Now what we can do is that we can take a set of coordinates like this and call this command called fg.addChild. So I'm not going to do this exactly, but I'm going to show you something similar. So I'm going to do fg.addChild. I'm going to add a pop-up and I'm going to place it slightly different from where the center of the map is, but within range. And for this, let's set it up as 9. Next, what you need to do is that you need to add the child to the map as well. So this is the map, this is the feature group. Feature group has children, and then the map also has children. Don't be confused by this. It works like this. There's a map, it is a feature group, and feature group has children. So map is the father of feature group. So map.addChild will take the feature group object. Let's run this. Let's reload the map. Let's see where a marker is. Here is a marker. Now if I click on it, it says hello. Why is the text hello being displayed over here? Because that is what you have passed in the pop-up variable. So I can say my home and I can set the color as blue. Let's reload the page. We are zoomed in. Let's zoom out. And here. Now it's in blue color and it says what I've told it to. So in this way, yes, you can make the map interactive. This is a sort of interactive map here. So yes, of course, you can add multiple coordinates as well, like it is being done over here. So if I was to create a generalized version of it, this is how I would do it. Now you should see two markers, right? So what we did was we just created an array of coordinates and we iterated over it. So it kept adding multiple children to the feature group. Coming to step 2, pandas is something that we're already familiar with. Now what we have is that we have the volcanoes USA dataset. This will be provided to you in your resources section. Now we have the volcanoes dataset. So how can we make use of this? So we just import pandas, we read the volcanoes dataset, and then we can print certain things from it. So let's just first run this. So it shows us what's in the file. There's a volcano, there's a number, there's a name, and there's a location, and there is a latitude and there is a longitude. There's a status, elevation, type, time frame. So there are different data points about the volcano. And we can see that for every volcano, we have the longitude and the latitude as well. So let's print this instead, just the latitude and the longitude. So if you notice over here, what you've done is that in the data frame, we have just accessed the column lon and lat. We got to know from looking at the data set. So let's run this again. So now the first array is the first series that you see over here on the top. This is the longitude, and second series that you see over here is the latitude. There is also something called as an elevation of a volcano. It's also an important data point, especially when doing considering disaster management. That's the objective of this exercise because that impacts the overall scale of the disaster as well. Like this is how high the volcano is. It can have certain deterministic factors in terms of what would be the strategy that would be used by John, anybody who's planning for this. So let's come to using Folium. Now the first thing that we will do over here is that we have just repeated the code here. We have got the list of we have got the separate individual arrays with longitude, latitude, and elevation. Next, we are going to define a method called as color producer. Now, what the color producer is going to do is that it is going to return a string which contains color based on the elevation. So we are saying that for every volcano which is less than 1,000 elevation, we're going to return the color green, and for 1,000 to 3,000 it's going to be orange, and for everything else which is basically volcanoes above 3,000 meters, we're going to return the color red. So the reason for this is that we will be marking different volcanoes differently using these colors so that we know which volcano is what is the elevation we just created ranges for that. Next, we're going to start the map and we're going to pass in these coordinates. Now, why these coordinates? It's just that the data set was of that sort. So the data set that we have given you here is USA volcanoes, and this basically latitude longitude pair is set accordingly. We give it a zoom level, we set a title, and we create a feature group volcanoes like we did. Next, we're going to use the zip function lat long elevation to create an iterable that we can go over one by one. So this is lat long and the elevation. It will merge lat long elevation and allow you to access them like this in a sequence. Next, nothing much. Again, location. So we pass it a latitude and longitude value over that value. And then for the pop-up, we're going to show the elevation. So this is in meters. So the actual elevation, we're going to convert it into string, add meters to it, and then for icon, folium.icon, we are going to pass it the color producer, the result of the color producer over here. So let me just show you what will happen over here. This is the elevation, right? This is what is going to come up in the pop-up. So let's take this for a spin, try the other one. So you see how for different elevations, we got different results over here. And these elevations, this was converted into a string here, meter was added, and then we called color producer on the element, red, orange, so on and so forth. What we would have produced is map2. So let's open this one. So we have all of these all of these pointers of volcanoes, latitudes and longitudes. And if we click inside it, we get the elevation. And as I said, this is the US based data. That's why we set the latitude longitude to that pair. As per this, we have green, orange, and red. That method is being called here. So folium.icon basically is another class present from Folium which tells you what should the icon be like. So it can take various parameters. Let's look at what all it can take. So you can pass it the color, the icon in type, like it can take different icon types as well. Right now it is taking this pointer, but you can pass it different icons as well. The angle that you want it to be at. So this is for you to explore. Really depends on what is the requirement for representation, how are you supposed to represent it, and you can just tackle it accordingly. So now we have got this. So as I was saying that this accepts strings only, so we are converting it into that value. Next is that now what we want to do is that we want to take up world.json and we now need to mark the population feature. So for what we do is that we create a new variable FGP, which is a feature group named as population. Then we call add child on FGP. Now this is a different style. So here what we did was that we created a loop. But what another thing that you can do is that for adding a child, you can pass multiple values as well. So we could have created multiple values out of this as well, or pass the correct kind of object. So over here in add child, we're passing folium.geojson. This function is used to show geographical data in maps from JSONs. So the data that we're going to pass it is going to come through io.open. You need to import io if you're in Python 2.x. So you do an io.open which opens this file, which is world.json. So this is world.json. Seems to be a very heavy file. It's just a JSON file containing the world data of population. So I open it in a write mode with an encoding UTF-8 sig and I read the data. So the data is read into this variable called as data. So we are basically GeoJSON. What it does is that it will mark the population of different countries
and then we are passing it a style function which is written using lambda, where we're going to give different kind of colors based on the geography. So green if this is less than this number, orange if it is, and if it is less than this, then red.
Like it is at the higher range, then we're going to give it a red color. Now let's add this to the map as well and run this. Let's see what we got as a result. So if you see, different countries are marked with different colors, and we have the volcanoes as well. So on a single map, what we have been able to do is we have been able to mark different countries, and we have been able to mark the location of the volcano. Next, we have a very interesting case study called the Titanic data analysis. So, as some of you might know, that there was a ship called Titanic which sailed from Southampton in US to UK, and it basically crashed and sank on its way there. It hit an iceberg and it sunk to the bottom of the ocean, and it was a big disaster at the time because it was the first voyage of the ship, and it was supposed to be really strongly built and on the best ships of that time. So it was a huge disaster, and of course there is a movie about it as well. Many of you might have watched it. Now, what we have is data of the passengers, those who survived and those who did not, this particular incident or this tragedy, and it has been compiled over the years and published. Now, what we want to do is we want to look at this data and analyze which factors would have contributed most to the chances of a person's survival on the ship or not. So, whether the person survived or died, does it have to do with anything common that they shared? Did the females or did the children survive better than the males? Did the rich passengers survive more than the poor passengers? Or if the fare amount, the amount of money you paid to get on the Titanic played any role? Maybe people who paid more money got evacuated first and there weren't anything left. What about the workers? The workers survived. What are the chances of your survival if you were a worker on the ship, not just traveling passenger? So all of these are very interesting questions, and we would basically go into them one by one now. Now here is what our data is going to look like, or it looks like. So we have passenger, which is a passenger ID. It's nothing but just a serial auto increment ID. There is no inherent meaning to this data. It's just roll numbers in a class. Next is survived, whether the person survived or died. 0 is for did not survive and 1 is for survived. Next is the name of the passenger, then the gender, age. Then we have something called as SIB-SP, number of siblings or spouses aboard the Titanic. So for this person, if they have any brothers or sisters traveling with them, what is the number? Or their better halves, that they have their spouses traveling with them. Next we have Parch, which is the number of parents or children aboard the Titanic. So if I'm a person, are my parents aboard or are my children aboard the ship? That counts. Next is the ticket number, inherently again sort of meaningless as the passenger ID. Then there is the fare, amount of money that the person paid. Then there is a cabin number, which is basically just the particular cabin that they were on in the ship. And finally, we have embarked, which is Cherbourg, Queenstown, or Southampton. Embarkation being where did they get on the ship. So first and foremost, let's load the data set and see where we get from it. So I have this here. So first foremost, we import the libraries. We import pandas, numpy, matplotlib, math. We have the Titanic dataset present over here in the same folder, and we are going to just do a pd.read csv. Then we want to print the number of passengers in original data, which is nothing but the length of the index. So just try to recall, just try to jog your memory about how you got the length of a data frame. So you can just, if you have the number of indexes in a data frame, which are the number of rows, then you have this particular data. So this is tf.index is an array. You take the length and you convert it into string so that it can get appended. So let's run this. So this is basically going to tell us how many passengers do we have information for. So we have 891 passengers that we can look at. That's a decent size. We can draw insights from a data of this size. Next is, let's look at the head. Let's look at the type of data we have. So as we said, passenger ID, survived, P class, 6, age, SIB-SP, parch, ticket, fare, cabin, and embark. So this is just a very cursory analysis. Let's dive a little deeper. So a lot of times what happens is that when you get data set from outside world, and because it's an imperfect world, a lot of times you will find that the data has certain missing values. So think about it in this way, that whoever collected this data about Titanic passengers, there would be missing information about so many of them.
the person couldn't be found, or some sketchy details came in, or something else, something was told, something was not told, something was never known. There are lots of scenarios like that. So let's just print the sum. Let's just have a look at how many of our values are missing. So we call is null, and then we can call some method on it. Let's see the output for this. So age is missing for a lot of them. K-bin number is missing for a lot of them. Well, age could have been a very, very important criteria, but apparently we don't have that for a lot of people. So let's see how we'll get by without it. But cabin number is not as important, so we are good that way. So what we're going to do to solve this issue is that we're going to remove passengers which have age as null. So we are going to use the not null method available in the pandas library, and we are going to pass it the column for age from the data frame where it is not null. Now here we're using the word wrangled. So wrangled is any sort of manipulation or any sort of dealing with the data. So in this case, wrangled for us basically means that we have removed certain values and we are just dealing with a modified version of the original data. So now the number is 714. So we removed all the passengers from our consideration which did not have a age provided to us. Next, we are going to look at gender. So number of passengers in age and embark wrangle data where age and embark both missing. So this is the embark wrangle data. Now, what we want to do is that we want to group data by gender, and then let's first do that. So for doing that, we're going to define a new variable gender data. We're going to take this data frame embark wrangled, which doesn't have any missing values for age or embarked. Now notice we did not do this for kbin, even though there were a lot of values missing, because inherently it is useless to us. Now, of course, this is where your judgment call comes in. This is where your brain is used to decide, okay, this is not useful, and we can do without thinking about it. For this, we simply call the group by function, which is going to group by on the gender or sex. And then what we're going to do next is very interesting. We're going to take out the mean. So the mean of the gender data. So let's see what we get for this. Now, what we have done first is that we have calculated the total survival rate, where for the survived column the is 0.40. So 40%, only 40% people survived the disaster. That is what we calculated, because we took the column survived, which was zeros and ones, and we took the median value. So there were 41 ones and of the 100 were zeros, then it will be 40 over 140. That's what this mean will be to figure out the survival rate. Otherwise, it wouldn't be the survival rate. It's just that because it's ones and zeros. That's why you've got the mean survival rate here. Next, what we're going to do is you're going to get the mean data that we have created by gender. So we're going to look at the mean values for all the data points. So for a survival rate or chance of 40%, what was the average gender, what was the age, what was the P class, CBSP, what are the different values for an average case. So for an average case, for a gender of female, so notice first and foremost how it is created two rows for text-based data, because it automatically realized that hey, there is no sense of saying that we took a mean of male and female. So where male and female are completely different, so they've been marked as such. If they were not marked as such, if there was no sex column, then of course there would be only one row. But because we have identified this as a feature, this as something which is a contributing factor. So we are saying that gender is going to be a contributing factor to the survival rate. And we can sort of see that how, because for female passengers the survival rate is 75%, for male it's only 20%. Immediately we know that females were preferred over men, women were preferred over men when it came to survival, which is usually the case in cases of disaster. Then we have other insights about the average age of a female passenger which got saved and the average age of a male passenger. We have the P class, which is sort of consistent, that it's greater than 2, but still a lot of even female passengers from the lower classes were saved. We also had the SIB-SP, which indicates that a lot of female passengers were traveling with children, is indicated in Parch. 71%, a lot of women were traveling with the children as compared to the men, which is at 27%. So again, women and children, if this 27% are the men who were traveling with children, that adds to their chances of survival. So the way this adds to the chances of survival are, if I'm a man and I'm traveling with a child and I don't have a sibling or a spouse and I don't have a parent, then I get the second preference because I'm traveling with a child and the child cannot be left alone. So for women, the preference order comes with children, then women, then the next one is men with children, because the child needs to survive. whenever the child gets thrown into the lifeboat, the men and women who are solely responsible for that person, for the child, also get added. Like, we can build that as a hypothesis. All of these are theories. This is basically hypothesizing as a data scientist or as an engineer, but you validate all of these hypotheses through data. So I may be wrong about what I just said. Maybe data will tell us a different story, but that's really the nature of the game, where you have to be ready to be wrong about things, and you have to constantly still assert until you're proven wrong definitively, and then you move on to another theory and another theory. But being proven wrong doesn't mean that you should stop there and then. It means that you should keep exploring. It at least cuts down one of the options in front of you, and that through data. We are playing by eliminating choices. So few other observation: women tended to be younger, travel with another person, have a greater number of siblings per spouse, SIB-SP feature, and children parents feature again stood out. So another interesting thing is that women paid more for the fare, $47, as compared to the men. Now, because the survival rate is so high, so then the P class socioeconomic status, which is indicated by the P class, is also lower because it has a lot of mixed people then. At this higher number, the P class average would be a higher number, of a lower number, because a lot of people get mixed. Let's do further investigation on gender. So now this tells us the number of female passengers and the number of male passengers present with us. Next, what we're going to do is that we're going to set the columns of DF, because what we're going to do is that we're going to set the columns as sex and total instead of sex and passenger ID. So let's do that and print total DF again. So now it has changed. The data point hasn't, it's just that we have changed the column name. Earlier it was mean data and by gender, but now we have changed it to sex and total. Now next we're going to get the gender list in another variable, and we're going to delete that column from total DF. Let me print total DF here and let me print gender list. Why we deleted, I'll come to that in a minute. So first is that we printed total DF with the sex column deleted. So this is the with the sex column deleted in total DF, this variable. And then we have gender data, which is basically a group by object. So I mean, it's a class object. We can't do anything with it till now. Next, we do something called as gender survived data frame. Let's print and see what we get over here as a value. So now what we have is that we have gender list. So earlier we had a total number of people, total number 259, 453. Now we have the survived 195 and 93. These are now two different numbers that we have. Let's delete the sex column from this. So here we have the gender survived DF. Next, we're going to combine the two together. So what we're going to do is that we're going to take total DF, from which we deleted the gender column, and we're going to take gender survived DF, where again we delete the sex column. We're going to combine them. But why? What will this give us? So it will give you the survived and the total by gender. So we just did not need it over here. That's we just kept deleting it from elsewhere. Next, we can go ahead and plot this. We can plot on a graph how the survival rate varies. The first thing is that we call the dot plot method bar graph that is available to us on the data frame itself. We pass the color lime green and dodge blue. We give it a title. We give it a label, x label, y label, x-axis, y-axis. This we know. So we are going to plot the gender across the x-axis and the number of people on the y-axis. We are going to set the text. Next, we're going to set the survival gender list. So this is the survival gender list in zeros and ones. So 0 is female, 1 is male. Then the total gender list, again male and female. Now we have also defined a small function to create labels on the plot. What we will do is that we will pass it the survival gender list over here, which contains the data for the survived according to gender. And we're going to take this PLT object present over here, and we are going to plot the x plus x adjust. It's just a minor adjustment to plot it, y plus y adjust, and we're going to give it the color and the font weight. So how we have done it till now. So we will do this for both a survival gender list and total gender list, and then next we're going to plot this. So this is the effect of gender on survival. If you notice, effect of gender on survival, the color, x label is gender. So basically whatever we pass to it gets printed over here in the plot. So as it appears, on average, women were more than 3 times likely to survive than men. And due to the binary nature of the survived field data type, where we are not considering injured or anything else, we're just saying pure survival, like we do assume that there was nothing bad that happened to them afterwards, which would be considered as caused by the incident or the accident. So we can confidently say that 75.3% of the women from the data set survived, while only 20.5% of the men survived. Now we can also draw further insights from whatever we have done till now.
Here are a few additional questions that may provide further explanation for why the women survive 3 times more likely than the men. So we can look at what is the effect of age on survival rate. We can look at what is the effect of company, whether somebody is traveling with the person or not. We can then also look at the effect of socio-economic status, which class, how much fare did they pay on the survival rate of the said person. Let's first look at effect of age on survival. So what we're going to do is that we're going to take the embark wrangled data frame and we are going to group by survive, and then we're going to take a mean of that and then we're going to print it. So we grouped by on survive and then we took a mean. So if you look at age, for females the average age is 30.62, for men the average is 28.19. So here we can see that survivors on average are younger, are presumably from a higher socioeconomic class. That is a more luxurious class ticket 1.9 versus 2.5 over here. So P class, luxurious class ticket and a higher ticket fare $51 versus $23. Travel with less siblings and spouses and travel with more parents and children. So for survivors, we can say that they are younger, they are traveling with fewer people, at least when it comes to siblings or spouses. They have paid a higher amount, but class is not as great as the other one. But there are certain things that we can ascertain from this data. So continuing further on this to figure out the effect of age. So first thing we're going to do is we're going to split the data into children and adults. And the way we are going to do this is that for children data, we're going to set the criteria of age being less than 18. So we are going to create a filter on the existing data set using this as well. Now this syntax can be confusing to a lot of people. If it is confusing in terms of how this is working, this is where pandas comes into. I am filtering on this pandas data frame using a condition on the data frame in itself. This is a very common way of using the pandas data frame if you're already not familiar with it. Next we're going to get the adult data. Again, the condition is of it being greater than 18. Let's get a count on the children and a count on the adult. So we take the children data passenger id.count and take the adult data passenger id.count. So the reason why we are taking the passenger ID is because these are going to be unique. Passenger IDs are not going to be repeated. We can expect that. Now let's take out the survived children count. So we take children data and on the column survived we do a sum. So because survived is 1 and 0, so the number of times you count 1, it's just going to add up to be the number of survived children. And for survived adult count, we can do something similar. Next, we are going to just put this simply into list. We're going to create a children list of survived children count and total children count. So think of this second one as the total children count. Similarly, for adults, we're going to create a list and then finally total. So let's stop here and print these three lists: children, adult list, and then the total list. So just to kind of sum it up, what we are trying to do is that we are going to get the different counts for survived versus total children, and we are also just accumulating data. And where is the intuition, or where am I getting the idea from? It's just because I want to compare by age. So that is the initial idea we're running with, where we are saying that hey, let's split it into children and adults and then let's look at the data. So let's run this. So the data is that 70 children survived out of 139. For adults, 218 survived out of 573, and the total number of children are 139 and 573. For the total survival, you can just add two items in the list, survive list. Let's create a pandas data frame out of this. We will call it CVSA data frame. What are the values in this data frame? The children list and the adult list. First row for children and second row for adult coming from this data. The columns are survived and total. Let's see what we're going to get here. So you can see for survived children we get 70 and 139. For adults we get 218 and 573. So we kept collecting it, and this is where we ended up using it. This first element is an array, this second element is also an array, which is making an entire row. So the index is children here and adult here. So we are setting the index. So this is corresponding to this row, this is corresponding to this row, because index is row wise, and then the columns are given as survived and total. Let's create a simple plot out of this. We're going to call plot.bar, and then we're going to simply, as we have been doing till now, set the title, set the y label, set the x text, and we're going to call create value labels as well, function as well. And finally, after all of that is done, we're going to plot it. Let's run this. Let's see the graph. So we can see for adults, this is what is happening, and for children, you can see a ratio of 70 is to 139. We have just taken the data and drawn it up. Next, we can create another plot where we take the survival rate for children and adults. Now this was children against the total children. Now we're going to compare children to adults. We create a new list and we call plot.bar, and we change the table. We change the title and the label. So let's run this. So this is one plot and we get another plot. This is gender versus survival. We get another one, survival rate between children and adults. So this is rate. So children have survived 50% of the time while adults have survived 38% of the time. How did this graph come? Through this, where we children data dot mean survived, adult data dot mean. So we took the mean, and the mean would be these values 0.50 and 0.38. After that, we just plotted it, nothing else. So this is survival rate between children and adults. So what can we conclude from this? We can conclude that 50.7% of the children from the dataset survived, while 38.1% of the adults survived, resulting in children being 1.3 times more likely to survive than the adults, which seems logical given that is how human beings tend to respond in a tragedy where they save the children first as compared to the adults. Let's look at the age distribution of all passengers. Let's see if that gives us any idea. For this, we're going to draw a simple histogram. So for this, what we're going to do is we will take the embark wrangle data. So in case you've forgotten what this is, we used it earlier. Let's see what the embark wrangle data is. So this is the embark wrangle data where we have removed the null values. And we're just going to plot the histogram of age distribution of all passengers, because we have taken the age column and we have called .plot.his begins with the range of 0 to 100, because that is the range we expect from 0 to 100. That is the human age. The human age is not in decimals with us. It can be represented in decimals, but then we just want to see how many people are of what age. Just in case you're not able to recall any of this syntax, how is this drawing a histogram, what all these are doing, I strongly recommend please go back, have a look at the module around matplotlib. So this is the histogram of age. So as you can see, there are a lot of passengers in this range between what seems like 18 here till the age of at least 38. So this is 38 or 35 actually, and this is around about 14. So from 14 till this number, so I'm watching the x-axis as that is appearing over here, and we get the same histogram. Let's look at the distribution of survivors in particular. This was not just for the ones who survived. Let's look at the ones who survived. We call the same one for survivor. So we have the survivor data. We can put the age label. Let's see what we get. So this is for the survivors. Now, as we saw earlier, of course, it is going to favor the young way more, where for children it's going to be quite high, and the survival rate is quite poor after 40. Let's now look at the effect of age on survival. First, let's look at survived stat. We are trying to do a describe. Let's look at what the description tells us. So for survive, we have the mean, standard deviation, minimum, 25%, 50%, 75% values. So the mean is that pretty much expected, but these are the survived stats. Now what we're going to do is that we're going to take the age data, because we want to check the effect of age on survival rate. We're going to group by age, and then we're going to take the mean. We'll create a list out of it. Next, we're going to use a scatter plot to plot the effect of age on survival rate. This is how the survival rate varies with the age. Some of these numbers you can see the survival rate just goes down to 0. And for some of these numbers, the survival rate is almost 100%, where we can say that if the person was of this age, or of this age, or of this age. This is not saying that this is a certainty, but this is more of what the data is telling us, that this is true, that if you were of this age, for example, if you were of 80 years old and on Titanic, you would definitely survive. But this is no pattern as these are just probably chances, because this is not the norm. But otherwise, this is a more realistic version of it. Now, please notice that we have used a little more complicated scatter plot here to kind of draw it out, because you can see the kind of effect we got. So what I would recommend is that you look at this yourself. What is alpha, what is C, what is C map, edge colors, the color bar which is appearing on the side, if I can show it to you again. So this color bar again, how it is coming up. Thing that is really required in programming that doesn't get talked about as much is the ability to read documentation and teach yourself, because it's a lifelong process. Every day will be challenging, every day there will be something new to learn, something new to do. Because of that nature, you need to develop that independence of sort. So what I would recommend is that you look at this piece of code, go back. If you can't figure it out, I would suggest that you reach out to the support, because I can tell you right now what all of this means, but then these things wouldn't immediately register. What I would instead recommend is that you change some of the values. So one thing is that what if we set S as 10? Can we sort of figure out what changed? So maybe, I don't know, the dots have gotten a little tinier. Let's change S to a really low value of 1. Let's see if we can discern what changed. So if you notice, now the dots have almost disappeared. They are present. So S basically determines the size of the dot. If we set S to, let's suppose, 100, a bigger value than before. So this is purely experimentation, and I encourage you to do it more and more with whatever code you are getting from us. Now this will help you out quite a bit. Now let's try it with this one as well. What is Vmax? So now 34. So if you notice the number of passengers, this color bar range has gone up from 30, it was earlier 30 in case you did not notice, through 34. If I set it as 35, even the 35 number would appear on the bar. So notice how there is no 35 right now. Let me run this. Now there is a 35. Let's do a little more data analysis before we leave this data set. So the first 5 ages only have 2 or less passengers in their age group. So the first 5 ages only have 2 or less passengers in their age group. With such a small sample size, the survival rates may not be representative as those with large sample sizes. So in the sense what we are saying is that let's suppose there is an age of 12 years old, but it has only 2 or less passengers, either 1 or 2 passengers which are 12 years old. Now, if you were looking at the survival rate of 12 or 1 versus 22, where you had 100 passengers or you had 50 passengers, you don't have enough sample size. The denominator in that equation of the total number of people of age 12 and the total number of people of age 50, it is not large enough for you to sort of be certain that yes, this is the pattern, because 1 out of 2 or 2 out of 2 is not a big thing to happen, but 50 out of 50 establishes a trend. If 50 out of 50 people of age 22 survived or did not survive, it tells you very clearly that hey, there is something happening with that age group. So some reason why the ones who were 22, they were considered to be too young or too old or something else, or they were helping out in a certain way, that none of them survived. Let's do one thing where to get more insights into our data. Let's remove passengers with ages in which there are 5 or less passengers in the group. For doing this, what we will do is that we'll get the total count age. This is nothing but the total count of passengers in itself. Then we are going to get count age GT5. So GT5 stands for greater than 5. So where we are going to do, we're going to take the count age, your count age particular your column, your data frame, and we're going to count for where it is greater than 5. Next, we're going to create a list out of it, and we are going to keep only data where. So we're going to call the embarked angled data frame, we're going to use that, and we're going to filter that on this list. This list is going to contain certain ages. Let's see what ages it contains. So these are the ages it contains, okay? Now we are simply telling Python or telling pandas that hey, just keep the passengers which are ages as 1, 2, 3, 4, 9, so on and so forth. Remove all the other ones. So let's see what we get. So now the number of passengers has gone down because we have removed certain age categories which did not have enough representatives. This is only useful when you're looking at things from an age perspective. If you're looking at it from a gender perspective, probably you would have removed people of a gender if it was non-representative. If only 2 females were on board, there was no point of looking at it from, hey, okay, this is the survival rate in females and males. So because there were sizable people in those sample sizes, and this is something you need to be very careful about. Sometimes you might get data sets, there is a classification or there is a labeling for a certain age group, but you can get thrown off. So let's suppose in the previous scatter plot where we saw with certainty that okay, anybody of age 80 would have survived. How do we know that this isn't one person? Because this is a survival rate, this is not a survival count. How do we know this is not one person each? So 1 out of 1 doesn't confirm anything. So what we are saying is that not these ones, but essentially would be able to consider the ones where there is enough sample size. We take the data that we have and we plot a histogram of the ages. Now these are for ages which have enough sample data, that is more than 5 people. So you immediately see that there are a lot of gaps. These gaps weren't present earlier, but now these gaps are present because we have removed these. These did not have enough number of passengers. So anything less than 5 number of passengers is removed. All of these are greater than 5. And you can even discount for these ones. You might want to consider everything above from 10. Depends really on the max number of passengers in a certain age. Now let's look at effect of age on survival rate given that we've cleaned the data, given that we've removed passengers which are of less than certain one. So we are going to draw a scatter plot again. We're going to group data by age. We're going to get the mean. We're going to get the number of passengers in age greater than 5. We're going to do a count and then we're going to do a scatter plot. And this is the outcome. See, immediately that top row gets disappeared. The top row is no longer available. So if you notice now, that top line, that survival rate of 1 has completely disappeared. There is no age group now which has a survival rate of 1, that all of the passengers of that, because it seems that we had a flawed input. So if you went by what we saw here, effect of age on survival rate versus effect of age on survival rate clean data. These are two different ones, and this is a more valid one if you ask any data scientist because sample size wasn't filtered out properly earlier. So here are some other plots that we can look at: effect of socioeconomic status and survival rate, Dobot, and then we can also look at that the ticket class and fare rate can be indicators of social economic status. If you can focus on investigating ticket class as that is specifically stated as a proxy for SES by the data dictionary. So we can focus on the ticket class is what we are trying to say, that both can be indicators, but we can look at ticket class because even if fare might have been lower, but then those days they were very strict on who traveled in what class. Yet we have certain gentry type be able to travel in first class. Now that way we can not just the economic status but the socio-economic status also gets indicated, where we can say that more prominent, socially prominent people were given the preference. And for fare rate and ticket class can be expected to be inverse. That is, a first class ticket is likely to cost more than a third class ticket. And you can also consider that for a third class ticket, most of them would have been bought. Nobody would have given them away. Whereas in a first class ticket scenario, in a first class passenger scenario, people would have bought for other passengers, people would have given them for free. They might have gotten a discounting because, hey, there's a prestigious politician and he's traveling on the first voyage of the Titanic. He might have just paid nothing but like £10 or $10 for it to get on that boat. So this is something that we leave for you. We suggest you go ahead and do it, and you should sort of see this sort of a plot for survivor class of 1, 2, and 3, and then the number of passengers in each. And then you can do a non-survivor class ticket distribution like this is survivor, where we see naturally they are higher in first, but the disparity is not much between second and third in survivor. But when you look at the non-survivors, number three, these are the ones who suffered the most. And overall, the effect of class and survivor rate. So survivor rates are better if you are a first class 65%, a second class 47%, and a third class 23%. There's a reason why we haven't shared the code for this, because it is suggested that you go back and do it by yourself. There is enough sample code for you to kind of work on any of these graphs to reproduce any of these given graphs. Let's talk about the first application, web scraping. So here is the problem statement. Bob is an intern and he wants to have all the hyperlinks from a web page. All the links that are present on a web page, he wants to collect all of those. Let's suppose it's an information website and he needs that information for because his manager has asked him for that. Okay, or his superior has asked for all the links or all the information about travel websites. Let's suppose that. Now, one way is of course that you can go to the website, copy the link, open them one by one, just down like copy pasting back and forth. Yes, you can do that for 100 websites, let's suppose, but like you can do it 100 times. But then there are a couple of problems with it. First, it will be slow, it will be prone to error, and it's just like apart from other things, it's just a very boring thing to do, right? Copy pasting all the time. So here is where Bob thinks that he should be sort of smart and do intelligent work rather than clerical work. And that's why he wants to write a program that will save all the hyperlinks from a specified web page. And he wants to write it in Python. So web scraping comes to the risk. Web scraping is a commonly known technique where you can extract large amount of data from website, okay? And you can save it to a local file in your computer or to a database. Now, what kind of data? So this could be text data, this could be image data, this could be just collection of links, as Bob said, but usually it is a bunch of things. So here is the fun fact. Google or any of the search engines that you use today, it works on web scraping. So part of it is that the results are not generated immediately, in the sense that Google indexes or crawls and scrapes data from the entire web, website by website, following link after the other. So it's like, think about it like this. It goes to wikipedia.org, it copies the text over there and saves it as wikipedia.org's text. Then it finds all the 10, 20, 100, 200 links over there, follows each one of those, and keeps doing this repeatedly over and over and over again. And just by doing that, it has managed to scrape or crawl. So think of it like a spider as shown here, like going from link to link. It's actually called as crawling and indexing. So there are a couple of libraries available in Python for this, and these libraries are very advanced, and advanced in terms of they're very ready to use. You don't have to do a lot of things to kind of get going with using these libraries. The first one of these is called Beautiful Soup. Okay, so it's a Python library for pulling data out of HTML and XML files. Now, what happens is that if you go to any website, so let's suppose we go to edureka.co. If I do a right click and I can do something called as view page source. Now this will give me all the HTML CSS present on Edureka, right? So this is the HTML CSS that makes this page. this, right? So let's suppose if we search for something like Python certification training, we can find it in this text. Of course, there is a lot of other HTML, CSS, or a lot of things present over here, but you can sort of map it to whatever you see over here, the images, the amounts, and everything. So the amount is present over here, right? All of these things. Now, what happens in scraping is that you programmatically download this entire page. You get all of this data. So one thing is that I could, right now select all of it, Control C, and then go to PyCharm and paste it over here. So it will take a second. There's a lot of text. So see, so it's all text at the end of the day, right? A website is nothing but text. So one thing is that I could have done that. The other is that I download using Python and then I search for data using Python. So right now, if I search for data, I'll have to really read line by line, and that will take a lot of time. I mean, it's better to just copy it straight from here then. So what happens in scraping is that where Beautiful Soup comes in handy is that you give it the HTML text document, which is nothing but very similar to a text file like Python file, and you ask it to search for certain things in it. And how you ask for it to search for those things, we are going to learn that. One other thing which is going to help us is request library in Python. It is used for making HTTP requests. So the downloading part of the web page, requests library is going to help us out with that. So let's look at the request library. What we can do is that we can take a web page. So this is a sample web page. It's from the Thomas Cook website. Let's just open it. So it shows holiday packages in a place called as Kerala in India, and it seems to be loading. So we're going to take this URL over here and requests.get. Okay, so the get method is available on this. So the get method simply downloads the entire HTML file, the response of this HTTP request, which is a web page, and it gives you a variable return that we are storing in R, and r.content is where you can see the contents of this web page. So let's run this file and see what we get. Okay, seems to be some issue. Instead, let's try and see if we can make it work on Edureka. Okay, so we got Edureka's website, and there is some data or something available over here for sure. This is what I just did, right? Now we have it in a variable. Let's move further. Next, what we need to do is that we need to import the Beautiful Soup library. Now, please note that you don't import from Beautiful Soup, you import from something called as BS4. That's just like the convention. So it's Beautiful Soup version 4. Now, what you do is that you call something, you create an object called soup, you pass it the content, and you specify that you want to use the HTML.parser class, where you want to use it as an HTML. And this has a function called as prettify, which will print a pretty version of this web page. So let's try this out. Okay, so we now have a somewhat pretty version of the web page. What this does for us is that it helps us in sort of analyzing particular thing, how the web page is structured. So we can do that in the browser as well, but maybe in Python as well. Sometimes, you might get a response and you want to just have a look at it within the console. So we can see the structure in a very clean cut way. So we have already done this where I've shown you how to view the HTML code of a web page. Now, let's suppose you wanted to get all the links. Very simply, what you will say is for web link in soup.findAll function. So we're going to use the findAll function, and we're going to find all the tags which are in the A tag. Okay. And next, we are just going to print web link and see what we get. So as you can see, we have gotten all the A links over here, all the A links. And what we need to do next is that we need to use the get method on this. We just want to get the href attribute. We don't want to get anything else. So we have all the links over here that are present in the href. Now let's create an empty array to store all of these links. So what we'll do is that we will just call links.append, and we'll start collecting all of these, and then we can just print. So it's just we're going to collect all of the neatly in an array and use it for the processing, right? So we got all the links in the array. So this is how you can basically scrap the web page. Now, of course, you can get more information from the web page as well. Let's suppose you wanted to get all the prices for a course. So what you do is that you sort of analyze the web page. You see what kind of data present. So if we look at this one, right? Icon INR. So anything which has a class of icon INR seems to, it always carries the amount. So let's confirm this. Let's search for icon INR in our web page again and again. So wherever there is an icon INR, there is some sort of a price being shown. This could be a way to find the prices for the various courses and store them. So if you have ever seen any of those price comparison websites, this is how they work. So what we need to do is that, let's have a look over here. Okay. Or rather, we need to select the after discount class, because these are not the discounted prices. We want to get the non-discounted price, like our post discount price. So let's try to see find all will help us out here. We want to find after discount, and because this is a CSS class, so let's see how we can select by class using Beautiful Soup. So it suggests that you use find all and you pass it the element type and the class type as well. So what we did not pass is the element type. So first is span, and then you need to give it class parameter like this, class underscore. So you're going to say that it's going to be class after discount. Let's see if we get any result out of this. Okay, so we got something. Now how to get the text out of this and how to get the course name. Let's go to application number 2, data visualization on the browser. Till now we have used matplotlib to visualize data in the Python window. Let's look at how we visualize data in the browser. So Nate is a data analyst who wants to analyze data and create a visualization on the browser, okay, for presentation purposes. So Bouquet is a Python interactive visualization library that basically produces presentations and visualizations for the web browser. So it is used widely as it allows for building complex statistical plots quickly using some very simple commands. Okay, so let's see what it is all about. First, you need to install Bouquet. The command is pip install Bouquet. Now let's plot a very simple plot using Bouquet. I have something ready for you here. So from bouquet.plotting, import output file show and figure. Now these are methods available from Bouquet. You create a data set like this, and basically you create something called as a object using figure, where you set the width and the height of the plot. Then you create a circle using the data set x and y, and you give a size. This would be the size of the circle, and you set the output file as scatter charts, and then you finally call the show method. Let's use this. Okay, so this is scatter charts. Show method basically opens it up in the browser, the default browser on your system. Let's try to change certain things. So we had the dataset X, which is still 1, 2, 3, 4, 5, and we have the dataset Y, which is still 1 to 25. Okay, so we have passed the dataset X and Y circle, right? Now let's suppose the size of this was 50. Let's see how it will change the output. You can see the size of the ball. This is the size of the circle. So this is basically telling it, hey, draw a circle at this X and this Y of size this. So as many points are present in x and y, it will plot all of them. And this is the plot width and the height. So now that we are crossing the height, let's set it to be higher. We can make it something like this. Now you see it's a big giant plot. And all of this is being made in the browser using Python. Let's suppose we wanted to build a scatter plot instead. Now for this, what we're going to do is that we're going to download a data set from this particular source. It's an XLSX. It's just some sample data. You can go back and have a look at it. We're going to just read it through Excel. You need to install this library called XLRD before you can do this. It's something that you should install in case this is not running. It will probably throw an error that XLRD was not found. So just pip install XLRD in case you run into an issue. So next thing is that we take this data set and we take the temperature column and we divide it by 10 just to sort of normalize it. Next, again, we create a plot figure. We give it a text, color, Arial, all of these things. These are just markers, okay? Pretty self-explanatory, text color, text font. Because it's in the browser, it allows you for a lot of flexibility that way, right? And then you create the circle. You set the size of the circle. So let's run this. So this is the result that we will get. And while it may seem like you can't make too much sense out of it, just notice that all of these are very individual points and these are being marked to the size of 0.1. Now I could regenerate the graph, but I think it would take a lot of time. But notice that it's a lot of points. It's not just like, 10 or 100 points. These are like probably 20, 30,000 points at least, in the very least, being plotted all across this graph. So please keep that in mind. Let's move on to the next topic. So for the third application that we're going to learn today, we need to first start with understanding how a computer reads an image. So you and I see this image right here, okay? but we perceive it in a certain way. We look at it like building and sky, and like that's how a typical human being would react. Oh, this is a skyline for a certain city. Oh, there are lights, there are windows, it's evening time, and all of those things. But here is sort of how a computer sees it. The computer sees each and every pixel, each and every point in the image as a combination of RGB values. Okay, and the RGB values contribute to what that pixel's color is like. So each individual pixel is basically nothing but a number for the computer. It's a set of numbers. Overall, the image is a set of numbers. It's a two-dimensional matrix that you have been given by the computer. Now, the size of the image will be B cross A, which is the height and the width of the image. So whenever you hear the word resolution, like 1024 cross 768, so it's 1024 pixel columns and 768 rows into 3. Why into 3? Because R, G, and B. So that is how the size of the image comes out, because all these three data points are present for every pixel, the R, G, and B value, because that's how a computer shows an image. So if you've ever noticed how image looks different on different monitors, so the same image can look different on different devices and screens, it's because pixel in itself, how does the screen or the device that you're looking at the image on, how does it treat the R, G, and B values? What is it able to do with those three numbers? And these are numbers, simple numbers like 255, 237, and 108, right? For R and for G and for B. These are numbers. How does it really manifest them? How does it paint that color? And that is where all the sharp and contrast and quality and all of those things come in. Because even for the same resolution, what a laptop might show might be very different from a full-fledged desktop, right? With a big screen or with a better screen. So this is how the computer basically looks at an image. But coming to OpenCV, it's a library, okay? Now, but it's not just a Python library. Now you will find OpenCV is something that got written in C and C++, and then all the popular programming languages such as Python and MATLAB and Java and C Sharp and .NET, they wrote libraries on top of it, which are using the original C++ code. Why? Because the OpenCV library is super powerful. It has a huge community behind it, and there's a lot of things that are developed under OpenCV. A lot of image processing that you see, a lot of things you see on your cameras these days, which recognize face detection and everything. That is essentially, a lot of that is built on top of OpenCV. So it's open computer vision essentially, and not just Python. Other like Java also, for example, has a wrapper or a library built on top of OpenCV. So let's look at few basic operations using OpenCV. First one is to read an image. So the first thing you need to do is, first of course, you will need to install OpenCV on your machine. The command is pip install OpenCV-Python. So let me just show it to you over here. Rather, let me open a terminal. So if you had to open CV-Python. I'm not going to show it to you here because I've already had it installed. Just one word of caution, this is a heavy library, so please make sure that you're on a stable and a good internet connection, otherwise it might fail while you're trying to install it. So it's one of the heavier libraries. Just make sure that you're on a stable internet connection before you try to install it. Okay, going back to this. Now, what you do is that you import CV2. So inside Python, it's called, not called OpenCV, it's called CV2. And simply, if you want to read an image, you pass the name of the image, I am read, followed by the format that you want to read it in. So you can read it either as grayscale, which is basically reading it in black and white, ignoring the colors, or you can read it in a colored format. So let's read the image. Right, so 1 is for colored and 0 is for grayscale. So grayscale is something that you will hear often. So grayscale is nothing but converting an image into black and white that we often see. So now that we have read the image, let's print the image as seen by the computer. Let me blank out all of these. Okay, let's run this file. Okay, so nothing but a sequence of numbers. As we said, RGB, R, G, and B. Let's look at the axis. So it has 3 dimensions. Let's look at the head. Right. So we basically get a NumPy array, n-dimensional array. In this case, it's a 2-dimensional array because height and width. And then each of the arrays has a particular value. So let's see, what do we have in 0? What is at the 0th value? Let's look at the first one, 0, 0. It's a 2-dimensional array, right? Okay, these are the values that we have. So this is 1 pixel being described. Similarly, we can have multiple such pixel values. Different values of R, G, and B. Now we have something called as image.shape, which tells us of the dimensions of the image. So, and this is available through NumPy, not through OpenCV. We have just read the image into a NumPy array over here, and image.shape is something that is available to us in NumPy. Now we know that it's 768, 1024, and 3. 3 being number of points that each particular position has. Now we have something called as IMShow. What IMShow does is that it will just open up a window and show the image. You can give it the title that you want, penguin's image. Now, why is this important? It's important because often you would need to manipulate the image and then see what was the outcome of the manipulation. Before we do any manipulation, let's just understand how we can show and hide images. So if I don't do this, if you notice this, it will run, but before I can click on it, it will almost disappear. That's because we did not give something called a cv2.wait key. So what this does is that wait key basically holds the pop-up for us, where we are saying that hey, so don't concentrate on the zero. We can basically pass it any key that is available on the keyboard, any letter or key, and we can say that hey, when this is pressed, then sort of close the window. So it waits on our key input. If we don't give that, if we give the value of 0, then it will wait indefinitely for any key. So 0 is for any key, not for the 0. So let's run this and see what we get. So we got the penguin image, but this has now been opened through Python. Okay, this is not opened by your regular image viewer. This is something that we have opened through Python. Next, what we can do is that we can resize this image. So what option we have available to us is that, okay, let me remove this first. We can take the original image over here and we can call the resize method on it. The second thing needs to be the shape of the image. So what we're going to do is that we have the image shape as 768, right? We just want to half it. So let's call those two height and the width and divide it by 2 here. And then let's show the image. So we're going to now show the resized image. So as you can see, the image is now resized. And okay, this is a very neat feature. Okay, now I was telling you that the computer views it as a pixel values. So if you notice, the more I zoom into it, because I've opened it in the Python window and not the regular window, you would not see this in the regular window. You can actually see what the pixel values are as you zoom into a region. So for white, you can see that almost all of them are equivalent for white regions. If you go to something really, really white over here, right, you can even see that it is showing up here. So this is really, really white, almost clearly white, snow white, right? Or water. This may be water. But if you look at this, it's not so equal. If you look at black, it's almost like all values are almost going to 0. You can zoom in as well. Yeah. There is also the write operation available to us where we can write the image permanently to file. So where I don't need to show this or even this, I can just resize the image. We call this and let's run this. And we have the output here. This is a resized image now. It's half the width. It's not 1024 anymore. 768 has also been halved to 384.
Next, let's look at face detection using OpenCV and Python. So here are the steps required to do face detection using OpenCV. The first thing that we're going to do is we're going to use something called as a cascade classifier. Now, the cascade classifier is basically a data set which previous researchers and programmers have developed before us, which kind of helps the computer or helps OpenCV in identifying a face as a face. Now, of course, there are multiple kinds of classifiers depending on the logic, but cascade classifier is one of the most common and popular ones. This is going to be the step one, step which is going to train the computer essentially to identify face as a face. You can also think about this as something related to machine learning because essentially the computer is going to learn through the cascade classifier into a human face looks like, but we are not going to go into the machine learning part of it. For now, we are just going to understand that this is an application of machine learning, and that is where the cascade classifier is coming from. Step number two is that we are going to use OpenCV to read the image into a NumPy array. Okay, and using the classifier, we are going to determine the range of values, the pixel values, which are forming the face. So if you look at this, step three, we are drawing the rectangle that you see typically in cameras or on Facebook, where it would detect the faces and it would encircle them, right? So the way this is going to happen is that the cascade classifier and the NumPy array, we're going to use them to detect which pixels in a given image are sort of approximately can be the outline of a human face. So let's look at the code. So the first thing that I'm going to do, I'm going to use the Cascade classifier object. Now this comes straight out of Cascade CV2 in itself. This is present as a class. It takes an argument which is a path to an XML file, which is present over here. So let me just open it for you in a second. Now this is a heavy file, so it might not make a lot of sense to you right now, which is okay. You can think of this more like training data by which you're teaching the machine that, hey, based on these random numbers, you can sort of classify a particular set of pixels as a face or not a face. The internals of how that they work have been utilized inside the library OpenCV. Of course, you can look into it, you can dive deeper into how this exactly works, but then you really need to think about if you want to. So this is how it works in the industry, where if something is working out of the box for us, where we don't have to know the internals of it because the way it is working out of the box is working really well, then we don't dive deeper into it unless and until it stops working well. So tomorrow, if you want to identify not human faces but let's suppose faces of monkeys or birds or something else, then you might start diving deeper into, hey, how is this exactly working? But if today we talk about that, hey, we want to quickly build something which will identify human faces, what these libraries do is that, I mean, we could spend, so to write a classifier by yourself, for example, would take anywhere between 6 to 12 months. Now imagine if you had to do that for writing us something which is so common these days, right? So that is where we don't reinvent the wheel. It has already been done. We just start using it. This is now saving the instance returned by this class in the face cascade object. Next, I'm going to read the file, which is this particular file, photo.jpg. So it is the same file as is shown on the slide of this actress. Okay, let me see if I can zoom out. As you can see, this is the image. Next, I'm going to convert this image into a grayscale image because that is when a classifier works somewhat better than with a non-grayscale image. Next, we can find the coordinates of the faces by calling the detect multiscale method on face cascade. The first parameter is going to be of the grayscale image. Another parameter is the scale factor and then minimum neighbors. And then we can just print the faces. Let's see what value we get by printing the faces. So if you see, we have gotten certain coordinates. So these are essentially pixels. These are the four corners that have been given to us by the detect multiscale method. Now the scale factor is basically decreases the shape value by 5% until the face is found. The smaller this value, the greater is the accuracy. So what we are doing is that if you look at this image over here, we are reducing the value of the shape. So the value of the shape being the rectangular coordinates. We are decreasing the value of the shape by 5%. The reason to do this is that it gives us a greater accuracy. Otherwise, let's suppose if we were not to do this. Let me just note these values down. So we got these coordinates, right? Let's try it out without a scale factor. Okay, I think we need to give a scale factor of greater than 0. So let's give it a scale factor of 0, 1. Now, if you look at this, the accuracy is not that great. Like it has given us a range of possible values because it was only 1% reduction. So the output is different this time. Like the numbers are different. So now it is not so sure about where the face is. So the scale factor greatly matters because it will decrease the value of the shape that it is trying to detect by the percentage. So the percentage 5% of course is coming from 1.05 until the face is found. The smaller this value, the greater is the accuracy. But it will also take a larger amount of time. Next, now that we have gotten the faces, the array, let's try to add the rectangular block. For this, very simple. We just iterate over what faces returns to us and we use cv2.rectangle method to draw a rectangle. The way this works is that you pass in the image, you tell it that x comma y is where you want to start off with, and then x plus w and x plus h, basically these are the other corners of the rectangle, and then you pass it the color that you want and other things. So RGB value of the rectangular outline and the width of the rectangle, and these form the x and the y coordinate, right? The 4 points that you want to draw on. Finally, we will resize the image a little bit and we will show the image. So let's take it for a run. So if you notice, we have drawn a, and if you notice the coordinates, they would be somewhere matching the ones that you got. Let's try again with a increased value of the scale factor. Let's see what we get, right? So this time, if you notice that because it was so high, there's no horizontal bound. We just got like, okay, this is the vertical bound where the face might be in. So the accuracy isn't that great with a larger percentage of reduction. If we increase this to 1.20, let's see what the output will be like. Okay, we got slightly better results, but now there is no lower bound. So of course, now these are more like tweaking parameters. You can try out different values to get the kind of results that you want depending on the image. And of course, not everybody is going to have the same kind of image set. Like the data set that you're going to get is going to vary in terms of the problem statement. You might just be getting very simple data set, which might be just, the typical passport size photographs, which are not too difficult to deal with. Or you might be getting something a little more complicated like CCTV footage, or something which is posted on social media. So there are various things to play around with. So it's not just that you write these 5-6 lines of code and you have written something which like is that easy. So I know it looks easy right now, but when you start dealing with the real world scenario of applying it in actual application, that is where you will be faced with certain practical challenges where the image might not be that great, or it might have certain other things, it might have noise. Because this time if you look at this image, right, it's a perfect image, it's a very good image to do this analysis on, but it's a very front facing image. But what if the image was turned to the side? Next, let's talk about capturing video works and using the computer webcam. So the way video capture works is that it captures the images one by one after the other, and just puts them in sequence. So because the images are put in sequence and they're continuous one after the other, they seem like video. Some of you might remember the principle of physics called as persistence of image, where images which are repeated at a rate of faster than 1/16th of a second, they appear to blend together. So if you look at this, right, actually these are 4 slides. But if I'm repeating them fast enough, you will get a sense of as if this particular person is moving, but they're just static images. This is, for example, slide 1, slide 2, slide 3, slide 4. But if I recurse through it really, really fast, I can make it seem like a moving image, right? While everything else remains same. So keeping that principle in mind, we're going to write a loop which is going to give us each of the individual frames of the image that we're looking to capture, and using that we would be able to do some sort of image processing, or we would be able to process the video in some format or the other. The way capturing video works is that we first start with importing CV2 obviously. Next we call the video capture method on it. Now we can either give it a path to a video file or use numbers. The numbers specify which webcam we would be using. So 0 stands for the primary webcam that is present on your laptop or your desktop. So typically you can give it a value of 0, or you can give it a path of any other video file that you have on your laptop. Now the next line of code here is video.release. This is very important to remember to kind of release the camera, because when you're capturing the video, right, it's sort of a CPU intensive operation. It takes up a lot of CPU and a lot of computer's RAM. So please make sure that when you're writing these programs, you're releasing the video properly. Otherwise, if any other script or any other code is running on your laptop or on your computer or on your server, it might just not get released, and that might become a problem and might crash your server or your laptop. Now, 0 is for the built-in camera, that is the primary camera. If you have external cameras attached, you can put 1 to use that. And if you have multiple external cameras for some reason, you can keep just adding the number one after the other. So let's go ahead and execute the code and see what happens. So I have it written over here. Actually, okay. So I imported CV2. I'm doing a video capture. Let me comment this and then run this to see if we can actually start capturing the video. So nothing much happened because we hadn't actually, done anything with the capture. So one thing that you would notice if you're doing this by yourself is that the cam light will turn on if you're capturing the video, and then it will turn off for a split second. To notice it for a longer duration, let's go ahead and add time delay using the time mod. So this is just to confirm to yourself that, hey, this Python code is actually able to turn on the camera on your device. Now, of course, you cannot see it because you would see that the camera light will turn on for 3 seconds now instead of, just immediate quickly turning on, turning off. Now, let's do a little more interesting. Let's add a window that shows the video. So for this, what we're going to do is we are going to call the video.read method. Okay, we're going to call the video.read method. What it returns to us is it returns two things. One is a boolean data type, which is true if Python is able to read the video capture object. So in case, let's suppose the camera is faulty or there's some problem with the file that you're reading, this will of course return false. So this is a quick check to see whether you have got the frame correctly or not. The second one is a frame, which is nothing but an image. So it is a NumPy array. It represents the first image that the video captures. Let's print the check. Let's do time.sleep for 3 seconds, and then let's call video.release. Let's run this. So you can see that we got a NumPy array. Now, yeah, it's 000, not to bother about that, but like, so we don't care about the exact values. It would be representing the image for sure that it is capturing. So this is the kind of output that we got, correct? Next, what we can do is that we can show the frame that is being captured. How do we do this? So for that, we can call the IMShow method, and we'll name the windows capturing video frame, and we'll pass it the frame. Why can we pass it the frame even if it's an image show method? Because the frame is nothing but an image. It's a NumPy array representing an image. We're also going to add the wait key method so that now it doesn't disappear all by itself, and it waits for us to kind of release it instead of it getting shut off by itself. And you also need to call the cv2.destroy all windows method. Let's run this. So the very first frame is going to be blank. That's just how it typically tends to be. Let's try and see if we can. Let's see if we can get a different result. Placing this over here and then going into a sleep mode. Okay, still black. Not to bother, but this is sort of the very first frame as the video camera is turning on. So if you notice over here, there's a slight whitishness, right? This is just from the camera getting turned on. But once we complete this entire project, we will be able to actually see the image that is being captured. Now, the next question is how to capture the video instead of the first image frame of the video. Because the first image frame is not very interesting, it's all just black. Let's try to capture the entire video. So for this, we are going to utilize a while loop, and we are going to iterate over each and every frame using this while loop. So I have already prepared over here. In the while loop, we're going to check for the true condition, which is going to make it run indefinitely. So why are we making it run indefinitely? Because we don't want to say that, okay, the video will be 3 minutes in length or 5 minutes or 5 hours in length, right? We don't know that. So we're just going to start with, hey, let's just run this, and we are going to come out of the loop using something else. So we are going to get the frame over here as we were till now, right? Next, we are going to cover it into grayscale. Then we'll start showing this over here. So that is there because it's the entire project that we are building, but let us understand things piece by piece as well. So we're going to add a wait key, and then if the key is equal to, we're going to set it to, let's suppose, Q. So if you press the Q key, you just want to break out of it. So this is how we're going to break out of this loop. And outside this while loop, we're going to go ahead and do video.release and and cv2.destroy all windows. So let's try and run this. Okay, now we are able to capture it because now this is inside the while loop. It's running constantly, and if you notice, this is my finger, and now it's not blank anymore. So that was just because it was a first frame, and first frame is always going to be black because we are turning it on, and like in that split second, it's just an image. So it turns out to be black, and slowly it just starts capturing, gathering all the light. That's just how the camera works, right? Okay, let's quit it. So I pressed the Q key and it disappeared and the process finished. So we are going to try and use this to build a motion detector. Let's look at the problem statement. Now the task is that given that we have a video stream from a webcam, we have to detect motion or any movement in front of it, and we have to return a graph. It should contain how long the human or the object was in front of the camera. Okay, and each bar of the graph should represent the time span, and each gap like this should represent when there was nobody in front of the camera. Let's look at the logic. What we're going to do is that we're going to save the initial image in a frame, and we're going to convert into Gaussian blur image, which is just a more manipulable image, which is just a more convenient way of doing it. We're going to take the frame of the object and convert it into Gaussian blur, and we're going to calculate the difference between the first and the second frame. So we're going to do this repeatedly for each and every frame that we're capturing. So each and every frame we bring each and every image. So we're going to do this over and over and over again. Now
we are going to define a threshold to remove the shadows and other noises. I'll show you how we will do this. So in case there is a shadow or there is some other thing like a flickering light, that shouldn't be counted, right? Let's suppose you're capturing a video stream through a CCTV camera and one of the light gets flickered or it gets turned on or off. But that shouldn't basically be counted as a motion, right? And that can be counted as a motion because we are working with the fact that any changes in the frame, so we are saying that, hey, this is an image, and any changes in this image should be counted as a motion. That's the simple logic that we are working with. Now, if there is any change in that due to light or sunlight or sunset or something of that sort, like any sort of immediate change, we need to factor that out. So that is why we'll define a threshold. We're going to define the borders of the object. We're going to add a rectangular box around the object and calculate the time when object appears and exists in the frame. Other thing that we're going to do is that wherever there is a new object, we're going to identify any new object that appears in front of the frame or in our frame. We're going to identify it and we're going to add a rectangular box around the object and we're going to calculate the time when the object appears and exits the frame. So we have already done the part where we convert into grayscale. From grayscale, we can convert it into Gaussian blur. Let's do that. So I'm going to add this line over here. Now convert it into Gaussian blur. Next, we also need to check for the first frame. So we're going to define a first frame object outside as none. So to make sure that we don't trigger a change. So if you notice the first frame was blank, right? If it is the first frame, we might get a motion detection just for turning the camera on. Naturally, we don't want that. So let's add that condition that if it is the first frame, let's change it to be this current frame and continue. So we're going to not count the first frame. So first frame of when the camera is turned on as a motion detection, we're just going to ignore it. This is basically us ignoring the first black, setting it. Okay, now let's go through it line by line. Delta frame. Now we're going to calculate the absolute difference between the first frame. Delta frame is just going to give us the difference in the two images. So this gives us the difference in the two images. So there is the first frame and there is the current frame. Gray is the current frame. Now the first frame will of course keep on changing from time to time. We're going to, as you will notice, as you go through the code, we're going to change this first frame as well as we loop over the entire thing. Next, we are going to build a threshold as we mentioned. Now what this will do is that it will convert the difference value with less than 30 to black, which means that any difference value with less than 30 in this delta frame, so we're going to pass it the delta frame, any difference of less than 30 in intensity, it is going to convert it to black. If the difference is greater than 30, it will convert those pixels to white. After that, we're going to call the dilate method on it. So dilate, as the literal word meaning goes, it expands. So it will expand the particular areas that we have found on the threshold frame. So what the threshold frame does is it discounts for the shadows and the light flickering and all of those kind of things by minimizing the effect. So by converting them to black. So what this will do is that if there is a shadow, it will basically convert it into black on our threshold frame. And what the next step this dilate frame is going to do is that it's going to zoom into those threshold frame which has been refactored, which has been cleaned out of all the noise and the random signals. Next, we want to find out the different contours in our image. We do it using the cv2.findContours object. As you can see, cv2 has a lot of these methods right out of the box. Now you may wonder how you would do it if you were not so familiar with the library. Okay, how is it that I just, like, from my end, I just know all of these methods? So it's not something which happens overnight. It's the same thing, like you Google, you research, you read through the library documentation, you figure out, hey, what does this method do, what does this method do, and you figure your way around. Now I would basically say that it is better that I leave this part up to you, where you explore it out on your own. And in case you get stuck, please reach out to support. They will definitely help you out in terms of understanding these lines individually. But really, the better way to do this is to read the documentation in depth, in detail, and try to understand it from there, play around with it, and see what you can get. Next is that for any contours which are less than a certain dimension, we're going to remove them out. So let's do that as well. So where we add a condition, so we're going to get multiple contours because it can identify multiple things in a given image, right? So we are going to say that, hey, if it is less than 1000, You just continue on to the next thing. You just continue on to the next thing. Otherwise, we're going to build a rectangle for ourselves where this CV2 dot rectangle is going to build a rectangle around the object that it has identified. So contour is the object. Think about CNTS as multiple objects. Any object which is less than 1000, ignore it. Otherwise, identify it. Place a rectangular around it. Okay, place a rectangle around it. I'll just show it to you in practice as well. Next, we are going to show the images that we are capturing. So we're going to show the different frames. So you can see what the delta frame looks like, what the threshold frame looks like, and what the original frame looks like. Let me run this and let's see what we get. So what will happen is that a bunch of frames will open up if you notice. So this is the delta frame. If you notice, it has a Gaussian blur to it. It is looking a little grainy because it just makes it a little easier to process data that way. This is just the grayed out version of the original frame, right? This is the original color frame. This is what we are capturing. This is the grayed out version of it. And this is the delta version of it. Let's look at the threshold frame. Yeah, here it is. So yeah, now this is the most interesting one. So if you look at the threshold frame right here, this is where it dilates, where we are converting it into black or white. So it is just identifying objects. If you notice, this over here is an object. Now I'll move my finger in front of the camera. This is my finger, okay, right now. Okay, let's look at the original color frame and this one side by side. So this is my finger, or this is my hand. Okay, this might be a better way to do it. If you notice, the threshold frame is counting for certain values, right? So as we sort of saw over here, it will take the delta when the motion is not happening. So when my hand was static, it was looking white, but when I was moving it, if you notice, that is when it was converting it into black or white. So it really is focused on the difference. It is not about painting the object, but it's more about looking at the difference on the contours and taking it from there. As always, we have the wait key and we can destroy the windows. Now let's try to calculate the time for which the object was in front of the camera. For this, what we're going to do is that we're going to define a data frame with columns start and end at the very top of our program. So let's do that. Let's take the data frame, define it over here. And next we're going to set a status. So status is going to be 0 initially because we have just started recording and there is nothing. So the first status is going to be 0. And when the object is detected, that is when it is, the contour is not, the contour is greater than 1000 in length, in height, in the contour area, we're going to set the status as 1. We are also going to use something called as a status list. Now what is the status list going to do? Status list is initially going to contain, is just going to be an array of 2 items, none and none. And we are going to append to the status list every time after the for loop finishes, where if it has detected something of a motion in that particular frame, it will append. So this could be 0 or this could be 1 for that frame. Next, we're going to take the last 2 values of the status list array because we are just concerned with the motion that happened. Okay, we are not concerned with the previous motion, we are just looking at the past motion. So we are collecting all the previous motions separately, but for this current scenario, we are just concerned with keeping the length of the array to be of 2 values, none and none. We're going to slice it and we're going to capture that. Next, we're going to add a condition. The condition would be that, yeah, so if the status list previously was 1 and now it is 0, or it was previously 0 and now it is 1, then we're going to take this times array. Okay, we're going to take this times array. Let me define it over here, which is going to be an empty array first, and we're going to add that, hey, at this particular time there was a motion that happened. So either one. So this is basically counting for a status change from a previous frame to a current frame. And then finally, we are going to record all of these changes over here like this. So what we can do is finally that we can iterate over the times that we have collected, and we can write it to a CSV file. So let me take this for a run so that we have some data in our CSV file. Go. Right, so let me take the original color frame. If you notice, my finger would be recognized as an object. Okay, and yeah, so this should give us enough data for movement. So let's see what times.csv has. Okay, it seems to be empty. Let's sort of run it once again and see what we can get. Might have been some bug. Let me try to just move it a little more. Okay, Right. Let's see if we get something now. So yeah, if you notice, now we have the time over here, the start and the end time in our times.csv. So we have two instances of movement that we captured quickly. One is this and the other one is this. So we have actually detected motion. Now we can actually go ahead and plot this. So the video part or the capturing part is done. All we need to do now is just go ahead and plot this on a plot using bokeh. For this, we are going to use bokeh, and we're converting the time to a string format first and foremost. So that is over here. So let's first import bokeh and then convert the time. So just so that it's pretty, because if you notice over here, it's written like this, right? It's not very human readable. Let's convert it into a more readable format. And next we're going to use the column data source, data frame, to pass it the data frame. And as we have been learning till now, we're just going to use the same methods that we have been learning about bokeh, and we're going to plot this. So we're going to create a figure. X-axis is going to be a date time, height of 100, width of 500. The title will be motion graph. So we're going to set the text or the markings. We're going to set the tool tips. We're going to add the tools, and then we're going to take the plot. We're going to mark the quadrants, and we're going to set the output file as graph. Let's run this and see what we get. So once I quit the camera, so now we have got a bokeh plot, right? As expected. So you have to quit the camera. Please keep that in mind. You can actually, run it in two different files. You can just, because you were mapping it in times.csv, you could just do it in different files. Just get times.csv first and then run it over here. But if you notice, now I've got the start and the end, and it says, okay, for 30 seconds or 25 seconds, we got this motion, and we have the output file over here as well, graph1.html. So of course, you will not get an exactly same graph. It depends on what kind of a motion you do in front of the camera. Thank you. Thank you so much.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!